everyone, and welcome to this video in which we will understand what data engineering is. The world in general has been continuously evolving around the data. Organizations have realized how valuable an asset data can be and how it can manipulate key business decisions, or at least that was the expectation. But back in 2017, Gartner's report stated that 85% of big data projects failed. One of the most important factors leading to this was the available data infrastructure was not reliable enough to make business decisions. According to the CTO of IBM in 2019, 87% of data science projects could never make it into production. Why is that? If data is so valuable and most decisions can be made using the data available, then why were so many data projects failing? Well, we are moving towards a world where we will be producing 435 exabytes of data per day. To put that in perspective, that's 1 followed by 18 bytes worth of data. This is where data engineers come into picture. Earlier, data scientists were expected to structure, source, and build pipelines for data. These tasks were often out of data scientists' scope of work or their skill set. The result was that data modeling would not be done correctly. There would be a redundant work and inconsistency in the use of data among data scientists. These kind of issues prevented companies from being able to extract optimal value from their data projects, so they failed. Eventually, more and more organizations began to realize the need of professionals who can transform and transport data in such a way that by the time it reaches an end user like data scientists, they are in highly usable format. Data pipelines are created by data engineers and they are used to build a warehouse of data collected from different sources and used across the entire organization. Data engineering came to be described a kind of software engineering that focused deeply on data infrastructure, data warehousing, data mining, data modeling, data crunching, and metadata management. Data engineers work in a variety of settings to build systems that collect, manage, and convert raw data into usable information for data scientists and business analysts to interpret. Their ultimate goal is to make data accessible so that organizations can use it to evaluate and optimize their performance. While data scientists are highly skilled in maths and statistics, R algorithms, and machine learning techniques, data engineers are more versed in SQL, MySQL, and NoSQL architecture and cloud technologies and frameworks such as Agile and Scrum. LinkedIn's 2020 Emerging Jobs Report and Hired's 2019 State of Software Engineers Report ranked data engineer jobs right up there with the data scientist and machine learning engineer. Although there is no such exhaustive list of skills required for becoming a data engineer, but there are a few that have remained in demand ever since. Some of them are knowledge of programming languages like SQL, Python, R, hands-on expertise in relational and no relational database, knowledge of ETL systems, knowledge of data warehousing. Tools such as Apache, Kafka, Spark, and Hadoop add a lot of weightage to your skill set. And last but not the least, cloud computing technologies such as Azure, AWS, or GCP. So that's all for this video. Hope you have understood what is data engineer and how it is different from data scientist, and also what skills are required to be a data engineer.
Hello everyone and welcome to today's session on Data Engineering Full Course by Intellipaat. You know, it's pretty difficult to do any data science without the data engineers being there to support this function. Now, there is a frequent collaboration between data engineers and data scientists. However, the priority skills and the knowledge of tools vary. I'm sure you all might be having a lot of questions regarding data engineering. So, without any further wait, let's directly ask the expert. So joining here with us today is Suyash, who is an expert on data engineering. Hi Suyash.
Hi Dev.
So tell us Suyash, what exactly is data engineering?
Okay, so basically data engineering helps make data more useful and accessible for consumers of data. It's now widely recognized that companies need both data scientists and data engineers in an advanced analytics. To learn data engineering is basically, it is difficult to define precisely. Okay, so it is basically about the designing and building the data infrastructure needed to collect, clean, and format data, making it accessible and useful for the end users.
Okay, that was a precise explanation. Now tell us Suyash, what exactly is the difference between a data scientist and a data engineer?
Okay, So basically, data engineers are the ones that prepare the data from raw data, which is basically unformatted, and it may include like human errors or the machine errors. Okay. So a data scientist works on the data which is provided by the data engineer. A data scientist is dependent on a data engineer, basically. A data scientist analyzes the data and gives insight as to how the company should work based on that particular data analysis.
Okay, that was a good answer. So, Suyash, could you please throw some light on the various career prospects and job prospects regarding this data engineering?
Okay, sure. So basically, after a huge influx of data scientists, companies realize that they need proper data infrastructure to perform any meaningful analysis on data. Companies have even started to spend money on proper cloud infrastructure, data architecture, and even hiring new data engineer talents. One solid proof of demand for data engineers is the growth in big data. If you have been living under a rock, data is the new oil. So basically, new data is being generated every day and it will continue to grow as well. With the insane amount of data, there will be an increase in the demand for engineers to handle the data. Another giveaway is the growth of big data engineering services provided by consulting firms like Accenture and other tech companies like Cognizant. With the increase in data, proper data engineering services is also increasing.
Okay, that seems like data engineering is in good demands right now.
Absolutely.
Well, thank you so much, Suyash, for answering all those questions of mine in a great detail.
You're welcome, Dave. So basically, this is just the tip of the iceberg. We'll be learning the complete data engineering process in this whole course.
That's great. So, without any more wait, let us get to our today's agenda. So, before we move on to our session, please make sure that you are subscribing to our YouTube channel.
And hit the bell icon for more updates from Intellipaat. Now let's start the session.
What is really big data means for us, and what is Hadoop, and relation between these two actually. So it's not something data is exist now. So it is there from beginning, almost 20, 30 years onwards, the data is there. But all of a sudden, people and a lot of organizations started discussing, a lot of discussions are going on the big data. So what is the meaning of big data means for us? So before I take you in depth about the big data, first of all, you have to understand a little bit about the data. So what is data? So probably you can think on that. What is data all about? Data is nothing but collection of some information, right? Anything. If you are keeping some information together, then you can call that one as a data, right? Data or data set actually. So when you are going to see the data, how you are going to see the data or data sets? Basically, from different data sources, you're going to see the data set. Just forget about the big data definition. So I'm just going through about the data set actually. So now data sets will be generated or data will be created out of the data sources basically. So you can just take the simple example, this Zoom. Zoom is one of the data source where we are seeing a lot of data will be generated behind the screens. So how we are discussing the audio, the video, the statistics, and the network, and who joined at what time, who left what time, all these things will be captured behind the screens actually. So that is all about the data set actually. Data sources are the one who is going to generate the data. Without data source, there is no data actually in this world. Very clear statement. Without data sources, there is no data. Everything, your cell phone is a data source, your personal computer is a data source, your YouTube is a data source, data is a data source, right? Social networks, probably Facebook or Twitter or anything, right? And also a transport data, right? YouTube data, satellite data, right? And also stock exchange data. All these are going to be the data sources actually, right? So data sources are the one who is going to generate the data actually. So Ajay says, what is data set example, right? So for example, right? So you went to the market and to vegetable market or probably to grocery, and you got some items, right? and he's going to print a bill for you with a list of items and their amount, right? That is a data indirectly, right? So the data you are going to maintain in a simple in a computer world in terms of data set actually. If you are maintaining, earlier we used to maintain the data in the documents, nowadays we are maintaining the data using computers as a in terms of data sets actually. Collection of some data if you are maintaining in your computers, that is all about your data sets actually. Legacy systems, right? Or traditional techniques. So using these things, we can really maintain the data actually. So these notes will be shared as a class notes, friends. You don't have to write down or you don't have to be busy taking the notes throughout our discussion. All you have to concentrate on my screen because everything will be shared with you. Okay, whatever I am showing on my screen, except paints, where we are going to use here and there paints also, except that we are going to share everything with you actually. So now let's go ahead and see definitely legacy systems, right? So one of the widely used in terms of data, it's mainframes, .NET, right? Or Java, it's one of the widely used RDB, MSDBs, right? Or any ETL tools, right? etc. So using this, you can maintain the data actually. So these are really well matured systems, friends, from beginning, and you don't have to worry about to maintain the data. But how far they can maintain the data? Maximum terabytes of data they can maintain, because when they designed the systems, they thought they are going to see maximum terabytes of data. That's how these tools were designed, and there is no question at all. When you are seeing the terabytes of data from your data sources, these systems are excellent systems actually. But now definitely you see, are you seeing only the maximum terabytes of data? No, we are going to see petabytes of data, which means 1024 terabytes equal to 1 petabytes, exabytes of data, zettabytes of data, yottabytes of data, etc. You started seeing this much of data from our data sources. But when you see this much of data from your data sources, but when you are trying to manage this much of data using these existing systems or traditional techniques where they are not able to tolerate your data, then they can start calling the data set is a big data. So what is that? Big data, it is a data set only, right? But this data set, we are not able to manage using the existing techniques actually, because it's a huge volume of data. It is beyond their storage capacity, beyond their processing capacity. So that is the reason they are not able to really tolerate the data actually. Clear? Big data, probably you might have thought you are going to learn as a language, as a technology, as something else, but you are not going to do anything with that. Simply big data is nothing but it's a data set only. It's a collection of some meaningful information, but using your existing systems, you are not able to really manage it actually. Clear? So that is all about the big data. When your existing systems are overloaded, simply you can call your data as a big data. That is as simple as that actually. So using your existing systems, we are not able to tolerate your data. Definitely we have to think the alternatives. We have to introduce the alternative for the big data actually. So now how we are going to do it? Let's go ahead and see one by one actually. So as you can understand here, right, there are many systems were born to handle your big data. So it's not a single uh, system or framework that was born to handle your big data. There were many systems were born in this market to really just address your big data related issues. So one of them is going to be the Hadoop, right? And also you see Spark, and also you can see HBase, MongoDB, right? etc. These are the frameworks which were born to really understand, to address your big data related issues actually. So what are the big data related issues? Basically, storage one, big data issues. There are two issues basically, right? Storage related issue, processing related issue. So these are the two issues that you have to understand, that you have to address whatever you're going to introduce actually. So what is big data? I mean, what is Hadoop basically? Hadoop is only it was born to address your big data related issues. Hadoop is going to address your storage related issues out of your big data. Hadoop is going to address the processing related issues out of your big data. Hadoop can manage both the things. So now let's go ahead and see how we are going to really, right, process, how we are going to store the data, how we are going to process the data using Hadoop. What is the specialty with the Hadoop than you're comparing your legacy systems actually, right? Before that, let me introduce about the big data definition from IBM side using 5Vs actually. So very, very important thing. I don't want to miss that one because most of the interviewer is going to ask those questions. So what is big data definition using 5Vs actually? Let me pull that documentation. So I'm going to share this one with you. So very simple, 5Vs means volume, velocity, variety, veracity, and value. That's how nicely they are calling as a 5Vs and 4Vs and 3Vs and all. So you don't have to worry. So all you have to understand about what is each V means. Then how we are going to leverage this each V definition to define your big data. We are going to see one by one actually. So let's see. So what is volume of data? Volume of data is nothing but simply the amount of data that you add from your data source to warehouse actually. So if you take any example, right, you are going to add some amount of data actually. So you're going to add some amount of data, and you're going to see some amount of data, and you're going to see that will be retained somewhere else actually. You're going to you see some amount of data from your data source, probably you can think of Amazon, and you are retaining somewhere else in the warehouse actually. So now you are trying to really just dump the data from here to here. So whatever the volume, whatever the amount it is, but you are going to retain the data. So let's understand volume means. So volume is nothing but velocity, right? I mean, volume is nothing but amount of data that you are adding from your data source to warehouse. From this data source into your warehouse. Warehouse is nothing but it's a place. It's a common place where you're going to retain the data, that is called warehouse actually. Amount of data that you are adding from your data source to warehouse is called nothing but volume, right? That is the volume definition. The amount of data that you added from your data source to warehouse. It can be anything in size. It can be bytes, it can be MBs, it can be GBs, it can be petabytes also. So that is called volume. Velocity is nothing but at what frequency you are trying to add the data from your data source to warehouse. So for example, you are seeing around 4 terabytes of data here. This 4 terabytes of data is being added at what frequency? How long your data source has taken to add this 4 terabytes of data? Is it taken a month, a week, and a year, in a month? So that's what your velocity means. At what frequency you're trying to add the data. It can be a day, it can be a month, it can be a year, it can be 10 years actually. So that is all about the frequency of adding your data actually. That is velocity. You know volume, you know velocity. The third thing is variety of data, right? So order does not matter, friends. All you have to understand each V means. So variety means, as the name says, variety, different forms of the data actually. So in this data world, right, if you take any data, that has to be categorized into one of these three ways: structured data, unstructured data, and semi-structured data. As the name says, structured, your data is been well organized in your data set. That's how we will be calling as a structured one. Unstructured, there is no structure at all, right? Your paint is unstructured data, your image is unstructured data, your audio file, video file, everything is unstructured. There is no structure, right? Binary format completely, right? That is unstructured. We know very well about the structured and unstructured. So what about this semi-structured? So half of the data, as the name says semi, half of the data, your data has been just structured, and rest of the data is not been structured actually. So you have to really process that unstructured data to make it as a structured one actually, right? To make it as a structured one. That is about the semi-structured actually. Your XMLs, JSONs, where we are going to use in our application. So where data exchange can be happen more frequently using your XMLs. And we are going to see more about the XMLs. You don't have to worry about that in our big data world, Hadoop world. So XML is all about the parent and child tags. We are going to see down the line how they are going to be working actually. Okay, that is all about the right structured, unstructured, and semi-structured. So we are going to see down the line how we are going to just leverage these definitions to define the big data. So we know structure, we know volume, we know velocity, we know variety. The next thing is veracity. So veracity is nothing but the accuracy of the data, right? So always there will be inconsistency, which means there is no accurate data you can see out of your whole data actually. If you collect, for example, right, 1 terabyte of data, 1 terabyte of data is not going to be the accurate data. You may see, right, some of the data is really, for example, if you're taking Amazon example only, or probably if you take any data, I mean, a exit polls are conducted in so and so city regarding the elections that has happened recently. So do you think all are going to be the accurate one? All the data that you see is the accurate one? No, some of them they just like that they submitted. Some of them they gave, they don't know anything what's going on. Some of them are not eligible, but they gave. But you see all data, but you have to separate it actually. That is called inconsistency. That is what accuracy of your data. Finding the accuracy is very, very important out of your data actually. So history says only the 70% of your data will be accurate actually. That is called veracity means. The next thing is value, right? So earlier we used to define using these 4 V's: volume, velocity, variety, veracity. So the next thing came here before I define the value. For example, if you see high in volume of data, high in velocity, high in variety, high in veracity. If these 4 characteristics are qualifying, then simply you can call that one as a big data. High in velocity, high in variety, high in volume, high in veracity. If these 4 characteristics are qualifying, then simply we used to call that one as a big data. But do you think if you are seeing this one, but if there is no value out of your data, do you think that that is going to be any value for your company? Right? It's as simple as that. Right? For example, you are maintaining a IT infrastructure and you are retaining so and so data from long time, but you are not using the data at all. But because of that data, your system is training. Because of that one, your system is straining actually. So do you think that is a big data for you? No, because unnecessarily there is no value out of your data, but still you're retaining the data for no use actually. So there is a reason if you are retaining the bulk data, definitely that should give some value, should have some meaning out of that data to give some value towards your company actually. That is called value. Volume, velocity, variety, veracity, and value actually. That is all about the 5 V's. So very, very important thing. We took ample time to discuss on this one. So that's all about the big data definition using 5 V's actually. So what is Hadoop really and how the Hadoop is going to work? So we have to understand very clearly. So Hadoop is a framework basically, and it's open source one also, right? So framework is nothing but, so you as a developer, framework developer, you don't have to start your application from scratch actually. Hardly you have to develop only the 60 to 70%. The rest of the things will not be developed by the this thing actually. Hadoop is a framework. Also it is a open source one. So open source is nothing but free to use actually. You don't have to pay any license cost actually for that actually. So that is a open source framework. Excellent. And it was born to address both big data issues, storage issue and processing issue actually. So now what is the specialty with the Hadoop? Why your Hadoop is able to handle your big data in an effective way comparing with your legacy systems? So the one of the important thing that you have to understand here is, right, Hadoop is going to, Hadoop was born very with very rich features friends. That is the reason Hadoop is able to really, right, address your big data related issues in an effective way actually. So Hadoop was born with the very rich features. One of them is going to the master slave architecture actually. Hadoop is going to follow the master slave architecture, which means Hadoop is going to work in a master slave architecture way. So which means master and slave. So indirectly, how the project manager and team member is going to work together within a team, the same way it's going to work. So this is the example always I give to all my participants, so that this example can be captured to understand most of the Hadoop concepts actually. So what is the project manager and team member? So very simple, very simple. Project manager is the one who is going to manage the team, right? Very clear. But why the team was born? What is the purpose of team? When you are working on your own, why you went with the team, right? That's what you have to understand very clearly. We went with the team because we went with the team because you are not able to really complete the work. You are not able to really satisfy your client on time for their work. That is the reason we went with the team actually. When your client is able to complete your work with you alone, then you are good. But the moment your client wanted to work to be done more from your end, but when you are not enough able to complete that, then you are going to say that, boss, I cannot complete. For example, if your client has assigned the work to complete in a day, but you are going to say that I'm going to take 15 days of time, then definitely, right, no way you can see your client is going to wait till that point of time. So for that reason only, definitely you have to understand team came into the picture, where team is going to work for you completely, where team is going to help you really to complete your task on time actually. So where you're going to see parallel, right, distribution, right? The distribution of the work is being done using the team actually. So which means instead of you alone working on top of your work, you're going to have the multiple people to work for your common task actually. So what is happen? So instead of you alone working, you are having 5 physical guys, 10 physical guys you are going to have, and you're going to complete that work actually, right? You have to understand that way. So when you go alone, when you work alone, you're going to take more time. But when you just work that same work with the 10 guys, definitely you're going to complete the work on time. You're going to take very, very less time to complete the work actually. So now that's how the team came into the picture. That's how you are going to just complete the work on time actually. So he's the project manager, right? And is going to be the team member one, team member two, team member three, something like that. You see, okay, that's how you are going to make sure these 10 team members are going to work for you to complete the work on time actually. Okay, so now let's see exactly, this is called master slave architecture. Master slave architecture is nothing but master is the one who is going to manage the team members actually. But one thing that you have to understand here, how the team members are going to be managed. Project manager is the one who is going to take care of the team members. All team members has to report back to the project manager. If one guy is not working, your project manager knows how to handle that one, and how the other team members are going to be working as a backups for the other team members. All these things in a team is going to work actually. The same way, Hadoop also is going to work for you actually. So here, each and every circle you have to understand is a computer. It's a machine actually. It's a node. It's a computer. All are going to represent the same thing. So what is happened here? Instead of you alone working or only single server, single computer, single node is going to work for you, you're going to have a multiple computers you kept together within the network, right? You pulled multiple computers to work within the network together towards the common task, right? So instead of you alone working, you pulled 10 computers, indirectly 11 computers you pulled here, right, including your master. You pulled the 11 computers together within the network, where they can work together, where they can talk each other. So that is called cluster actually. So team is equivalent to the cluster, master computer, and it's going to be the slave computers actually, slave machines, physical machines, friends. So how you are attending this meeting using your computer, so those kind of machines you are given 11 machines to build this cluster actually. So we are going to see down the line how we are going to build this cluster very clearly, we are going to see it. But 11 machines you kept together within the network to just build the, right, a cluster actually. So how they are going to help you out to really, we are going to see very clearly. In terms of storage, in terms of processing, how this Hadoop cluster is going to help you, we are going to see one by one. There is no limit to add the number of nodes to the cluster, number of machines to the cluster. If you want more storage capacity, simply go ahead and add. If you want more processing capacity, simply go ahead and add. So this is called horizontal scalability. You are scaling your system in a horizontal way, right? So that is one of the excellent feature out of the Hadoop. Hadoop is going to enable you to scale your system in a horizontal way. So for example, to really little bit elaborate that one, for example, you take the two organizations. One is Google, other one is for example, a small, probably your a banking sector. For example, if you are from India, let me give a simple example, any banking, ABC banking. So now you see your Google, whatever the infrastructure that is as, whatever the Google, you have the IT infrastructure, Google can manage, right? For example, forget about the Hadoop and all, existing infrastructure, whatever you have Google 15 years back, 20 years back, they can maintain, for example, 50 terabytes of data easily, right? Because the IT infrastructure that they have is really well matured one. They can maintain 50 terabytes of data in an easy way actually. But do you think the 50 terabytes of data can be managed easily by ABC organization from the banking sector? Because they did not think much about the data. They thought more about their business, not about the data. But Google has thought a lot of data is going to come because their business is that one. That's how they had the matured systems there. So that's how existing systems, whenever from the Google side, they see 50 terabytes of data is not a big data for them. But when you see the same 50 terabytes of data from ABC organization is going to be the lot of data actually. So your ABC organization can call that one as a big data, but your Google is not going to call that one as a big data actually. There is a difference when to call your data as a big data. Simply, whenever your existing systems are overloaded with the data that you see out of your organization, then you can simply call that data as a big data actually. So when extending horizontally, is it cost going to be increased as well? Yes. Instead of using one machine, you are as you are increasing horizontally, you're going to say one, two, three, four, something like that. You are increasing horizontally. Definitely, you're going to put a lot of efforts to buy these things actually, right? Definitely. Instead of buying one machine, if you're buying 10 machines, you have to spend 10 times actually. But you have to understand very clearly, Hadoop is going to claim that, right? They can use the commodity hardwares actually, cheap hardwares, general purpose hardwares actually. So when you go with the legacy side, for example, any MySQL server, right? So you cannot use the cheap hardwares there actually. General purpose hardware, whatever you use in your personal computer, these are the general purpose hardwares actually. So you cannot use them cheap hardwares there actually. You have to use the high reliable hardwares, right? When you go with the high reliable enterprise hardwares actually, you have to end up spending a lot of money to buy those enterprise hardwares actually. So cheap hardwares are the general purpose hardwares and you have to spend very less amount to buy them. So Hadoop is going to claim that, yes boss, you can use the cheap hardwares for me to build actually, because I have my own tolerate mechanisms. Best features is best tolerate mechanisms that I, where I can tolerate my data, where I can make sure my data is available more than one time. So that's how they came actually. Hadoop can use the commodity hardwares. One commodity, instead of buying one enterprise hardwares, you can buy 50, 60 commodity hardwares actually. There is a difference between the enterprise hardwares and commodity hardwares actually. So now how this is going to help you out to store your data. Let's go ahead and see one by one. So very simple. Hadoop is born to address your storage related issues and processing related issues. Let's go ahead and see how this is going to help you out. So very simple. So instead of one computer that you have, so right, in the legacy side, you have only one machine, right? You're going to maintain that complete thing using the single machine actually. And you're going to say standalone, individual machine. So now you see, for example, if you're having, right, 4 terabytes of data, you are going to see 4 terabytes of data will be managed by the single guy. So you are here, you are the client, and you're trying to use your legacy system. Then you are going to see 4 terabytes of data will be managed by the single guy. No way you can share it, right? You're going to just manage using the single guy. And when it's come to processing side also, right, you're going to see 4 terabytes of data will be managed by this guy actually. 4 terabytes of data will be managed by your single guy. In terms of processing also, single guy has to process actually. That is where it's taking more time, right? That is what the main issue with the legacy side. So now how this 4 terabytes of data will be handled by your Hadoop? Let's see that. So you are going to send the request to the team, and the team is going to, which means it's going to be notified to the project manager. So in the case, master computer is the one who is going to really notified, saying that yes, this is the work that I need to store. So now here in terms of storage, first initially we are going to see the storage, then after that I'm going to discuss about the processing side. So now you see 4 terabytes of data that we have. So for example, 4 terabytes of data that we have, I need to handle that one actually. So one thumb rule before that. So each and every machine hard drive, computer, you're going to have a hard drive. You know that your computer hard drive is how much, that much of data that you can store. So now I see 20 terabytes of data that you have, probably 32 terabytes of data that you have. 32 terabytes of data that we have each and every machine hard drive capacity. So 32 terabytes of hard drive is really huge actually. So to maintain the 4 terabytes of data, do you think 32 terabytes of data needed? So very simple. I can manage using this with the 4 terabytes of data I can manage, but that is the legacy way of managing your things actually. That is the legacy way of managing your these things. But how the Hadoop is going to do? So here one thumb rule that you can remember always, whenever you are going to store the data in the Hadoop cluster, Hadoop is going to divide the data into the chunks of data and distribute actually. He's not going to store your whole data together. Even though individual machine is enough capable to handle your whole data, your data will be divided and distributed actually. So what is the meaning of that actually? So now you see 4 terabytes of data, let's say we divide into the 4 parts. For our easy understanding purpose, I just said 4 parts, but does not mean that it's going to be the 4 parts actually, right? We can go very in-depth discussion how the division is going to happen. We are going to see down the line. You don't have to worry about that. A simple, a layman way, right? You don't know anything about Hadoop. So you simply have to understand my 4 terabytes of data is divided into the 4 chunks and it started distributing this way.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right? Your master computer is the one who has distributed one chunk here, one chunk here, and one chunk probably here, and one more chunk somewhere else here, actually. Probably here. Let's just keep one more here. So that many rules, whatever you are going to assume, but you can break them actually. Right, friend? You can see very clearly here, instead of just going and depending on single guy, you are distributing your work to the multiple guys. You have divided your data into the 4 chunks and you distribute it into the multiple guys. So now you see one chunk here, one chunk here. You don't have to really distribute sequentially. If you are distributing 1, 2, 3, it does not mean that 4, 5 has to be used. That's the reason I broke that rule. I left the data slave node 3, right? Slave computer 3, I left it. And the next thing is, when you are accepting one chunk from one file, does not mean that another chunk cannot be accepted from that file actually. You can, as long as you are having the bandwidth, those many chunks also you can accept from your main thing actually. So that is how you can see very clearly how your data distribution has happened actually. Instead of storing using the single machine, we are going to have the multiple machines for you actually. That is all about the how the data division is happened and distributed. This concept only we'll be calling as a Hadoop distributed file system. So we can call them as a HDFS, Hadoop distributed file system, to address the storage by issue actually. So we are good with the storage things. And the next thing is processing. So now definitely the processing is nothing but you as a user, you are going to send the logic. and also you're going to send your file name. That's all. This is my file name and I need to process this one. So this is the logic and this is the file name. So you as a user, you know this division, where your divisions, where these chunks have been distributed, which chunk is going to be really maintained by what and everything. Are you going to see this one really? The answer is definitely no, actually, right? So you as a user, you don't know anything. You don't have to know anything. All you have to understand, right, where the, I mean, what is my file name and what is the logic. So when I say logic, what you need to read out of that file, what you wanted to see out of your that file, actually, that is all about the logic, actually. So now that is how you send the master computer. Now master computer, so he is going to really check your chunks, whether it is accommodated by your slave 1, slave 2, slave 3, slave 4, something like that. So for example, if you take Yahoo, which is one of the biggest Hadoop cluster, right? 45,000 machines they added together. So do you think 45,000 machines that you have to scan to locate your data now? If that is the case, forget about the advantage that you see, but a lot of overload will happen, actually. But how you're going to see that? So one thing that you have to understand very clearly, so you are going to see at the time of storage, your project manager is going to maintain a log, right? Your project manager is going to maintain a log saying that, yes, my work has been distributed into this many guys, and these many guys are doing this one. And if anyone is requesting the work status, I need to go ahead and check with these guys. That's how he's going to maintain the log, right? Definitely. The same thing in Hadoop also, your master computer is going to maintain the a log. So we'll be calling that one as a metadata in our Hadoop terminology. That metadata is nothing but data about your data, information about your data. The real data is your your file that is being this guy, right? About this one, we are maintaining some information saying that my whole data has been divided into the 4 chunks. One chunk is there with the slave 1, other chunk is there with the slave 2, other chunk is there with the slave 4 and slave 5, 2 chunks. That's how that information will be maintained here, actually. The information will be maintained here. So this guy, right, the same thing, the moment your master computer is receiving any request to process, he's going to scan that metadata and is going to simply send the logic wherever the data exists, actually. So now, so here the request is being sent to this guy and this guy and this guy. That's all. So whichever the machines not involved, they don't have to work for this task, actually. Whoever is involved to accommodate your data, they have to work on top of your these things, actually. So now you see, so this is the data. Now you see slave computer 1, and this is the logic, and your master computer is going to assign the work to the slave to start working on top of this chunk alone. The same thing, this slave is going to work on top of this chunk alone. The same thing, this chunk is this slave is going to work on top of this chunk and also this chunk, actually. So that's how they start reporting the status back to the master computer, actually. So now master computer is the one who is going to consolidate the results and is going to report the status back to the client, actually. So what has done here, instead of just processing using the single guy, and as the data is being distributed the same way we started processing, actually. So we are going to see really in depth the concepts how the processing is going to happen, but at a high level, what has happened, where the data is being distributed, there only you started processing, actually. So this concept only will be calling as a map reduce. So map reduce is a programming model, right? It's a technique using which you can address the processing related issues, actually. Storage related issues will be addressed by your HDFS, and processing related issues will be addressed by your map reduce, actually. So now there are some ecosystems, right? These are core systems we can call core Hadoop core systems. If someone is asking what are the Hadoop core components means, these are core components. So you can get the ecosystems also, right? Ecosystems, but I'm going to define, we are going to learn pig. Pig is nothing but it's a scripting language, and it's an alternative to map reduce, actually, right? So we are going to see how that is going to be useful and all. It's a Latin scripts that we are going to use, scripting language, and using that we are going to really just alternate it to the map reduce, because map reduce is a framework, right? It's a technique, right? It's a framework, it's a technique. So we have to use Java or Python to develop actually. So Java or Python or Perl or Ruby also we can use it. To develop this, we have to use this case actually. But you have to understand very clearly. So MapReduce, right? It's a programming model using which you can process. But to develop that model, definitely you have to use Java kind of programming language. So now definitely you're going to ask me, do I need to know Java or Python to develop the MapReduce? Yes, right? We have to know definitely a Java, core Java, definitely you have to understand. Otherwise, there is no way you can develop the MapReduce. So that is the reason they develop the pig. So to avoid the writing your MapReduce using Java or Python, simply you write the pig scripts using Latin scripts. Very simple to understand, simple to really learn also. So you can just alternate the MapReduce. You don't have to know single Java if you know little bit Python actually. The same thing Hive. Hive is same as SQL. So the engineers who are from SQL background, Facebook thought like they should able to really come up and develop the Hive Hadoop application. So that's how they develop the Hive framework. Hive is same as SQL. If you know the SQL, then you know most of the Hive concepts actually. So these queries again, they are going to just use to alternate your MapReduce actually. You don't have to worry. So you know pig, you know Hive actually. We are going to see HBase also. HBase is nothing but NoSQL one. What I mean by NoSQL, not only SQL databases, there are different NoSQL databases are available. So using that, you can maintain. NoSQL specialty is nothing but you can maintain the billions of instructions in your table. So when it comes to big data world, using row oriented, right? Rows and columns, it is not easy to maintain that much of data. That is the reason, right? We go with the column oriented actually. NoSQL databases are the one of the column oriented database. We are going to see in depth about that, but you can maintain entire data using the single column. How and all we are going to discuss in depth in the HBase discussion. You don't have to worry about that. Okay. Then the next tool that we are going to discuss about the Scoop actually. So to import the data from RDB MS DBs to Hadoop world, we are going to use Scoop actually. SQL to Hadoop actually. Scoop is nothing but SQL to Hadoop. So really to import the data from RDBMS DBs to Hadoop, we are going to use Scoop actually. So Scoop, the same thing, Flume, right? Flume to import the streaming data from large log files into Hadoop side, we are going to use, right, Flume. So they both are data ingestion tools. To get the data from outside world into the Hadoop world, we are going to use these two things, Scoop and Flume, but they have their own different usage. We are going to really discuss down the line how we can use them in a different way. But a simple one-line statement, Scoop can use to get the data from our DBMS world, and Flume can be used to get the data from the streaming, definitely from large log files into the Hadoop actually. The last thing that we are going to discuss, Oozie. So Oozie is a scheduler actually. So to run your jobs in a particular pattern, right? If you take any organization, it's not something only one job that you're going to run. You have to run multiple jobs to really maintain your data actually. So for that, we use Oozie actually. Okay, so these are all about the ecosystems. We are going to discuss in depth about them as we proceed further. So now let's go ahead and discuss about the HDFS now. So HDFS, now we know very high level about the Hadoop cluster. It's a combination of multiple machines, and we are going to have master and slaves. Master is the one who is going to maintain the slaves, and slaves are the one who is going to report back to the master. We know very well. So this is going to be the master computer, and this is going to be the slave computer. Let me take this picture, just have in one more pen so that I can make use of that one for the. Okay, so let's proceed further. So how we are going to make use of this? So this is what your master computer, master node, computer, both are same. Slave node, slave computer, both are same. Slave node, right? And also we can call this one as a worker node. And also we can call this one as a data node. All are going to represent the same thing. Slave node, worker node, data node, all are going to represent the same thing. The only slave node one, you can call them as a data node one or worker node one. Anything is fine. Okay. So now let's go ahead and see so how this is going to be helpful. So one thing that you have to understand here, master is the one who is going to manage all these things, the same concept that we discussed here, but how we are going to manage the data. For example, you have a file, right? File name is called temp.txt file. So who is having, right, so and so size. So then how you are going to manage the data, we are going to discuss one by one. So this is the this is the temp.txt file. Then I wanted to store the data into the Hadoop cluster. So from here onwards, every topic is interlinked. So please try to concentrate on my screen 100%. If you're not able to follow any time, any screen, please do stop me. Okay, so now next thing, temp.txt is the file that I wanted to store the data into the Hadoop cluster. So now, like I said, the file has to be divided into the chunks actually. So now how that is going to be divided, who is going to decide that one? So all these things we have to discuss one by one. So now here, as we know, this division, right, in our Hadoop cluster, the division is going to happen at the file level, not at the cluster level, not at the directory level also. As you know, every directory is going to have a multiple files. If you take a Windows, as you use most of the time, you use in a Windows folder, you see the multiple files. Each file is going to just have in the directory. So, but the division is going to be at the file level, right? And this division, a user can decide how they wanted to divide the data actually. How they can decide and divide the data, they can decide here actually. But for example, user has not decided to divide the data into the chunks. Then there should be the default division also has to be there, right? Based on the Hadoop version, we can just go ahead and divide the data into the chunks of data. For example, you see temp.txt file, and don't worry about the chunk, but let's go ahead and see. I'm using the Hadoop one version. So there is one version and also there is two version also. And nowadays we are using three version also, but very rare, it's not matured. But two and three, there is no difference. Two and three, very in-depth concept. There are differences, but you don't have to worry about that. So Hadoop one version, initial version. So what is the default division actually? So based on the size, right, we have to divide, right? So whether you go with the your own division, whether you go with the Hadoop version, but you have to have a concept. You have to have a parameter to divide the data into the chunks of data. That parameter name only is called block size actually. So block size is nothing but the way you are going to divide your whole file into the chunks of file.
Just a quick info, guys. If you want to learn data engineering, then Intellipaat provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job. Now, let's continue with the session.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So what is the block size here? So let me define the block size here. So default block sizes that we are going to see, but what is the block size means? Block size is a parameter. Block size, what is that block size? It is a parameter, it is a argument, or it is a just a simple value using which parameter, using which we are going to divide the whole file into chunks of file. So you can read. I'm requesting everyone to read this one so that you will understand what is the block size. So I know as we proceed further, it will confuse you, but you have to understand block size is a parameter using which we are going to divide, right? Block size is a parameter which is used to divide your file into the chunks of file actually. So this block size, you as a user, you can define whether the based on the version you can go, default block size is based on the version that you are going to have. For example, you decided to go based on the version, right? So when you say Hadoop version that you're using one, then all in every machine you're going to see only one. It's not something one in one machine, two in other machine. You're not going to mix it. So for example, you as a Hadoop user, you decided to go with the Hadoop one version. So what is the block size that you're going to see as a default way? It's going to be the 64 MB actually. 64 MB is the block size, default block size using which you are going to divide the data into the chunks of data. So 128 MB in two version actually. So what does this mean? This means your whole file has to be divided into 64 MB is the block size so that you start seeing the number of blocks, chunks, sizes, slices, pieces, and all that we used to call as a layman way. But now you have to understand that is a blocks actually. The whole file will be divided into the number of blocks, right? So temp.txt file is being divided into the block size actually. So now, for example, so what is our really right file size? For example, temp.txt file is having 100 MB and the block size that I'm going to have is 64 MB because of the one version. So how many blocks? So two blocks, right? B1 64 MB and B2 36 MB, friends. So that's how the division is going to happen. So any questions? So the block size can be configurable. Going forward, when I say configurable, you can go all the way with the 1 MB minimum block size that you can go with 1 MB, which means you can go and configure your block size there 1 MB in one version and two version. Maximum block size can be anything. I should give as a star here, right? Block size can be anything, but one thing that you have to understand, so we should not go more than 256 MB as per our recommendations, because the more block size that you have, the more resources and availability that you are going to see actually. So that is the reason you have to understand very clearly block size maximum 256 MB that you have seen so far in my work experience actually. So minimum that you can have 1 MB, the maximum can be 256 MB. Indirectly you can take that one as a selection. 1 terabyte. Let's do how we are going to do 1 terabyte. If you are going to convert into the MBs, so you can do 1024 or 1000 also, does not matter. So this is what 1 GB, right? 1024 GB equal to 1 terabyte. Again, if you do multiply with 1024, it became what? MBs actually. So now it is 1024 into 1024 equal to 1 terabyte by 64 MB. Both are MBs, right? So if you do this guy, what is that answer? That is going to be your answer. So it's going to be the 16,000 something, right? 16,556 something. You see that correct answer. But 15,000 also it's fine. 16,384, right? I think that is the, so now file one 70, right? Then both are MBs. I don't have to convert. There is no work for me. Then 64. Then how many blocks ended up having? B1 64 MB and B2. The rest of the data we just track as a B2. What is that? 6 MB, right? Then file 2. So what is that? Your 10 MB. So by 64, there is no way you can divide. Then you are going to track that one as a B1 actually. So now how many blocks you ended up having? First one is 2, second one is 1. So total 3 blocks actually. That is the answer actually. So this is the calculation. So one thing that we are clear now, how we can divide our file into the smaller files and track them in our HDFS file system. Very, very high level we are able to discuss. Let me take you a little bit in depth so that you will understand more on this one also. So now you see, right? So this is how your master computer and who is there for you to manage your data. So now, for example, temp.txt file. So now it has divided into the smaller files, which is block 1 and block 2, as 64 MB is the block size, B1 here and B2 here. Or for example, B2 somewhere here where you are having around, right, data node 1, data node 2, data node 3, data node 4, and data node 4000 or 5,000, for example, right? These many machines are there in your cluster. That's how the data distribution is happening, right? So one thing that you have to understand, right? These are master node. So now you are the one who has stored the data, and that is how it's settled, which is good. So now, for example, another client, another user came into the picture and he wanted to read your temp.txt file. You send the request to the temp.txt file. Out of your temp.txt file, now you send the request. All you are going to say that, yes, I would like to locate the temp.txt file. So the request will go to the master node. Now, master node is going to scan 1, 2, 3, 4, 5, something like that, 5,000 files to locate your temp.txt file, which is just 100 MB of file. No way it's going to happen, because each one is, for example, 32 terabytes or 64 terabytes of data that you have, right? So then definitely what will happen? It is going to take a lot of time to scan just 100 MB of file. So forget about the advantage that you see, but a lot of disadvantage that you can expect out of this connection. So for that reason only, what your master computer is going to do, he's going to maintain the metadata here, friends. So metadata is nothing but, right, data about the data. So information about the data. That is the metadata definition in our layman language. So information is what? Simply some data that you are maintaining about your real data. The real data is temp.txt file. About that we are maintaining some information. So here our Hadoop is going to maintain some information about your each and every file. So that is called transaction log, you can call, or metadata, saying file name, file size, block size, right? Number of blocks, blocks location, right? And user group, and for example, date, and permissions, right? All these things that you can expect as a metadata is going to have. For example, our temp.txt file, let's see, the file name is temp.txt file, and file size having 100 MB, block size that we wanted to have is 64 MB, number of blocks is 2, and blocks location B1 is there with the data node 1, and B2 is there with the data node 5000. Okay, and user, for example, XYZ, user belongs to super group, and date 08 something 24 or whatever it is, and permissions, read, write, blah blah blah, whatever it is, right? So this is how for every file these guys are going to maintain this information, and it's going to be the flat file, right? So your metadata will be managed by one of the master computer in terms of flat files, actually, right? Binary format, nowhere you can read it, but it is in terms of binary format. Now you see this whole file has been tracked this way. Now you see, right? So this file is a flat file, binary format, nowhere you can read it. But the moment your master computer is going to receive any request, he has to scan this file. If there is any entry in this file for this file, then only it's going to say that the file exists. Otherwise, it's going to say that file does not exist, actually. So this is a temp.txt file. If it is exist, it's going to say yes, it is available. Otherwise, it's going to say that not available, actually. So temp.txt file, and it is available, and it's going to check B1 is there is the data node 1, and B2 is the data node 5000. Simply is going to send the request to B1 and B5000. He does not have to scan the rest of the machines because they are not involved in accommodating this data, actually. So that is all about the metadata. So you see, can you locate your file without metadata file, right? Is it possible to locate your metadata file? I mean, without your metadata, is it possible to locate your actual data in the HDFS file system? The answer is yes. It is not possible. It is impossible. So that is the reason metadata is a hot kind of thing for your HDFS file system. If there is no metadata, no way you can locate it, actually, right? So if you are missing the metadata, no way you can locate this guy, actually. That is the reason we call this one as a, say, counter piece of your HDFS file. It's a hot kind of thing. So if you are missing the metadata, nowhere you can recreate this one. You have to start from scratch. You cannot do the reverse engineering saying that data node 1 is having these many blocks from these many files, then I'm going to recreate this metadata. Nowhere you can create, because you don't have user information, you don't have permission information, you don't have date, you don't have groups information. All these things you cannot rebuild again from the existing file system. You have to retain the metadata as much as a backups as much as you can actually. So that is the reason metadata is going to play a very, very important role actually. So who is going to maintain the metadata? One of the master computer. Yes, if the master computer is going down, that is what Veera's question. What will happen? Your complete cluster will become the inaccessible actually. So is a Lehman way we are calling as a master. I'm going to introduce the real names for that now. A high level, you're just calling as a master nodes, but at a low level, we are going to see. So who is managing the metadata? One of the master computer. That master computer name, let me introduce. That is called name node. Name node is a master node. We'll be having the multiple master nodes in the Hadoop cluster, right? Name node is a master node. ABC is a master node. XYZ is a master node. We are going to introduce one by one as we proceed further. Okay, so name node, I just introduced the one master node, the first master node, that is a name node actually. So you have to understand name node is a master node who is going to really take care of your Hadoop metadata, Hadoop cluster metadata. As of now, it's going to have the multiple responsibilities. One of the first responsibility I'm introducing the name node actually, metadata. So name node is the one who is managing the metadata. Name node is the one who is managing the all external clients in terms of writing the data into the Hadoop cluster, in terms of reading the data out of your Hadoop cluster. Again, I'm repeating, in terms of whenever you're writing the data into the Hadoop cluster, whenever you're reading the data out of your Hadoop cluster, you are going to see, right? Name node is the point of contact. The metadata also will be managed by the name node actually. And also whenever you are assigned the work to the data nodes, you are going to send the work. The name node is the one who is going to send the work to the data nodes in terms of data storage. So I just introduced one master computer, that is a name node actually. Okay, let's proceed further. So these are the data nodes or worker nodes. You can call them with any name that you wish. So this is going to be the name node. Let's start with our real names, name node actually. So now name node is the one who is managing the metadata. You know what is metadata, and is the one who is going to manage the worker nodes, data nodes, right? Worker node, data node, slave nodes, all are going to represent the same thing, friend. Okay, so whatever number of machines. So now temp.txt file that you just sent to store the data, and block size that you wanted to have is 64 MB. Then you ended up having two blocks, B1 here and B2 is somewhere else. So now, as we can see, every participant is expecting. Yes, if you are just missing the metadata, then you have to start from scratch. For example, it's been 2 years you started, or it's you're interacting with your Hadoop cluster, and you missed your metadata file. So you are going to start from again scratch, right? For example, 1.5 year back you started, and from 1.5 year onwards, whatever the activities that you've done, you have to redo again. So is it going to be acceptable? Definitely no, right? So you cannot redo the same thing again. It's really not easy actually. Okay, so now let's see, we have to have a backup for this one. Is there any way to recover the metadata file? Excellent, right? Definitely everyone is expecting metadata backup actually. But next, before we proceed further, you have to understand, right? So anytime in this cluster setup, right, anytime if someone is sending any request, that request is being sent to the name node. Name node should be always active. At the same time, you should listen that request actually. The same thing, you're sending the request to the data node, right? Data node also should be always active and should be responsive back to the name node. So for example, though you're in online, if you're not responding me back, what is the purpose of staying in online? No, actually. So that is the reason always every machine has to have a listener kind of thing to take care of their responsibilities actually. If you remember, if you know a little bit about the daemons concept. So what is daemon here? Any language. For example, if you know a little bit Unix, you know the daemon. If you know a little bit MySQL, you know the daemon. If you know a little bit about server side, you know the daemon. Daemon is nothing but it is a process, right? It's a process or program that will be running always in the background actually. So that is all about the daemon. Daemon is the process or is a program that will be always running in the background actually. So now here, if you go with the MySQL side, MySQL D is the daemon that has to be always running in the background in order to just to take care of your MySQL responsibility. The moment you are not running that, your MySQL is not going to be the accepting any request from the outside clients actually. The same thing here, each and every machine has to be responsible to take care of these actions actually. For that reason only, we go ahead and just make sure some of the daemons we are going to run in our Hadoop cluster. Hadoop daemons. So total we have 5 Hadoop daemons that we have actually. So let's go ahead and name it one by one actually. So name node is a daemon, right? I'm going to run one listener, right? Always in this machine, that script, that service, a program, a script, a service, right? We are going to run in this machine that is called a name node actually. So now first daemon I introduced, name node daemon. So now here also, right? In every machine, we need to run one daemon to take care of the data node activities. So that is called data node daemon actually. In every machine, it's not something one data node is going to, one service is going to take care of all machines. If you're having 50,000 data nodes, means 50,000 data node daemons you are going to see. Each one is going to run one. In every machine, you're going to run one data node daemon, and that is going to take care of that data node work in terms of storage, in terms of reading the data out of your Hadoop cluster, in terms of writing the data to the Hadoop cluster actually, right? That is name node and data node. Name node is going to take care of your all responsibility what we discussed, and data node is going to take care of that one. And again, at the same time, you see those responsibilities actually. Clear? Name node, data node. So what else? So now you see, as we are expecting the backup for your metadata, we are going to have one more master computer to take care of the metadata backup. So that is only the purpose, friends. Please try to understand the purpose of this computer. Then after that, I'm going to introduce the name, because name also is going to confuse you, right? Because they gave very bad name, the worst name than your blocks is they gave this name. So it may confuse you. So I don't want to confuse you. That is the reason I am requesting you to understand this mission purpose. Then only I can introduce the name. So now you see, every 1 hour, what this machine is going to do is going to copy the metadata from this machine into this guy. Every 1 hour you are copying your metadata every 1 hour from this mission to this mission, and this can be configurable. You can go with less time, you can go with more time. So for example, this machine is gone, right? You are not able to recover your hard drive also out of this machine. Then I can only just locate this machine to recover this metadata, friends. That's all. The moment your name node is going down, I'm not going to bypass this request to this machine actually. I'm not going to take care of my data nodes using this machine. It is not going to do this one for you. What is the one time of 1 hour, which means after every 1 hour from now, after next 1 hour, you're going to take one more file backup from this machine into this machine actually. This is one more master computer. We are just backing up that one into the other machine. This is one computer, this is one computer. That computer name only, right? Secondary name node actually. So this is secondary name node, which is just taking care of your metadata backup. So we are going to run one more daemon that is called secondary name node. Right. So far we have seen name node, secondary name node, data. 3 daemons that we have seen. So 2 master computers, name node and secondary name node, 2 master computers that we introduced. Okay. So now, so far we are discussing about the storage. Name node, data node, secondary name node, all are just handling your storage. How about the processing side? So when I say processing, right, your data has been settled. Now one client came and you wanted to locate your data. Probably he came up with the map reduce and you wanted to process against that. So now map reduce request will be taken, it will not be taken care by the name node actually. So map reduce request has to be taken care by the one more master computer. That guy name is called job tracker. So in Hadoop one version we'll be calling as a job tracker. They are the one who is going to take care of your all map reduce jobs. And in 2 we are going to have the resource manager actually. Okay, so we are going to see what is the resource manager in Hadoop 2 version. So job tracker and resource manager. So job tracker in one version, and that has been replaced with the resource manager. What is that mean and all, we are going to see yarn architecture actually. Definitely I'm going to take you there actually. You don't have to worry, in depth I'm going to take you there actually, right? So we are going to run job tracker, right? So job tracker is the one who is going to take care of all your jobs. So now the request is been sent to the job tracker, and job tracker has received the logic and is going to receive the file name. That's all. Temp.txt file is the file name and this is the logic. That's all. So job tracker has any information about your blocks of your file. So this file name is temp.txt file. Then that's all. Where the blocks exist, where they are available, all these things, who knows that? He has any intelligence to locate the data? He has any capable to locate your data? No, exactly. He does not have that information. So who has that information? Who knows your block report? Who has enough capable to handle your block report? Metadata. But who is maintaining the metadata? Exactly, name node. Then simply I need to request the name node. Definitely, but I need to know this is the my file name, but I would like to know what is the block report. So now name job tracker is the one who is going to send the request to the name node. Name node is the one who is going to scan the metadata, right? Who is going to scan the metadata and is going to check how many blocks are there and where they exist, and they are going to simply report back to the job tracker saying that yes, temp.txt file has been divided into the two blocks, and it is there. Block one is there, the data node 1, and block 2 is there with the data node 3. So now that's all. Job tracker is the one who is going to be start interacting with the respective nodes where the data exists actually. Okay. So now job tracker is at the cluster level, friends. All is managing the jobs. He cannot go all the way with the data node level and cannot just really do anything actually. So he's going to just have one more housekeeping the here. That guy name is called task tracker actually. So task tracker is the one who has to take care of these things actually. So job tracker is this guy. Task tracker is the one who is going to take care of the job tracker works. So indirectly, job tracker is the one who is going to assign the work to the task tracker, saying that yes, this is the logic, and you have a B1 from the temp.txt file with you. You go ahead and start processing this guy. Now task tracker is the one who is going to start the process against this block one with this logic. Then from here onward, it is going to report the status back to the job tracker. The same thing here it has happened, right? So from here onwards, he's going to send the status back to here. So job tracker is the one who is going to track the complete status, and is going to take the help from again one of the task tracker to consolidate your results. We are going to see in depth about the job tracker at the time of map reduce discussion, but end of the day, job tracker is the one who is going to consolidate the end results and is going to report back to the client actually. So that's how, right? Task tracker also is been introduced actually. So what is that? Task tracker in one version, right? That is being replaced by the node manager in Hadoop 2 version. So we are going to discuss more about this job tracker and task tracker, a resource manager and node manager in our coming discussion actually. So any question? These are the 5 daemons that we are going to run in our Hadoop cluster. So let me take the questions one by one. So all you have to understand this, each and every box is an individual computer. A typical Hadoop cluster is going to have a this way. These are all individual machines, individual computers. It's not something you're going to merge together as a single machine actually. Right? So Arthi says, where is the job tracker is running? In the other machine, other computer. Name node is one computer, secondary name node is one computer, job tracker is one computer actually. Right? What is the task tracker? Task tracker is at the data node level to take care of the all tasks actually. Right? Data node is the daemon that is going to take care of all in terms of storage, in terms of reading and writing the data. Task tracker is the one who is going to take care of the all the jobs in terms of writing the data, in terms of reading the data out of your Hadoop cluster action. Okay, so now you see dead node 5 and also this one, and this is how your data will be sent, temp.txt file, and so you see B1 is here and B2 is somewhere else here, right friend? So now please concentrate on my screen. So now this is how your data has been settled. So now these machines are the commodity hardwares, right friend? Cheap hardwares, general purpose hardwares. They may go down any given period of time. So definitely you have to have a backup for this guy actually. So now the moment they are going down, then you are not going to realize to have the backup friend. There's no way you can just do that one, right? Definitely you have to have a backup before, right? Even though it is going down now, should have a backup. So for that one, what a Hadoop cluster is going to do, for example, your data node 1 went down, so your B1 is not available, then only B2 is available. That does not mean that only one block is not available. What is there, friend? I will go ahead and process B2 to see my output. No way you can see that one. Definitely 100% the data recovery has to happen before you start processing your data actually. Without, right, no way you can really process the data. Out of your 1 terabyte of file also, if one file is missing, one block is missing out of your 16,384 blocks, one block is missing, nowhere you can process that file actually. It's going to say that block is missing, right? Somehow the data recovery has to happen. So now you see dead node 1 went down. Now B2 is only available. Then you have to recover now to process your temp.txt file. If that is the case, definitely you see a lot of really disadvantage here actually. So for that reason only, what my Hadoop is going to say, at the time of copying the file, I can maintain the multiple copies actually. So B1, B1, B1. So 3 copies by default I am going to maintain, B2, B2 and B2. So now for example, I am going to distribute this one into the randomly based on the bandwidth that is available. So B1 was here and one more B1 was here and one more B1 was somewhere else here actually. So now B2 is here and B2 is somewhere else here actually. So now you are not maintaining exactly data node replicas, but the copies that you are maintaining for your data. Indirectly, one file, block one is indirectly one file, and you are maintaining that in the 3 places actually. So this is called a replication factor actually. The default replication factor in 1 version and 2 version and 3 version, everywhere it's 3. Default RF is 3. The minimum, again, this can be configurable at the file level, not at the cluster level, not at the direct level. It's at this purely at file level. How we add the blocks at the file level, the same thing. The replication also can have the block level, file level. The minimum replication factor that you can have is 1, and the maximum replication factor that you can have is anything. So when I say here anything, really anything, right? Really anything that you want, you can have. The more replication factor, the more data availability here actually. So now let's see. So you see here at the time of copying your data, you maintain 3 copies. So now indirectly, instead of maintaining 100 MB, you are maintaining 300 MB of data in your Hadoop cluster. Hey Shiva, you are already having the lot of data. On top of that, you are having 3 times of data. Yes, I of course I can do that one. How many machines that you want, I can horizontally add to my cluster, right? Commodity hardware, cheap hardware. There is no need to worry about the storage. All I need to just to take care of my data with the very limited amount. So now you see B1, B1 and B1 right here. So one B1 is not available, right? This complete information will be maintained in the metadata front. It's not something only one copy will be maintained and the rest of the copies will not be maintained in the metadata. No. So everything will be maintained in the metadata. Other thing that you have to understand, there is no priority that I'm assigning, right? First one is B1, first priority. Then second one is B2, second priority. Third, data node 4 is having third priority. There is no such concept actually. All are having the equal priority. So for example, the moment your name node is receiving the request to locate your temp.txt file, it has to locate only one copy, right? Not 3 copies, only one copy. So now B1, it was not available in the, it was available in the data node 1, but it is not available now. Then no way you can locate out of data node 1. Then what else we have? Data node 2 and data node 4. So dead node 2 and dead node 4 B1 is available. Then out of these 2 machines, which one is having the more bandwidth? That machine that you have to locate. For example, dead node 4 is having more bandwidth. When I say bandwidth, I'm going to really discuss more about the bandwidth actually, right? So how the bandwidth distribution is going to happen now, right? How we are going to locate that one, we are going to see down the line. So you see dead node 4, I'm going to really locate B1 because dead node 4 is having more bandwidth. When I say more bandwidth, we are going to discuss down the line. What do you mean by bandwidth and all? That is purely based on the RAM and hard drive. So that is each machine bandwidth is going to come out of that one only, right? So now out of B2, now B2 you see dead node 2, dead node 3, dead node 4 also. So now out of these three things, I'm not going to prioritize anything. I'm going to see the equal priority out of these three copies. Which one is having the more bandwidth, that will be picked. For example, dead node 3 is having the more bandwidth. So now dead node 3 is going to be picked for the B2. So B1 from dead node 4, B2 from dead node 3 actually. So that is how the replication factor is going to help you out. So replication factor, it's a fault tolerance mechanism using which you increase your data availability in the Hadoop cluster. Instead of just depending on a single copy, you made sure three copies are available for you so that you can just maintain the data, right? Or you can process your data without waiting to recover your data from there actually. At what time the data replication happen? When the writing the data or after some time? At the time of writing the data. When you are writing the data into the Hadoop cluster, based on the replication factor, your data will be replicated. So then the second thing is how your right data node is going to, how your name node is going to know that your data node 1 went down, right? You have to have that mechanism also. How your name node is going to know your data node went down, right? So that is also you should understand. Each and every data node is going to send the signal pulse back to the name node saying that I am alive. So that will be calling as a pulse, heartbeat, or signal. Every data node has to send the signal back to the name node saying that yes, I am alive. So that is going to be the every 3 seconds. So this can be configurable by default 3 seconds. Every data node is going to report back to the indirectly ping back to the name node saying that I am alive. For example, let's see the first data node 1 case actually. So name node did not receive any signal from the data node 1 first attempt. Then it's going to see the second attempt. Then it's going to see the third attempt. Then you see, yes, your data node 1 went down. Your name node did not receive even after third attempt. Then is going to, your name node is going to confirm saying that data node 1 is dead guy. So he's no more active in the networks. No way I can assign any work to this guy actually. Right? Going forward, I cannot assign any work to this guy to accommodate my data. At the same time, I should start recovering the data that was there in the data node 1. You are not going to report the data node 1 to recover the data. Your data is what data is available, what data is available in the data node 1, you know already. Who you as a name node, you know that one. With the help of metadata, you know that. So now your data node 1 is not going to just accommodate only B1 and is just waiting ideally, right? So for example, this is having 16 terabytes of hard drive means 16 terabytes of blocks you are going to accommodate, right? 16 terabytes of files you are going to accommodate. So thousands of files has to be, thousands of blocks has to be recovered immediately because your data node 1 is not responsive actually. So I'm just giving the example for the B1 from the temp.txt file. The same thing has to be followed for the other files, right? Now you see B1 is available here. So now you see B1 temp.txt file is available in the data node 2 and also data node 4. Your name node knows that one because this metadata is available in this guy. So now B1 has to be recovered either from the data node 2 or data node 4. So at this point of time also, name node is going to check who is having the more bandwidth actually, right? Who is having the more bandwidth, that guy will be picked actually. So in this case, our data node, right? For example, dead node 4 is having more bandwidth. Now he's going to assign the work to the dead node 4 saying that, yes, data node 4, I see block 1 from the temp.txt file. You have to just copy that one into the data node 5. So now B1 from the data node 4, now you're going to copy to the data node 5 as a B1. So now data node 4 has copied the B1 into the data node 5 and you recover the data immediately. You see after 9 seconds, automatically he is able to heal himself actually. You don't have to manually do this process. Automatically this will be taken care by the Hadoop cluster actually. So this is one of the excellent fault tolerance mechanism that we have in our Hadoop cluster. So every name node, data node, how you are sending the heartbeat back to the name node, how your name node is managing the metadata at the cluster level, your data nodes also is going to maintain the metadata at the data node level. So this is called data node metadata. You know the data node metadata is nothing but only the data node metadata. which means what files from what blocks are there from what files, how they are doing, right? Whether the data is real data was there when it was copied, the same data is there, or it is corrupted. All these things will be available in this metadata. This metadata will be just shared back to the name node actually. So along with your heartbeat, your data node metadata also will be shared back to the name node. So we'll call that one as a block report, BR. Every data node is going to share the metadata from the data node to the name node in terms of block report along with the heartbeat actually. Based on this one only, your main name node metadata will be shuffled accordingly, because earlier data node 1 was having one of the copy from your temp.txt file. Now is it available? It is available with the data node 5. So the moment your data node 5 is sending the block report back to the name node saying that yes, temp.txt file, one of the copy is available with him, then your name node has to has to update the metadata to the current one, so that in future request, if someone is locating the temp.txt file, you should be able to give the correct exact location of your blocks actually. So that is called all about the block report. With the block report, you are able to make sure your name node metadata is shuffled up to date actually. Everything is clear. Now your data has been settled. You are maintaining the 3 copies. So now your admin came into the picture and he has looked into this one, and there was a network issue and he has fixed, right? He is ready to rock and roll, which means he is ready to take care of your work. There was a network issue and is fixed. So when you say fixed, he is not going to recover the data that was there here. temp.txt file b1, 2000 from your log file, 25,000 from your so and so file. There is no way you can see, you can recover that blocks actually. Simply, he is going to really format this file data node, right? He's going to delete the complete data that was there here, and is going to act as a fresh machine, and is going to accept the new work from the name node. He's not going to even restore the status back here actually. If that is the case, you are going to see a lot of work only for this game. Your data is been recovered and recovered, that's all. So why you have to go again and recover this data, right? Why you have to retain your old status of your b1? Your data has been recovered, that's done, right? So that is all about the how, if one of the machine whichever went down, how you are going to get it back, how your recovery is going to happen. I hope you are clear. Even for a tricky question, you should be in a position to answer, right friends? So let's proceed further. So these are called, right, multi-node cluster, right? Multiple machines. It is ideal in the production environment. For example, your production is having 20,000 machines. So do you think I need to maintain the 20,000 nodes in my development environment also? Do you think I need to maintain the 20,000 machines in my test environment also? Right? Really not possible. Nowhere you can maintain these many machines in the every environment. So that is the reason you can really develop with any number of machines, and you can deploy that code to any number of machines, and you can run that application with any number of machines. So that is the reason multi-node cluster is ideal only for the production, but in the development environment we are going to use single node cluster, right? Single node cluster is nothing but your all daemons you are going to run in a single machine actually. So name node, secondary name node, data node, job tracker, task tracker, all these daemons you are going to run in a single machine. But what is the purpose of this one? Are you going to get any performance here? The answer is no, you don't get the performance. But what you get? You get the concept wise how it is working, you are going to get. But the performance wise, you have to get out of the multi-node cluster actually. So multi-node cluster only can give the performance, but the single node cluster is going to just give you the for the development purpose, that's all. So that is all about the multi-node cluster.
Just a quick info, guys. If you want to learn data engineering, then Intellipaat provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job. Now, let's continue with the session.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark, C. Apache Kafka, D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
What you have to do in Oracle VM VirtualBox is click on to the Oracle VM VirtualBox. This is the main link. Okay, and here are the sublinks for different operating systems. I have I have also given this particular link as well, so look into that. So based on the operating system that you are using, okay, based on the operating systems that you are using, try to click on to any one of those links and a file will get downloaded in your system. Okay, let's say I'm using a Windows operating system. I'll click on to this and there will be a file that will be downloaded. Okay, so after downloading VirtualBox, you just have to double click on that so that to install that particular application. Okay, a double click on that particular application and it will ask you for certain yes or no. So you have to click on next and continue. Okay, can we use to Hadoop VM setup for Linux? So as per as the downloads with the respect to the virtual box, just click on next and continue. Do not try to change any of the default settings. Okay, let there be all the default settings as it is. There is no requirement for you to change the default settings. Just click on next and continue. Okay, and so after installing VirtualBox, please make sure that you have installed it properly. How to check is just go to your search window and just type in Oracle VM VirtualBox. Okay, just by typing initial words, you should be able to see an application that is present in your system. You should see that. Can you see this? This is my downloaded file. This particular is the file. What file? This file. Okay, after we have downloaded successfully, the file should be looking like something like this. Okay, before, okay, if your virtual box is not installed, this will be of an unsupported format. So as I have already installed virtual box in my system, this will show you some of a supported format. And how can you check whether this is of a supported format? Just double click on it. It will redirect your page to the virtual box directly. Okay, it will redirect to that particular application, which is nothing but your Oracle VM VirtualBox. Okay, now you can see the specifications. So basic requirement is, as let's say, as if you have a 8 GB RAM, so we are specifying 4 GB of RAM to my virtual machine. And you also can change also, when you check onto this, you can change the RAM size also, but preferably, because you have to have a decent amount of RAM allocated to your virtual machine, we keep all the settings as default. Okay, so let's say if you have a 16 GB, no worries, 4 GB is totally fine for the virtual machine. Just click on to import. As you click onto that, it will require a total of 10 minutes for you to completely import all the things that your downloaded file has. Okay, so as I have already started this will not be showing to you. This is a different virtual, this is the virtual machine which I have already. Okay, when you are starting for the first time, this also will not be there. Okay, I will cancel this because I already have imported everything in this particular thing. Okay, so after importing, after a time span of nearly 7 to 8 minutes, the entire downloaded file will be imported as Ubuntu. Let's start the virtual machine. We have already imported the virtual machine. Let's start just by clicking to start. Please notice that as this is a local on-premise virtual machine, it will take some of the time. Okay, because it has to start a new virtual machine inside your local machine. You have to have some patience before it gets initiated. Start this, you will get this particular window. Okay, it is asking for a validation whether you are for Hadoop. So you have to always select on Hadoop. This is where all your Hadoop frameworks have been installed. Just click on enter. You should be initiating your Ubuntu virtual machine. Yes, finally we have got into our virtual machine. So this is the entire installation process. We also had a file with respect to the commands as well. These are my command files. When you open this, you will see many different commands. Okay, why exactly these are commands? What are these different commands? You will have a basic idea on top of that itself. So start dfs.sh is used to start the Hadoop cluster. So start hyphen yarn is used to start yarn services. So, and also JPS command is used to check the status of all the Hadoop services that is currently being running in the system. Okay, and also there is something with respect to the name node from web browser, how you can access the name node, resource manager, all this thing. I will show you how exactly you have to do. And also there is something called as different framework that are available, and according to each command, let's say if you want to start a hive shell, these are nothing but the basic and the most used commands that is very much important for you to use them in the future, in the upcoming course. So many commands are there. What I ask you is, whenever you are running all the commands, please make sure that you are familiar with the commands usage. Okay, whenever you are executing this particular command, you should know that actual use case of this, which is nothing but to start the Hadoop cluster. Whenever you're using start yarn, you should know that it is starting the yarn service. Similar to that, this again, we are using this pick command to get into the pick shell. Yeah, hive command to get into the hive shell, spark command to get into spark shell. Okay, so now if you ask me where exactly do we execute these commands, let me show you that. So there is a terminal in the virtual machine. Okay, just click on to that. You should be able to access a terminal. So this is your terminal. So where exactly you have to run all the commands? You have to run all the commands in the terminal itself. Let's say your first command is nothing but to start the Hadoop cluster. Get into the terminal, just type in start-dfs.sh, which is the command to start the Hadoop cluster. Click on enter. It will start all the requirement that is necessity with respect to the command. So it will start your name node, data node, secondary name node. Till when you have to wait to get the complete process done is until you get back the same terminal, which is the Hadoop at Intellipaat -Hadoop. Please do not try to execute any other command. It is starting secondary name node as well. Yeah, so not yet we have got that, so we have to wait until it gets back to Hadoop at Intellipaat -Hadoop. So as you can see that we have got back the same Hadoop at Intellipaat -Hadoop. Let's run a few more commands. Let's use this particular command. Let me show that. Start -yarn.sh.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
This is for Mac users, OS Exhaust for Mac users. So yes, we are running the other command, which is start-yarn.sh. Let's that get completed. Okay, and also there is a command called as JPS that will tell me what are the different services that are currently running in my Hadoop environment. So you can see that data node, name node, node manager, resource manager, secondary name node. All these are the services that are currently being running in my system. And also with respect in that command file, there is also something with respect to the to access name node from your browser. How is this possible? Is you have to copy this URL, okay, which is nothing but localhost colon 8088. Okay, this is your URL. So what you have to do is go to the browser that is present in your system. which is nothing but which is nothing but Firefox. Okay, when you click onto that Firefox, it will automatically create a browser it will open up a terminal, which is nothing but a tab in with respect to the Windows operating system. In that particular tab, just type in the URL, which is nothing but localhost colon 8080. What is this 8080? These are specific port number to that particular manager. So here it is talking about the yarn resource manager. So 8080 slash, just type in to that. You should be able to access the name node. Okay, localhost. Okay, let's access the 7870, which is nothing but my name node. So can you see this? We were able to access the name node with the help of a GUI as well, which is like the graphical user interface for the different nodes that we are using. Yeah. Similar to this, there are multiple other ports also, which is 8080 for resource manager, 9864 for default port. Yeah, for the data node. And also to stop the cluster, we also have a command to stop the cluster, which is stop-dfs.sh. Okay, let me also show you some of the frameworks. Okay, let's say if you want to get into a Hive shell, okay, for all the other shells you can directly get into the Spark shell. Let's say for an example, this is just to show you how exactly to execute different commands to get into some shells. Okay, not to worry if you have no idea with respect to what exactly a Spark shell is, what exactly is a Hive shell. Yeah, so let's say to get into the Spark shell. So the command is Spark-shell. Just click on enter. You should be able to access Spark. Okay, it will take you to a different environment, which is nothing but your Spark shell. So we have to wait until it gets completely executed. Yeah. So finally, Spark session available as Spark, and now you should be able to access Spark shell. Yeah. Can you see this? We were able to get into the Spark shell. So this is the Spark shell, and whatever the commands with respect to Spark or Scala, you will be executing it over here. Yeah. So what if I say to get back to my system portal, which is my terminal portal? So the command to get back to your system portal is Control C. Okay, so that you will get back to the same port. And yeah, similar to this, let me show you also. There is something called as Hive. There is something called as Hive. Okay, to access Hive shell, first you have to run this particular Hive hyphen service metastore. Okay, this is to start your Hive metastore. With the help of accessing this only, you will be able to access Hive. Okay, so let me show you that. So let me clear all this. So first you have to get into Hive service metastore. With the help of this command, you will activate your metastore. Is this the command? Hive service metastore. Yes, this is the command. Okay, this is the command through which you will be able to activate your service metastore. Okay, now see, this will never get back to the same terminal, which is Hadoop at Intellipaat, showing that yes, the Hive store is activated. So what you have to do is create a new terminal. This is only for Hive. Okay, for all the other things, there is no requirement for you to use two terminals, not at all required. Just for this Hive, in one tab you enable your metastore, and in another tab just click as Hive. That will nothing but get me into the Hive shell. So as I click into Hive, as I get into Hive, you should be able to see my Hive shell. See, yes, we were able to access Hive with the help of Hive command itself. Okay, for that the only prerequisite is to keep your metastore always active. Do not terminate this particular session and create another one. Just create another terminal and use Hive there.
So now let's see how do these two differ. So batch processing is an efficient way of processing high volumes of data, such as a group of transactions which is collected over a period of time. Hadoop focuses on batch processing, but as you can see over here, there is a time lag in processing this data. So the data which is generated on day 1 is processed on day 2. Similarly, the data which is generated on day 2 is processed on day 3. And on the other hand, real-time processing involves a continual input, process, and output of data. So it provides an organization the ability to take immediate action in times when acting within seconds or minutes is significant. So Spark helps in achieving this real-time processing. So again, as we can see over here in this figure, the data which is generated on day 1 is processed on day 1 itself, and there is no time lag in processing. So that's the major difference between Hadoop and Spark. So now let us understand about Spark briefly. So Spark is a cluster computing framework for real-time processing. It was Hadoop's sub-project introduced in the UC Berkeley R&D lab in the year 2009, and it became open source in 2010. And then 2013, it was donated to Apache Software Foundation. So Spark provides an interface for programming multiple clusters with implicit data parallelism and fault tolerance. So now that we know what is Spark, let's actually have a look at some of its features. So Spark is real time. That is, it provides real-time computation and low latency because of in-memory computation. And Spark is also 100 times faster for large-scale data processing. And Spark is also polyglot. That is, you can write Spark applications in multiple languages such as Java, Scala, Python, R, and SQL. Spark also has a simple programming layer which provides powerful caching and disk persistence capabilities. And Spark also has multiple deployment modes, so it can be deployed through Mesos, Hadoop via Yarn, or Spark's own cluster manager. So now, let us look at some domain scenarios of Spark. So from small startups to Fortune 500s, almost every single company is adopting Apache Spark to build, scale, and innovate their big data applications. So let us see some industries where Spark is used widely these days. So industries like healthcare, media, finance, e-commerce, and travel are extensively using Spark to add value to their business. So now let's understand how our Hadoop and Spark use together. So Hadoop alone provided limited predictive capabilities as organizations were finding it difficult to predict customer needs and emerging market requirements. But with a combination of Hadoop and Spark, companies can now process billions of events every day at an analytical speed of 40 milliseconds per event. Companies can also enhance their storage and processing capabilities by working together with Hadoop and Spark to reduce costs by almost 40%. And by deploying a big data platform in the cloud, organizations can avoid duplication by unifying clusters into one, which basically supports both Hadoop and Spark. So now many organizations are already using Hadoop and Spark together. Yahoo, Amazon, NASA, and eBay run Apache Spark inside their Hadoop clusters. Hortonworks and Cloudera Hadoop distributions come bundled with Apache Spark. Altiscale uses Spark on Hadoop to provide big data as a cloud service. And Uber also uses Spark and Hadoop together to optimize customer experience. So now let us have a look at some of Spark's APIs. So Apache Spark codes can be written in Scala, Java, Python, and R, and we can also write SQL queries with Spark. But the most preferred language along with Spark is Scala. So let's have a look at some of the features of Scala. So Scala provides scalability on Java Virtual Machine, and its performance is also really high when compared to others. Scala also provides excellent built-in concurrency support and libraries. And well, a single line of code in Scala can replace 20 to 25 lines of Java code. And Spark is also extremely fast and efficient. So now it's time to have a look at Spark's architecture. So Apache Spark has a well-defined layered architecture where all the Spark components and layers are loosely coupled. So Spark basically uses a master worker architecture, and in the master node you have the driver program which drives your application. Now you might be wondering, what is a driver program? So basically the code that you're writing behaves as a driver program, or if you're using the interactive shell, the shell will act as the driver program. Now, the driver program runs the main function of the application, and it is the very place where the Spark context is created. So assume that the Spark context is a gateway to all the Spark functionalities. So Spark driver and Spark context take care of the job execution within the cluster. Now, Spark context also works along with the cluster manager to manage various jobs, and cluster manager is responsible for acquiring resources on the Spark cluster and allocating them to a Spark job. Now, this job is split into multiple tasks which are distributed over the worker node. So, these worker nodes are the slave nodes whose job is to basically execute the task and return the result to the Spark context. Then we have the executor, which is a distributed agent responsible for the execution of tasks. So every Spark application has its own executor process, and these executors usually run for the entire lifetime of a Spark application. So in a nutshell, the Spark context takes the job, breaks the job in tasks, and distributes them to the worker nodes. These tasks work on the partition RDD, perform operations, collect the results, and return to the main Spark context. Now, if you actually increase the number of worker nodes, then you can divide the jobs into more partitions and execute them parallelly over multiple systems, and it'll be a lot faster. And with the increase in the number of workers, memory size will also increase and you can cache the jobs to execute it faster. So now let us see the various ways by which Spark can be deployed. The system currently supports these cluster managers. So we have Spark standalone cluster, which is a simple cluster manager included with Spark that makes it easy to set up a cluster. Then we have Apache Mesos, which is a general cluster manager that can also run Hadoop Map Reduce and service applications. After that, we have Hadoop via Yarn, and we can also deploy it with Kubernetes, which is an open source system for automating deployment, scaling, and management of containerized applications. And Spark currently supports these three shells. We have Spark Shell with Scala support, PySpark with Python support, and Spark R with R support. Now it's time to understand about RDDs in Spark. So when it comes to processing the data over multiple jobs, we need to reuse and share the data, which can be achieved through in-memory data sharing, which is actually a lot faster than network and disk sharing. And RDDs help in achieving this in-memory data sharing. So RDD stands for Resilient Distributed Data Set, and it is the fundamental data structure of Apache Spark. So by resilient, I mean fault tolerant, as it can recompute missing or damaged partitions in case of a node failure with the help of RDD lineage graph. And it is distributed since data resides on multiple nodes. And dataset basically represents records of the data you work with. So the user can load the dataset externally, which can either be JSON file, CSV file, text file, or a database. So now let's actually implement a demo on RDDs. So we'll start off by understanding how can we create RDDs. So there are three ways to create an RDD in Spark. So the first way would be to parallelize already existing collection in a driver program. The second way would be to refer a dataset in an external storage system. And the third way would be to create an RDD from already existing RDDs. So let's create an RDD by parallelizing a collection. So this would be the syntax for that. So first we'll create a collection, and this collection is a list which contains these three elements: Spark, Scala, and Hadoop. And then we'll use sc.parallelize to parallelize this collection, and we'll store this result in my first RDD. So this is one of the ways by which we can create a Spark RDD. The second way was to reference a data set in an external storage system. So let's do that. So I'll just type in val and then give a name to the object, which would be, let's say, text RDD, and then let me load this external data file. So the command would be sc.text file, and then I will give in the path, right? So this was the second way to create our RDD. And the third way to create RDD is to transform an existing RDD. So we'll do that using the filter function, right? So over here, we already have an RDD which is text RDD, and on top of that RDD I am using this filter function, and I will be extracting only those elements where it contains the string Spark, and I will assign to this result new RDD. So these are the three ways by which we can create RDDs in Spark. So now that we know how to create RDDs in Spark, let's go ahead and perform some operations. So the first set of operations would be the transformation tasks. So the Spark transformations basically produce new RDDs from the existing RDDs. So it takes RDD as input and processes one or more RDD as an output. And each time it creates a new RDD whenever we apply any new transformation. So the first set of transformation function would be the map function. So this map function iterates over every line in RDD and it splits it into a new RDD. So using the map transformation, we can take in any function, and that function is applied to every single element of RDD. So what I'll do is I will go ahead and create an RDD with the name X, and this RDD is made by parallelizing this collection. Now what I want is, using the map function, I want to add the number 1 to each of these existing element. So this would be the command for that. So on top of this RDD X, I'll apply the map function, and this will take in every single element and add 1 to that element. I'll hit enter. Now let me just type in y dot collect, and let's see what is the final result. So over here we see that these were the initial values, and after applying the map function on top of this, 1 has been added to each of the individual element. So initially it was just Spark. After using the map function, it became Spark1. Initially it was just RDD. After using the map function, it became RDD1. So this is how we can use the map function. So now we'll go ahead and work with the flat map function. So with the help of flat map function, to each input element, we can have many elements in an output RDD. So the key difference between map and flat map is that map returns only one element, while flat map can return a list of elements. So over here, what I'm doing is, I have a list 1, 2, and 3. And what I want to do is, I want to duplicate each of the individual element 3 times from this RDD. So I'll use the flat map function, and I'll take this element and I want to duplicate each of the element 3 times. I'll hit enter and let's see what do we get. So this was our initial RDD, and after applying the flat map operation, we see that each element has been printed 3 times. Now let's say instead of 3 times, I only wanted to duplicate it 2 times. So what I'll do is I'll remove this X, I'll remove comma over here. Now I'll hit enter. So see that we have duplicated this initial RDD like this. So the duplication is twice over here. So after this, we have the filter function. So the Spark RDD filter function returns a new RDD containing only the elements that meet a predicate. So it basically narrows operations because it does not shuffle data from one partition to many partitions. So I'll go ahead and create an RDD which contains the first 10 numbers. Now from this RDD, I would only want the even numbers. So to do that, I can use the filter function. So on top of this numbers RDD, I'll apply the filter function, and I will extract only those elements where the remainder is equal to 0, and then I'll collect the result. So this was our initial RDD, and after applying the filter function, we have extracted only the even elements. So the next function is intersection. So when we apply the intersection function on two RDDs, we will get only the common elements between the two RDDs. And the key rule of this function is that the two RDDs should be of the same type. So I will go ahead and create two RDDs. Right, so first I am creating an RDD with the elements 1 to 9. After that, I am creating another RDD with the elements 5 to 15. Now, what I'll do is I will apply the intersection function between these two RDDs, and let's see what do we get. So we see that we have only the common elements from these two RDDs. So the common elements are 5, 6, 7, 8, 9. So these were some of the transformation functions. Now after that we also have something known as actions. So while transformations create RDDs from each other, but when we want to work with the actual data set, at that point action is required. So when the action is triggered after the result, new RDD is not formed like transformation. Thus, actions are Spark RDD operations that give non-RDD values. So the values of action are stored to drivers or to the external storage system. So this basically brings in laziness of RDD into motion. So now let's work with the first action task, which would be reduce. So the reduce function takes the two elements as input from the RDD and then produces the output of the same type as it of the input elements. So let's say I create an RDD for the elements 1 to 10. Now what I want is the sum of the first 10 elements. So I'll use the reduce function, and what I'll do is I will add each element with the next element, and this should give me the sum of all the elements in this RDD. So when you add up all the elements from 1 to 10, the final result would be 55. Similarly, let's say I create an RDD which would have these string elements Abe, Abby, and Apple. Now what I want is in the final result, I would want a concatenation of these three strings as the final RDD. So let's again implement the reduce function on top of this RDD. So here what I'm doing is I am taking each string and concatenating it with each other. So this was our initial RDD which contained three individual strings. We have applied the reduce operation on this and we have got a final string which is a concatenation of these three individual strings. So after this we have the first function. So the first function, as the name states, basically gives us the first element of the RDD. So I'll create an RDD like this which contains these three elements Apple, BT and Beatrice. So I'll apply the first function on top of this names to RDD to get the first element, right? So see that the first element is Apple and that is what we have extracted. And then we have the take function which returns the first n number of elements from the RDD. So over here I create an RDD nums which contains these elements. Now let's say if I wanted only the first four elements. So I'll just type in nums dot take and then the parameter would be 4 since I want the first four elements. So here I see that I have extracted only the first four elements from this entire RDD. And then we have for each partition, which basically executes a single function for each partition of the data frame. So let's say I create a Spark RDD with these elements 1 to 9 and each partition would have 3 elements. So 1, 2, 3 would come under first partition, 4, 5, 6 would have come under second partition and 7, 8, 9 would come under the third partition. Now what I want is for each of these three individual partitions, I want the sum of the elements, that is 1 plus 2 plus 3 for the first partition, 4 plus 5 plus 6 for the second partition and 7 plus 8 plus 9 for the third partition. And this would be the syntax to do that. So on top of this RDDB, I am applying the for each partition function and I will be printing the sum of all the elements for each individual partition. So I'll hit enter. So we see that when we add 1 plus 2 plus 3, we get 6. When we add 4 plus 5 plus 6, we get 15. And when we add 7 plus 8 plus 9, we get 24. Right, so that was a demo on Spark RDDs. Now let us understand the various components of Spark ecosystem. So let me start with the Spark core component, which is the most vital component of Spark ecosystem. So it is responsible for basic IO functions, scheduling, monitoring, and so on. And the entire Spark ecosystem is built on top of it. So now you know how important it is. So as we already saw, Spark supports different deployment modes. It can be deployed through Hadoop via Yarn, Mesos, or Spark's own cluster manager. Now let's have a look at Spark's ecosystem library. So the library is composed of Spark SQL, Mllib, GraphX, and streaming. So Spark SQL helps us in performing SQL-like queries to process the data. Then we have Spark's machine learning library, which eases the deployment and development of scalable machine learning pipelines like summary statistics, correlation, and feature extraction. And graphics component of Spark helps the data scientists to work with graphs and non-graph sources to achieve flexibility and resilience in graph construction and transformation. Then we have the Spark streaming component, which allows us to perform batch processing and streaming of the data in the applications. And since Spark is polyglot, it can be implemented in Scala, R, Python, and Java. However, Scala is the widely used language. And when it comes to storage, we can store data over HDFS, local file system, and cloud. It also supports SQL and NoSQL databases. So now, let us deep dive into the Spark components. So we'll start with Spark SQL. So Spark SQL is a Spark module for structured data processing. And the code for Spark SQL can be written in Java, Scala, Python, or R. And Spark SQL helps to query data from data sources like CSV, JSON, Hive, and Cassandra. And we can also seamlessly mix SQL-like queries with Spark programs. So Spark SQL lets us query structured data as a distributed dataset or RDD in Spark with integrated APIs in Python, Scala, and Java. Another good thing about Spark SQL is it provides unified data access so we can load and query data from a variety of sources. Schema RDDs provide a single interface for efficiently working with structured data, including Apache Hive tables, Parquet files, and JSON files. Spark SQL also has Hive compatibility, so we can run unmodified Hive queries on existing warehouses. Spark SQL reuses the Hive front end and metastore, giving us full compatibility with existing Hive data queries and UDFs. So we simply have to install it alongside Hive. Another notable point is it provides standard connectivity through JDBC or ODBC. So Spark SQL includes a server mode with industry standard JDBC and ODBC connectivity. And finally, Spark is also scalable. So Spark SQL takes advantage of the RDD model to support mid-query fault tolerance, letting it scale to large jobs too. Now let's have a look at some advantages of Spark SQL. So the execution of queries in Spark SQL is much faster than Hive. So let's say if it takes 600 seconds to execute a query in Hive, it'll only take 50 seconds in Spark SQL. And there are no hurdles if you want to migrate the Hive code to Spark SQL. And as we already know, we can do real-time querying with Spark SQL. Now let's look at the Spark SQL architecture. So let's start with a data source API. So this is a universal API for loading and storing structured data. And it has built-in support for Hive, Avro, JSON, JDBC, and Parquet. It supports third-party integration through Spark packages and also has support for smart sources. Then we have the data frame API, which is a distributed collection of data in the form of named columns and rows. It is basically equivalent to a relational table in SQL used for storing data in tables. And it is lazily evaluated like Apache Spark transformations and can be accessed through SQL context and Hive context. And the next component is SQL Interpreter and Optimizer. So SQL Interpreter and Optimizer is based on functional programming construct in Scala. It is the newest and most technically evolved component of Spark SQL and provides a general framework for transforming trees, which is used to perform analysis, optimization, planning, and runtime code spawning. It also supports cost-based optimization and rule-based optimization, making queries run much faster than their RDD counterparts. And there is also SQL Service, which is the entry point for working along structured data in Spark. It allows the creation of data frame objects as well as the execution of SQL queries. So now, let's learn how to create data frames and work with Spark SQL in Spark. So we'll start off by learning how to create a data frame in Spark. So I'll create a list with these three elements. So the first element has 1 mobile and 50,000. The second element has 2 shoes and 4,500. And the third element is 3 TV and 70,000. Now, what I want is to convert this into a data frame where this will be the first row, this will be the second row, and this will be the third row. And to do that, I would have to use the toDF function. So on top of this object which I've just made, product, I will use the toDF function and I will give the names of the three columns. So the name of the first column would be PID, the name of the second column would be product, and the name of the third column would be value. So now let me have a glance at the data frame which I've just created. I will just type out product df dot show. So we have successfully converted this list into a data frame where this became a first row, this became a second row, and this became a third row. Now we'll go ahead and do some basic operations on Spark data frames. So here I am reading a JSON file as a data frame. So the command for that would be spark.read.json, and inside this I will give in the path which is student1.json, and I will store it in df. So df is a data frame. Now, as we had already seen earlier, if you wanted to show the elements or the records inside the data frame, we will use the df.show function. And if we also wanted to see the schema of this data frame, then we'll use the print schema function on this data frame. So df.print schema tells us that this data frame has two columns. First column is age, which is of type long. Second column is name, which is of type string. So now what I'm doing is, with the help of the select function, I am extracting only the name column from the entire data frame. So df.select name. So this data frame actually has two columns, name and age. But if I want to extract only individual columns, then I'll use the select function. So df.select name, and then I'll show it out. So we have extracted only the name column. Now, similarly, let's say I wanted to extract only those records where the age of the person is greater than or equal to 18. So for this, the command would be this. So on top of the data frame, I'll use the filter function and specify the condition that age needs to be equal to or greater than 18. So we have three records, but out of those three records, we get only these two because Janet's age is equal to 18 and Serena's age is more than 18. And then in the final command, we are grouping the data frame with respect to the age column, and I want to find the count of number of persons for each age value. So there is one person with age 18, one person with age 17, and one person with age 19. So these were some basic operations on Spark data frames. Now we will go ahead and apply some Spark SQL queries on top of the same data frame. So for that, I would actually have to create a temporary view. Command would be create or replace temp view, and then I will pass in the name of the data frame, which would be student1. So let's go ahead and apply our Spark SQL queries. So in the first command, what I'm doing is I am extracting all the records. So we have a simple SQL query select star from student1, which gives us all the records from this table. Now similarly, if we wanted only those records where the age is equal to 17, this would be a syntax. So select star from student1 where age equals 17, and this is the result which we get. So now let's understand about Spark's machine learning library, Mllib. So Mllib basically consists of two packages. First is spark.mllib, which contains the original API built on top of RDDs, and it is currently in maintenance mode.
Just a quick info, guys. If you want to learn data engineering, then Intellipaat provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job. Now let's continue with the session.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Second package is Spark-ML, which provides higher level API built on top of data frames for constructing ML pipelines. And Spark.ml is the primary machine learning API for Spark now. So with the help of Mllib, you can implement statistical analysis, you can implement classification and regression algorithms such as linear regression, naive Bayes, and decision tree. Mllib also supports clustering algorithms such as k-means and Gaussian mixture. So there are multiple things which you can do with Mllib. Now let us implement a demo on Mllib. So let me start off by loading all the requisite packages first. So we will basically be implementing the linear regression algorithm. Now let me load the dataset and show you guys the schema of this dataset. So over here we are loading a CSV file with the name e-commerce customers, and we are storing it into a data frame, and the name of that data frame is ecom.ds. Now after that we have printed the schema. So you see that these are the different columns available in this data frame. So we have email, which is of string type, address, which is of string type again, avatar, which is of string type again, and then we have these double values: average session length, time on app, time on website, length of membership, and yearly amount spent. So we basically want to apply the linear regression algorithm on top of this yearly amount spent column. So this yearly amount spent column would be the dependent variable, and the rest of the double values would be the independent variables. So average session length, time on app, time on website, and length of membership would be the independent variables, and yearly amount spent would be the dependent variable. So now what I'll do is I will go ahead and select only these double values from this entire data frame. So I'll use the select function, and I will be selecting this yearly amount spent column as label. So I will name this column as label, and the other columns I'll be selecting the same. And I'll store this result in ecom.df1. After that, I'll use a vector assembler, which helps me to take in all of these independent variables and store them in a single column and name that column to be features, right? So this is the syntax. So I'll type new vector assembler, and I will first take in all of the input columns, which are nothing but all of the independent variables. So these are all of the independent variables, and I will be storing them under one new column and name that column to be equal to features. And I'll store this in an object and name that object to be assembler. So after this, I'll apply this transform function on top of the ecom.df1 data frame. So over here, we are basically creating a data frame which will have just two columns. First is the label column, next is the features column. So this label column would be our dependent variable, and this features column has all of the independent variables, and we are storing that in ecom.df2. So now let me just show you guys how the data frame looks like. So I'll type in ecom.df2 dot show. So this is our final data frame. This is our dependent variable with the name label, and this is our independent variable features, which contains all of the independent variables. So after this, I will go ahead and create a new linear regression object and name that to be LR. So we can create a new linear regression object with the help of this linear regression function. Now after this, we will go ahead and build the linear regression model on top of the ecom.df2 data frame. The function would be lr.fit, and I am storing the result in LR model. So now that we've built the model, let's actually have a look at the training summary. So over here, I will use the summary function on top of the model which we've just built, and I'll store it in training summary. And I would want to know the residuals of this training summary. So these residual values are basically the error in prediction, or in other words, the difference between the actual values and the predicted values. So over here, these are all of the residuals for the first 20 rows. Now let's also have a glance at some performance metrics. So we are printing the root mean square error, the mean square error, and the R square value. So we see that the root mean square error value is 9.92, The mean square error value is 98 and the R square value is 0.98.
So let's see how to deal with different types of data. And now what I want to show you is how to deal with something called JSON data. So basically JSON is not binary file. JSON is one of the most widely used file formats, especially in the case of big data. You see JSON everywhere. Yes. So JSON stands for JavaScript Object Notation. JavaScript Object Notation. That is called JSON. To put it very simply, it is the format in which you will represent your data as a key value pair. Right. So, and why JSON is important? Because there are many platforms who are going to give you the data in the form of JSON. We had many customers, for example. So there are customers who are dealing with this so-called IoT, Internet of Things related data. So if you have a customer who is actually dealing with IoT kind of data, then what happens is that the data that the sensors are collecting normally comes in the JSON format. Not only that, there are many applications which will give you the data in the JSON format, because JSON is a widely accepted, popular, and standardized way of representing your data. So chances are very high that you will see the data coming in JSON format. And it is called a JSON object. So if you are a person who is coming from the object-oriented programming side, it's very easy for you to programmatically access the data. That is the advantage. So if I'm getting a text file, okay, the text file is not an object, right? So, but JSON is an object actually. So if you can actually call it in your program and natively work with this type of data. And this is primarily the reason why NoSQL databases like MongoDB are extremely popular. Now, if you go to the NoSQL side, you have a database called MongoDB. I'm quite sure that most of you could have heard about it. The reason why MongoDB is number one in the market is because it stores the data as JSON. So that internally JSON, but yeah, representation is JSON, right? Because then programmers can directly play around with the data, right? So not only in the NoSQL side, in many areas, this JSON data is very important. So now our problem is that we have some JSON data and we want to read it and analyze it inside Spark, right? So let me do one thing. Let me show you a use case or a case study rather than just showing you this. So let me figure out where is the data first, okay? I think here we have the data. I just need to upload this data, okay? So what I'm going to do, I will just upload the data, and that may take a while and I will explain it. Meanwhile, what am I going to do? So I will just drag and drop this. So I will take a small case. So when you want to run a Spark program in production, you package it. The only difference is that you package it. And for that, you are using SBT. And we have already demonstrated how to work with SBT, right? Any program that you have, you can compile it and get a jar file, right? You submit the jar file. That is a difference. No other difference. But you can also use the shell. There are people who use the shell also. It is not like a hardcore way, say that you must always use the jar file. Like I use shell all the time, not the jar side, because sometimes you just want to, see what is happening. So when you submit a jar file, that's not possible, right? So we had discussed SBT, right? SBT is the way to productionize your program. Yelp was the original company who invented this idea of local business listing of restaurants. So basically what Yelp does is it's like Zomato. You can find restaurants to eat, you can have reviews, and then you can book a table if you want, you can have takeaways and all these things. So basically it is local business listing. especially for the restaurants, right? Restaurant side. And so I can just search for something. For example, I can say, I want to find restaurants in San Francisco, and you will get. This is what they do. I mean, that's what it does. Now, even if you open a restaurant, you will get tons of information about the restaurant. Like you have the name, the star rating, the address, the phone number, the pictures, the reviews, reservation details, so many other things actually. So Yelp has a huge amount of data related to all the restaurants, right? Now, Yelp also allows you to sort of like download the data, right? So all this data that they have is public data. So you can actually visit their website and you can download all the data that they have. There's a file called a business.json, and that is the file. Now, the idea is when you download the data, it comes in the JSON format. And this is how the data looks like. So this is the original Yelp data. So basically, this contains all the restaurants, probably not all of them, but some of the restaurants which are listed in Yelp, right? And let's say our requirement is that we want to load this data into Spark, and then we want to ask some interesting questions about the restaurants, right? So we are interested in, loading this data into Spark and then answering some interesting questions. Let's say how to do that. Now, if you want to have a look at the data, you can see that every restaurant will have something called a business ID. That is a unique business ID. And then you will have this full address of the restaurant. And then you have this hours key. Within hours, so how hours is a key, then Tuesday is the value. Again, it is nested. Tuesday becomes the key, close becomes the value, and then you have all the days and all. Then you have categories, then you have a city, and then latitude, longitude, so many other things. So if I scroll down, some of the restaurants will have much more interesting information. For example, I don't know. There is something called business info. Let me just try to get it. Okay. City review count, attributes. Look at this. So this attributes is something very interesting. For example, these are two restaurants and I'm just showing you the attributes. In the first restaurant, the attribute says it allows no parking, no street parking, no valet parking, I guess. Accept credit cards, true. Wi-Fi, no. Price range. So this is the attribute of one restaurant. But if you look at the attribute of the second restaurant, see there is more, right? These are all the attributes. For example, what kind of a music do they provide? What kind of an ambience do they have? And classy, trendy, upscale. Do they support smoking? Accept credit card, takeout, happy hour, outdoor seating, Wi-Fi, diner. So many things are there. So the point that I'm trying to tell you is the data is not really properly structured. If you try to put this in a table, one restaurant may have 20 columns, the next restaurant may have 100 columns. Because that is how the business is. When you are listing your restaurant in Yelp, Yelp cannot say that your restaurant must have 10 features or something, right? So every restaurant will have its own different features and options and all. So this data is not really something which we can easily analyze and put it in a row column structure. But anyway, let's see how to play with it in the Spark SQL side. So I also need another file. Yeah. So what I'm going to do, so the first question will be naturally, how are you going to read it, right? So let me start the Spark shell first. So this is semi-structured data. So JSON files are actually semi-structured. They fall in the category of semi-structured data. Now, in the traditional world, let's say you are not using Hadoop or Spark or something, like you are in the traditional world. So normally what people do, there are JSON parsers. You can use something called a parser library and you can read it. But the problem is that that will work if your data set is kind of like small, right? So now what I want to do, I want to read the data. So what I'm going to do, I will simply say spark.read.json, business.json. So the data is in Linux, not in Hadoop, right? Let me just upload it. So how do you copy that? HDFS, DFS hyphen put the file to user training. Okay. And now let's run this. So, by the way, this file has a lot of columns and a lot of data, but look at what I have done. I simply did a spark.read.json and gave the file. All I did is I used this method spark read JSON and then said that, you know what, this is the file you want to read it. And Spark automatically read the file, sampled it, figured out the schema, and created a data frame for me. So the data frame is already created. Its name is BIS. Now, if I show you the data frame, you may not be able to understand because there are too many columns actually. So I mean, like it doesn't fit on the screen really, but the data frame is there. Now, what is more interesting is that if you look at the schema of this guy, look at the schema. All the column names and their data types, everything is automatically inferred. Don't you think this is really interesting? Because you don't have to spend any number of time understanding what is the structure, where it is, how many columns are there. All you need to do is that simply say spark.read.json, right? And there are nested columns, so that is very interesting, right? So the top column right now, it says there is a column called attributes. Within that, there is a column called alcohol. So if you want to get this alcohol column, you can say attributes dot alcohol because it is a struct data type, right? And all the columns are red, so that is the beauty of it. Now, what I want to do, so this is my data frame. So I will say create or replace temp view, and I will just call it as biz. So what I'm going to do, I'm going to register this JSON file as a temporary view, right? So that we can run SQL queries, right? And once I have it, I can simply start running SQL queries. For example, let's say we want to know how many restaurants are there. So I can simply do a select count one as business from biz. So there are a total of 61,184 restaurants, right? You want to get the group state-wise number of restaurants. So what I'm going to do, I'm saying that, select state comma count one as business, group by state, then show 10. And see, it is faster, right? It is not like Hive. You have to understand that you are looking at 61,000 lines of data, that too nested JSON. And if you run a query, the answer is getting in less than a second or two. That means it is fairly fast. It's not like Hive, right? Well, so what is this query? You are basically getting the state-wise number of restaurants, and I'm just doing a show 10 to get the top 10 restaurants. And let's also do a order by query. I'm again selecting the state, count one as business. I want to group by state, order by business in the descending order. Okay, and we want a show 10, let's say. See, very, very fast, right? So you're basically ordering the data based on the number of restaurants of each state. Like Arizona has around 25,000, Nevada has 16,000, etc., etc. Right? So you can run any SQL query that you want. And I just wrote some queries. I will share this with you. For example, you can actually write any type of query. So this one here says, I want to select the name, stars, review count, where the city is Las Vegas, order by stars in descending, review count descending, limit 5. Or let's do a show 10. Do we have a show 10? Yeah, only 5 are there, right? Total. Yeah. So the basic idea is to demonstrate that it is very easy to work with JSON data, especially when you're having Spark SQL, right? Google download Yelp data, you will get first link. Okay. Is data frame base changed? No. What is a data frame behind the scene? A data frame is nothing but an RDD. So the original data frame never changes actually when you run a query, right? Anyway, you got the idea, right? It's very easy to play around even with nested JSON data if you have, and all you need to do is spark.read.json, and then you can work with JSON data. Can I save the table in Spark? Yes, you can. Okay, I will show you that in another example. Dealing with XML data. Okay, so let me see if I have the file available. So I just need to upload it only, hdosdfs -put. I will just upload the data, okay? Then I'll show you what I'm talking about. Training. So now the question is that what if I have an XML file to play around with, right? Well, you are not running Hive queries as such. You are running SQL queries, but you can integrate with Hive to read from Hive, right? But let's say you want to, read XML data. Well, couple of things you need to understand is that even though Spark SQL supports reading XML files, it may not work in every possible scenario. So I should also give you the real picture, right? In the sense like XML is probably more common than JSON, right? So there are many cases where you get XML files as the output, right? You go to all the ERPs, right? For example, I mean, simple examples I'm giving. Let's say you are using something like Tally. Tally is an ERP, right? So Tally has this TDL file, and if you read it, it will by default give you as an XML if you want to process it further, right? So XML files are very common, and Spark SQL has a way of reading XML files. Now you can try that. Let's say in your project, your requirement is that you have a bunch of XML files and you want to read it. Yes, please, you can try that. But in case if it doesn't work, the XML reader doesn't work, then you need to write your custom parser for reading. And we have done that in many cases, right? We had a client 24/7. So 24/7 is a BPO or a call center company. So basically they provide this customer services like call center, chat support, etc. to clients. So I was working with them in one of their project. So what they do, they have this call data. So let's say you're calling customer care, right? What happens? When you call, you will be redirected to this IVR, and the IVR will say that press 1 for English, 2 for this, 3 for that. So you do that, right? So that is recorded in something called a VXML or a voice XML. So basically that XML file will contain the metadata, the duration of the call, what the customer pressed, 1, 2, 3, and how long he took to press, etc. So this data, so they had like millions of records in this data because they had a lot of call center business. So every day what will happen, we will get this data, this VXML, right? And we were not able to convert it using Spark. So that's what I'm saying. In all the cases, the XML conversion will not work. And they wrote their own parser to convert the data. But just to show you an example of how to do this. So this is the XML file that I'm going to use. And this is a very simple XML file. It's not like very complicated or something. So an XML file normally has a root tag and a row tag. So this employees is called the root tag. That is like the outer tag. And then you have this employee. There is the inner, or we call it as the row tag. So when you want to read an XML file, you need to identify what is the root tag and what is the row tag. Once you identify that, well, directly Spark doesn't have any capability to read an XML file directly. So what you need to do, I will exit the shell. And again, search for Spark XML Databricks. So there is an XML data source for Apache Spark, and you can use it for reading the XML. So what you need to do, you need to say you want to start the Spark shell. Okay. So normally you will simply say Spark shell and that will start it. But now what you need to do, you have to say, I want to start the Spark shell hyphen packages, and you then give the name or the Maven coordinates of this Databricks Spark XML package. So if you are wondering from where I got this, it is from this website. So if you go here, it will be written how to start. See? So you have to simply say Spark shell and this command, right? This is the same command I'm typing here, right? So you just say Spark shell packages and then you just give this. And what will happen if you run this? It will download this XML dependency to your session. It is basically going to add this XML package or the XML parser to your Spark session. And then you will be able to read it. So I started the Spark shell. So what am I trying to do here? I'm saying spark.read.format. Okay. And then I'm going to give the name of the reader. That is nothing but com databricks spark XML. What are the options? Infer schema true, because I don't want to mention the schema. Please find it automatically. What is the root tag? Employees. What is the row tag? Employee. And then load the data. So this will automatically read and convert your XML file into a data frame structure. But so if I look at the data frame, right, that we just got, what is its name? Employees df.show. The data frame looks nice, but the problem is that if you look at the first column, the address column is actually struct, I think. If I look at the schema, the address column is of a data type called a struct, which means within the address column, you have 3 more columns: city, country, pin code. That is how it will read. So if you want to run SQL queries and all, one thing you can do is that you can say address dot city, address dot country, like that you can say, right? But an easier way will be that, you can again expand it. So I can simply say where, I just want to select employee number, employee name, address dot city, address dot country, etc. So you see the new data frame. This has the expanded columns, meaning it's easy for you to work on the data, right? And now you can do what? You can register it as a view, start running your SQL queries. The same story follows after this, right? So the point is how to use this XML package. So what you need to do, start your Spark shell with the package option. And once you have it, read the data like this. You just need to give the name of the reader, what is your root tag, what is your row tag, and the file name. and then you will be able to work with it. Right? How do you actually copy files from Linux to Hadoop in production environment? Well, if the file is already in Linux, we do the same thing. So let's say you already have a file in Linux, you want to put it in Hadoop. We do the same thing, HDFS, DFS put, but that situation is very rare. So normally we have data ingestion techniques. So if you have heard about Scoop, Flume, Kafka, Kinesis, so there are data ingestion tools which can ingest your data. Package option is same. Package argument is same, right? So right now I'm using this XML argument. Now there is a file format called Avro. Okay. So right now you may not have it, but I'm just saying, let me just show you. There is a file format called Avro. Okay. Avro is a serialization format, right? It is used to serialize your data, Avro files, right? Well, the representation is different. Like JSON is key value. Avro is not key value. Avro is proper serialization, right? JSON is not serialization. JSON is what? You're just representing your data as an object. Avro will actually allow you to compress the data, save some space if you want. Well, we are not going to discuss Avro, but my point is, if you get an Avro file, imagine. So let's say you are working, you got an Avro file. The file format is in Avro. Then you will be thinking, okay, now I want to read Avro. What will I do? So there is an Avro reader. So you can search for these things, right? So in fact, you can actually search in the GitHub Spark scikit-learn, that is for machine learning, Spark CSV, and Spark Avro. Probably there is a direct method now. There is a Spark Avro. See? So if I get an Avro file, you can read it. It is archived. I don't know why. So some of the things you will learn while you are working. So not everything can be taught also, right? Also, it doesn't make any sense. So I'm taking a class where I'm showing you how to read 100 different type of files. That's useless, I believe, right? Doesn't make any sense, right? Some of the common formats, yes, it makes sense. So even though you learn all this, probably when you start working in production, you will get a file which nobody is able to understand. Even nobody could have seen that format again. You need to figure out how to read it. If Spark is not able to read it, use a parser. You write your own custom code, convert it, and then read it, right? So those are some of the challenges we face actually. For XML, the option is same, but for other formats, so this is how you deal with XML data. We can use third-party library to load and implicitly infer XML schema in a data frame. We saw that already, right? And dealing with Parquet files, right? Parquet is a compression format. So it is nothing but compression. So when you're talking about compression techniques in big data, there are three major formats that we have. There is something called RC, then there is something called ORC, then we have something called Parquet. These are the three formats that we have for compression. What is the difference? Well, beyond the scope of our discussion, but I will tell you, ORC is the best compression format so far. ORC stands for Optimized Row Columnar Format. So far, the best compression format is ORC. No questions asked. Then the next one will be Parquet. Then the next one will be RC. In fact, RC is sort of like very old. So this is very old. I don't think much people are using it. This one. Mostly people prefer ORC or Parquet. Now again, there is this competition. If you are using Hortonworks, you will see ORC more. If you are using Cloudera, you will see Parquet more. So Hortonworks was originally, I think they were contributing a lot to the ORC project. So when you start working on a Hortonworks platform, right? Hortonworks will say that, you know what, if you want to compress your data, please use ORC format. And even Hive and all supports ORC extremely well. And ORC is the best, no questions asked. ORC can even do things like indexing internally. So it's one of the best formats ever created, no questions asked. But when you go to the Cloudera platform, Cloudera will say that, well, not use ORC, use Spark. Well, you don't have to understand much about how this is happening. The only thing is Parquet files are compressed files, right? Heavily compressed, right? So I think Parquet will achieve around 50% compression. Like if I have a 100 GB file, it will compress to around 50 GB. And this is really, really important because you never want to store the data as it is on big data clusters, because that will consume a lot of space for you, right? So people are always searching for ways to reduce the total file size, right? And Parquet is what you have in your syllabus because you are learning Cloudera course, right? You are learning CCA 175. So, but yeah, ORC is very nice. I personally prefer ORC over Parquet in any situation. But Cloudera's official documentation says use Parquet. Cloudera likes Parquet. So we are going to learn Parquet for sure, right? So the point is that if you have a Parquet file, how do you read it, right? I think Spark has an ORC reader now. So if I say spark dot read dot, you can read ORC or you can read Parquet. There is no RC reader, I guess. RC is no longer there. But let me show you a sample so that you understand how this Parquet files looks like. So people will be thinking like, what do you mean by a Parquet file? Do we have the file? There is a file called baby names dot Parquet. Can I upload it? Baby names dot Parquet to user training. Oh, it's already there. Baby names.parquet. So the point is, this is the file, baby names.parquet. Okay. And you cannot read it normally. So if I try to read it, you cannot, because Parquet is a specific format, right? Using your normal text editor or anything, if you try to read it, you will never be able to read it as such, right? So that is why you can use the Parquet reader. So I can simply say val baby df equal to spark dot read dot Parquet baby names dot Parquet. Very easy. And if I do a baby names, well, this is how the data looks like. You have an year, the name of the baby, the probability, and the sex, boy or girl. Some sample data I have, but you got the idea anyway, right? So you will be using this reader for Parquet. That's my whole point, right? So I told you that Spark SQL has excellent connectivity options, to read the data from things like RDBMS, right? So how can you read the data from RDBMS? Let's have a look at it. Okay, so I will show you that. And then Hive is also there. We will look at Hive as well. Don't worry, right? So Ravi is asking, generally NoSQL, what format they provide the data? It depends on the platform. Ravi, like MongoDB is JSON and BSON. Cassandra, if you read, it's like tables only. Cassandra has tables normally. So you can read it as in the proper structured format itself if you want, right? So we have a case study in dataset also. But where is this RDBMS thing? If you guys allow me. Okay, so we have it. I just need to search for a file, then I will tell you what we're talking about. MySQL dash connector.java. MySQL dash connector.java. Okay, inside this .bin.jar file. Okay, so we got it. Right. So let's do one thing. Let us first verify whether MySQL is running on our cloud lab. So in the cloud lab, we already have the MySQL, and let me try to log into that. So I'm just going to type this command. Okay, so we have logged in. So we already have MySQL running, and let us see whether MySQL has some data. Show databases. Oh, very well. We have a lot of data actually. So there is a retail DB, and I can say use retail DB, show tables, customers, orders, select star from orders. Well, you got the idea. So I have a MySQL database, which is running on the cloud lab, right? And it has a database called a retail DB. Within that, there are some tables. So I just did a select star on one of the table called orders table. You can see there are around 68,000 rows, and there is an order ID, order date, the amount, and the order status, kind of like a schema. Now, what is our requirement? I want to read this table into Spark directly. Well, I want to read it. How can I do that? Now, if you want to do this, the first thing you need to understand is that you need the MySQL connector or MySQL driver. You understand that, right? Whenever you want to talk to any RDBMS, be it Oracle or MySQL, you need the JDBC or DBC driver. Then only you can talk. Point number one. So I'm going to verify whether I already have downloaded it or not. Let's quit from here. CP MySQL. There is a MySQL connector.jar. So I am assuming this guy should work. Okay, so 5118.jar. Where can you get it? You can go to Google, right? You can just go to Google and do what? Download MySQL connector jar. And the first link that you get is the MySQL download page. That is from where you can download. I think you guys understand it. So I already have a MySQL connector Java 5118.jar. So this is already there. And let's see if we can use this. Now, how do you use it? First, exit from the Spark shell that you have. And you need to start the Spark shell with a couple of arguments. Let me show you what it is. So we will say Spark shell. Let me just copy paste it, okay? MySQL connector Java. What is the version we are using? 5118. 18.jar. .jar. Yeah. So what I'm going to do, I'm going to start my Spark shell with this argument. I'm going to say that start the Spark shell, the driver class path, and the connector jar file is this. So basically it will add the driver to the session. That is basically what is going to happen. Let's try that.
Just a quick info, guys. If you want to learn data engineering, then Intellipaat provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job. Now let's continue with the session.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, started. But now the question is that how do I read the data, right? To do that, what you need to do is, see, you have to create something called, Java utilities properties object. So there is a Java util properties class. All you need to do is you instantiate this class and then you create an object. That object is called prop. It can be any name. Why are you creating this object? Because this object has some attributes. Using that, you can pass the RDBMS connection details like the database name, table name, etc. So first step is that you create this object and then you put things like username, password, and all. So what is the username, right? To connect with MySQL. I think it is here. Password is this. Driver class is this. URL. What is the URL to connect? So it will be localhost, right? Because it is running on the same machine. Localhost. Database is retail DB. Table name is orders, and then it should work. So let's try this first. No suitable driver. So I guess the driver we have used did not work the way we expected. Okay, so let me use a different driver, okay? And see if this all works. So there is a connector, this should work, I'm assuming. Too many folders are there actually. Okay, so now I have added the driver. I just need to restart the session. See what happens now. Now can you read? This is giving me driver error now. For sure. I will just upload one more sample driver I have and see if that works. If not, we will figure it out. Don't worry. Okay. So I will do a start. What is the name of the file? MySQL-connector-java- 5147. The driver version is correct. I have been using the same version for quite some time. The driver class is also correct as per me, because I had been running this for quite some time. So JDBC, now it is trying, it read. So it read, I mean, there is a warning, but it read. What was the error? I did not add this slash. So in the connection string, right? So how do you read it? So like I said, you have to put the username, password, the driver class, and the URI. And I read it as empdf. So if I do a empdf dot show, that's it. This is your data from MySQL, right? But tell me one thing. Why do you want to do this? What is the practical scenario? Why do you want to read the data from, say, MySQL into something like Spark? Why? Why do you want to do this? So no, it's not for speed, right? See, MySQL in its own class is very fast, right? So you are using MySQL as an OLTP system, RDBMS, right? And it's really fast, faster than Spark for sure, right? So you are not reading this so that Spark will become faster or Spark will become better. That is not the idea. And also we do this if, so if you want to do things like join operation, like you have a very large data set, like a data frame, and you have a small data that is already lying in MySQL, you want to do a join operation, this is what you do. Because that is the only situation. Otherwise, you don't really read a lot from RDBMS and then process the data, right? So one thing that people have been asking is that how do you actually connect with Hive? Okay, so the question is like, I have Hive, and how do you access Hive? So let me do one thing. Let me start Hive and check whether we have something. So Hive is here. If I do a show databases, okay, there are some databases. And let's see if I can use some of them. Use movie analysis, show tables. No tables. Intellipaat, let's look at this. The only thing is that, okay, so there is this retail DB, I think probably we can use it. This should have. Hey, select star from departments. Okay, so some data is there, I think, in departments. So the database name is what? Retail DB departments. So there has been a lot of confusion around integrating Spark SQL and Hive. So as per the slides, when you say you want to integrate Spark SQL with Hive, right? Well, one way to do this is that you install Spark and Hive everything in your setup. So let's say you are using a new setup, right? So you install Spark, you install Hive, right? And Hive has a configuration file called Hive site XML, right? So there is a file called Hive site XML, and let us look into that. Hive installed Hive slash conf. So can you see there is the file called a hive-site.xml file. So typically what people do is that if you are working in a big data infrastructure, this will be done by the administrator. What he will do, he will copy this Hive site XML file to the Spark folder. So if I go to Spark conf, it should be here. So here is the Hive site XML. So first thing you need to do is that you have to make sure that you copy the so-called what you say Hive site XML file from the Hive configuration folder into the Spark configuration folder. And you don't have to really worry about this because see, when you are working in a company, this will be already done and set up by your administrator, Hadoop administrator or Spark administrator. Now let me see what we are going to do. So remember we have this Yahoo stocks example. So we are going to use the same thing in this example. So I'm going to just say Spark shell. Start the Spark shell. And remember we were creating the data frame by reading the RDD and then converting it. I guess you guys remember. So we are going to do the same thing. Then let's do this manually. sc.text file. So you just read it and see what is there. The data is read. The Yahoo stocks example is already there. So I'm just going to run this again. You read the data, you extract the header, right? And then you convert it. And then you're defining the case class. Remember this? And then you will convert this to a data frame called stock price. So till this, I think it is here. It is called Yahoo stock data frame, but we are calling it a stock price. That's also fine. Right. And you can register it as a table and then write queries. We have already seen that. That's not the problem. Yahoo stocks data frame, just a processing engine, right? And therefore, let's create a Hive table using Spark SQL and store the data into the Hive table. So if you want to connect from Spark to Hive, you need to create something called a Hive context. So I'm just going to say, we're going to say stock price dot show. Okay, we have the data. So first thing that you need to do is that you need to create something called a Hive context. So I'm going to my Hive context equal to, you will say new org Apache Spark SQL Hive dot Hive context, and you will pass the SC. Right. So you are creating an object called a Hive context object, and you are passing the Spark context in doing this. Now you may be wondering, why are you creating this object called Hive context? This will allow you to connect with Hive from your Spark SQL session, right? The first step is that you create this object, and now we will use this Hive context for operations on the Hive table. So if you want to create a Hive table, you can simply say my Hive context.sql, and then you can simply say create table, the Yahoo stocks table that you want, right? So let's say you can say my Hive context.sql, and you can simply say the create table statement, right? So I can say create table Yahoo stocks one, Yahoo stocks. Let's call it as 100, okay? Because probably the table will already exist. String open, that is float, high, that is again float, L means low value, float, and there is adjustment, that is also M is integer, then there is adjustment which is float. So this is your query. So what it says, create table should work, right? Not to think. Yes. Yes. So once you create a Hive context, using the Hive context, you can say .sql, and then if you run a create table command, this will be created in your Hive actually. And now if you want to load the data, let's say into the Hive table, you can again use the same set of commands. For example, you can say my Hive context.sql load data. So let's say my Hive context.sql, I can say load data in path, and where is the location? You can say user training Yahoo stocks.csv, Yahoo stock 100. Yahoo underscore stocks 100, right? Not stock. It is stocks 100. Yes. See? So now it is loaded the data, right, into Hive. And we can actually go to Hive and verify this. So what I can do, I can create one more session and then log on to Hive. So let's start Hive and then verify this. Okay. Show tables. Yes, here is the Yahoo stocks 100. Select star from Yahoo stocks 100. Here is the data. Well, my data format was wrong. That is why it is dumping it as null, but you got the idea, right? So we didn't mention the delimiter in the create table statement. That is why it is considering each line as a column. You should also say delimited by comma, right, in the create table. That is why it didn't understand, but you know the data is getting loaded. You got the idea, right, what to do. So this is one way to work with Spark and Hive. So what did we do? Let me show you this here again. You create something called a Hive context object. You can say new Spark SQL Hive context. And once you have the object from the Spark's SQL command line itself, you can run all the Hive queries that you want actually. Okay. How can we read already existing table in Hive? I will show you. So the point is, this technique that I'm showing you, this creation of Hive context and all, is a bit old. Now, in your slide, actually, this is what we have. If I look at your slide, this is what we have. But this technique is a bit old. How do you know that it is old? I can actually prove it. When you're creating that Hive context, you will get a warning. So where was the time when we created it? See, let's say you're creating this Hive context, right? You will get a warning. Let me show you. See, warning. There was one deprecation warning, rerun with deprecation. So it is giving the warning saying that this creation of Hive context and accessing the Hive tables using this Hive context. These techniques are actually a bit old. In the latest versions of Spark, the Spark session itself supports all this. Let me show you that. So ideally what you should do, go to the Spark website, and then you have documentation. Let's pick up our version, that is 231. And in the documentation, if you scroll down, there is Spark SQL. In Spark SQL, you have run Parquet Hive tables. Very interesting. So this is what you should do ideally. And when I'm working, this is what I'm seeing. Most of the times people are using this technique. So Spark SQL also supports reading and writing data stored in Apache Hive, right? So that is what we are doing. Configuration is done by placing Hive site XML or core site XML in the Spark configuration. Now, how do you do this is very, very easy, actually. So you have to create a Spark session. Now, we already have the Spark session, so I don't have to worry about this, right? Now, if you want to read, all you need to do is this. So I can simply go here and I can simply say spark.sql, and I can say select star from I think this should work. See, you don't have to do any of this, like creating Hive context and doing this, that, and all. If you want to read a Hive table, very simple. Simply say spark.sql and whatever query. So this will directly read from Hive. I'm reading from Hive because this Yahoo stocks table is in the Hive. Now, what if your table is inside a database? So let's read it, right? We had a table, right? Retail DB departments. So you want to read that? So very simple. If you want to read that, all you need to do is this. Select star from retail DB dot departments. So some Spark versions have a bit of warning, don't bother about it, but you are able to read it directly, right? So select star from db name dot table name, and the data in the Hive table is now available as a data frame to you. So it is as simple as that, right? So look at this table. This it is able to read properly, right? You can get the department and the ID name, right? So in the Spark version 2, especially when you start with 2.2 and 2.3, what is the recommended way is that you can directly use the Spark session to read any table from Hive. So this is one thing you will be interested to know. The second thing you will be interested to know is that how can you save it back in Hive? I have a data frame. I want to save it back. So what was the name? Yahoo stocks, right? We created a data frame, right? Stock price. Okay, if we delete it, let me read it. We need some data to play around with, right? Let me just verify. What I'm going to do, val ret equal to spark.read.csv, and let me just give the data. Oh, very nice. I think there is a one column data, some data that we have. I just read it, right? So there is a retail sample data in Hadoop. I read it into Spark. I say spark.read.csv. I got the data. Now my intention is I want to save it in a Hive table. How can I do that? Right. It's actually very simple. Let me show you. Yes. So you can simply say ret dot save as table. Ret table, something like this. Why it is saying, oh, we need to import probably save as table, right? So sometimes you need to save, import certain libraries. I will tell you when you need to import what, but let me just import these standard libraries. I will explain when to use what. Import org.apache.spark.sql. Save mode. Okay, now it should work. Hive records, read table. See, Hive records. It got saved as a table. This is the command I ran, right? The command I ran is this. So Hive records is the table name. So once you have a data frame, RET is my data frame. You can say write mode, okay? Save mode overwrite. So what is this? When you're saving a data frame in a Hive table, you can mention something called a save mode. And there are 3 save modes: append, overwrite, and replace. I think the third one is ignore, right? Because in Hive, when you are saving the data, either you can append the data, or you can overwrite the data, or you can ignore the data. So when you are saving a data frame, so right now I'm saying that I want to save this data frame called RET. The save mode is overwrite. So if there is a table already I want to overwrite, simply say save as table, it will save it in a Hive table. That's all you need to do. So my whole purpose in demonstrating this is that use the Spark session for Hive integration. If you want to read the data from a Hive table, you can simply say spark.sql and then anything that you want. Any table in Hive and any query in that table will use Spark engine to read the data. If you want to store the data, permanently in a Hive table, say write mode, overwrite, or append, save as table. That is how Hive integration works. Okay, so let's discuss a little bit about performance tuning, right? Well, performance tuning may not be something which can immediately have an impact on your learning, because see, things like performance tuning will come into picture when you start working and you work for an year or two, and then when you want to dig deeper, because performance tuning is done if now your program may run in any way, but later you want to improvise on your program, right? So for some workloads, it is possible to improve the performance by either caching data in memory or tuning on some experimental options. Now, remember we discussed this caching technique in Spark in RDDs. The same thing you can use in Spark SQL. Meaning you have a data frame, and let's say you are running a lot of queries on the data frame. You can simply say data frame dot cache. What will happen? The underlying RDD will get cached, right? So Spark SQL can cache tables using an in-memory columnar format by calling spark.cache table or data frame.cache. Any of this is fine. So when you cache a data frame, what will happen? The internal RDD, which it is related to, will get cached. And if most of your queries are on the same data frame, it will be ideally faster. That is what is going to happen. Then Spark SQL will scan only required columns and will automatically tune compression to minimize memory usage and GC pressure. Right. So caching is a good technique. You can call spark.uncache table to remove the table from memory. So if you are registering the data frame as a temporary table, then you can say spark.cache table, right? This can be used if you are registering as a temporary view, create or replace temp view, right? If you're done with it, you can say spark.uncache table. That is also possible. And when you're caching the data in memory, configuration of in-memory caching can be done using setconf method on Spark session or by running set something equal to something. So when you want to cache it, either you can say set Spark SQL in-memory columnar storage compressed true, right? So when you do this, what will happen? Spark SQL will automatically select a compression codec for each column based on the statistics of the data. This is really helpful because if your data is in the columnar format, right, row column format, each column will be different, right? For example, we have some compression codecs, like there is something called Elzo, Snappy. These are all compression codecs, and they will work really well if you know how the data is. For example, imagine there is a column called a gender. There is a gender column. Now the gender column can have what? Maximum 3 values, unique values, male, female, or you don't want to provide the information at all, right? So the compression that you use in the gender column compared to, let's say, you are compressing on a transaction ID column. Transaction IDs are what? They are having millions of unique values, right? So depending on the data that you have in a Spark SQL data frame column, Spark SQL will automatically use the appropriate compression codec. To do that, you need to simply say Spark SQL in memory columnar storage compress true. If you do that, it's gonna cache it and compress it as well. That is one technique that you can use. You can also say Spark SQL in memory columnar storage batch size to a value something like 10,000. It controls the size of batches for columnar caching. Larger batch sizes can improve memory utilization and compression, but risk OOMs when caching the data. So what is this property? This is the batch size. So if you say 10,000, the batch size is 10,000. So it will start compressing 10,000, 10,000 batches, right? So if the batch size is really big, you may get a out of memory error. Otherwise, this is also a good technique you can use. Following operations can also be used to tune the performance of query execution. What is it? Spark SQL files maximum partition bytes, the maximum number of bytes to pack into a single partition when reading files. So what happens is that partitioning is also applied to Spark SQL, right? So when you're saying that I'm reading a JSON file or I'm reading a Parquet file or a CSV file, what is the maximum partition? The default is 128 MB because by default the partition is set to 128 MB. Now you may be wondering why this partition and all are really important. It is really important. In Spark SQL, we have a shuffle. So I will discuss it, the last property. Partitions are really important. And what is the second property? Spark SQL files open costlin bytes. The estimated cost to open a file measured by the number of bytes could be scanned in the same time. This is used when putting multiple files into a partition, right? So why this property is important? So if you're having a lot of small files, then this property is important. Otherwise, it is not really important. So what this property says, it gives you an estimated cost to open a file, right? So for example, I have 1,000 or 2,000 files, and I want to read them, all of them together, right? So how much time should be allocated for opening and sampling and reading the file? That is this property. Spark SQL broadcast timeout in seconds for the broadcast wait time in broadcast joins. So there is a technique called a broadcast joins, okay, that we use in Spark SQL. Maybe not really important right now to you. So you can set a timeout period for that. That is this broadcast timeout period. And what is the Spark SQL auto broadcast join threshold? This configures maximum size in bytes for a table that will be broadcast to all nodes when performing a join. By setting this value to -1 can be disabled. Note that current statistics are only supported for high metastore tables. So probably this broadcast join is important for you. So let's say you have two data sets. So there is a file 1.csv and there is a file 2.csv. And you are saying join and you read it as a data frame. Okay. So you said df1 equal to this. And here you said df2 equal to this, right? Now you are saying that join df1 comma df2. You are writing a join operation, no problem. This file 1 CSV is, let's say, around 20 GB. File 2 CSV is, let's say, 40 MB. Small file. So the point is that if I simply say join data frame comma data frame 2, the join operation will happen, no doubt about it. But if I want to make my join operation more efficient, I can do something called broadcast joins in Spark SQL. So you just need to use a keyword and then it will do something called a broadcast join. What is the advantage of doing a broadcast join is that when you do broadcast join, so this data frame 1 is 20 GB, right? Imagine data frame 1 is lying on 33 machines. Because it is a very big file, it is divided into what blocks, and let's say the data is lying on 33 machines. Data frame 2 will be normally lying on only one machine because it is a very small file. When you do a broadcast join, what will happen? It will take the smaller file, that is this data frame 2 file, and broadcast it to all the 33 machines where data frame 1 data is there. So your joins are faster. So basically the smaller file is taken and then it is broadcasted to all the machines wherever there is a part of the bigger file. So your join operations we have seen becomes 2 times, 3 times faster. This technique is called broadcast join. And what is this property? It is telling you what is the broadcast join threshold, right? So if you say 10 MB, the threshold, if your second table is less than 10 MB, it will be broadcasted. If it is more than 10 MB, it will not attempt broadcast join. So ideally, we can keep it less than 100 MB. So like 40 MB, 60 MB, the threshold, that will speed up your join. But if it is too big, that is also another problem. Like if your file is like 3 GB, you cannot broadcast to all the machines. That will again have a lot of performance issues. And this broadcast timeout is, you can set a timeout. And after that, if the join did not complete, it will abandon it actually. The last property is called Spark SQL Shuffle Partitions. This configures the number of partitions to use when shuffling data for joins or aggregations. And this is very important, right? It's very common that you have something called shuffle operations. Like you are going to join two tables, right? If both the tables are really big, And when the join operation happens, a lot of data shuffling will happen, right? And that is very common. During the join operation, it will happen. Now, this property set how many partitions maximum you should use for your shuffling and join operations. And ideally, the default number is 200. Sometimes we keep this number even more than 200. That is recommended actually, right? Because Spark SQL also has a small drawback. If the partition size is more than 2 GB, your shuffle operations will fail. We always see this error. So the problem is, let's say you have a 10 GB file, okay? And let's say you created a data frame. You said df equal to spark road read dot csv, and then you read the file dot csv and you created it. Now, what is the size of the file? 10 GB. Imagine that you read it as 2 partitions. So what will happen? You will have partition 1, that is 5 GB. Then you will have partition 2, that is again 5 GB. Now, this is fine. I mean, you may think this is fine, but the problem is that when a shuffle operation or a join operation happen, it will throw an error and it will not work. Why? Because the partitions, if the partition size is more than 2 GB, it cannot support shuffle or join operations. Then what will you do? You can say repartition. There is a command called repartition. So already my data has 2 partitions. I can say repartitions 10. What will happen? Your data will get repartitioned to 10 partitions. So these are some of the things which will become very clear to you when you start working. Maybe not immediately you will understand this, but the size of the partition, the number of partitions to be used, these all have a very strong impact on your performance. Any questions on these properties? Anything that you don't understand, let me know on these properties we were discussing. So this can be dynamic or static. These properties can be set in a static file or from the command line also you can set it. But it is very rare that suddenly you receive a big file. It doesn't happen like that, right? These are all batches, right? So you know that how much data you are going to process, and accordingly, now see, if you were already getting 100 terabyte file, if it becomes 200 terabyte, you don't have to do anything special actually. Like once it crosses certain limit, even though the file size becomes bigger, it's not a big deal. But if you were getting very smaller files and then all of a sudden you get a big file, then yeah, you might have to rewrite your code in that case for performance. So some of these properties, so the problem is that end of the day, you will be compiling and running all this as jar files using SBT. So runtime, you may not be able to make any changes here. So if you feel that your queries are running slow, probably you can change these properties, recompile your code, and then run it again. That is one way you can do it. Okay. So there are 2 options, right? One is through shell. One is the this thing, what SBT. You can also use the Eclipse. You can use Eclipse with Scala support, right? Remember, we were learning Scala, right? In the first day. Same Eclipse, there also you can run the code. No problem. If you just want to test it, you can do that also. You can open Eclipse, write the code, run it, and see the output. That's also possible. So it depends on the company, right? Some companies use IntelliJ. Some companies, they use something called IntelliJ, not Eclipse. Somebody use Eclipse. Up to them to decide.
Just a quick info, guys. If you want to learn data engineering, then Intellipaat provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job. Now let's continue with the session.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So, what is AWS? So, first, let me give you the full form, the expansion of AWS. AWS is an Amazon subsidiary cloud provider, which is Amazon Web Services. So, Amazon Web Services, you would know that it is a cloud provider. But what is a cloud provider? So, to understand what is a cloud provider, you should first know what is a cloud service. So, let me tell you in the most simplest terms what a cloud service is. Cloud service is something which is on another person's computer which you are trying to access through the internet. So let's say I have 10 computers. So in that I'm just using one and 9 computers are redundant for me. I'm not going to use them. So what I'll do, I'll just rent it out through the internet. So I'll be running virtual machines on these PCs. So you will be able to create a virtual machine on my system and use it for yourself, and you will be paying me for that. So you are renting something through the internet. So a cloud service, so let's say even Gmail is a cloud service, but Gmail provides you an application over the internet. So you're using an application over the internet, but you do not know where this application is hosted on. Obviously, this application is hosted on a server somewhere in America or somewhere in Europe or any data center. So somewhere it is hosted. So that particular computer has these files, and you are accessing these files or these applications through the internet. So that is a cloud service. So any service, any website which you are viewing on your browser. So you go to google.com and type in if you go to a browser and just type in google.com, you get a website. So that website is fetched from a server which is running on the Google Cloud. So even google.com is a cloud service. So now there are other types of cloud services as well. So what do I mean by other types? So we've discussed about applications hosted on, that is google.com, Gmail, Google Sheets. So now coming to other types, there are two more types. One would be infrastructural and one would be platform based. Infrastructural in the sense you can rent or you can basically get your own PC. So you can get your own computer, but the thing is you will get access to the operating system, not the hardware components. You will have complete access on the operating system. You can install anything, you can add any kind of files, you can host your applications on them, but you'll be paying for that usage. But you will not be given hardware level permissions, but you will be given OS level permissions. So you can get a server which is hosted on AWS. Another one which I was saying is platform. Platform in the sense you will be given a website on which you can create your own application through that platform, which again will be hosted on AWS. So here we are discussing AWS, that's why I'm giving AWS examples. So I've given you a basic idea of the three types. One is infrastructural, that is you will get servers. Platform, where you will get a platform to design applications and also get servers automatically for that. Third is the applications like Gmail, Google Sheets. So I'll give these. So for infrastructure, I'll give a service. For platform, I'll give a service which is available in AWS later in this session. So now we've understood what is a cloud service. Now a cloud service is something which you get over the internet. Now a cloud provider is a company who provides these cloud services. So Amazon Web Services is a cloud provider who provides these services over the internet, and they have a lot of different services, and we'll discuss about them later. Now IT before the cloud. So before we used to buy servers. So for any application you want to host, you will have to buy few servers and then configure it, install applications, install softwares, and then copy your code to that, make it run, and then make it online. So this takes a lot of time, as well as once it is running, you will also have to maintain them. So the maintenance cost will be very high, and that is one of the reason people started to shift off with cloud computing. And then increase in expenditure. Obviously, if you want to buy more servers, you need more capital, and to maintain them, you'll have to hire professionals, and for them you'll have to pay. So that also increases the expenditure. Data privacy and security is poor because you will have to hire security professionals, a lot of security professionals. If you are having a lot of servers, take care of it. If not, obviously your security will be poor because you will not be active all the time. Any security professional cannot be active all the time to keep on checking if there is a bug or if there is a loophole. And then finally, scalability and flexibility. Flexibility in the sense, if you have 10 servers, you cannot easily give back 2 servers and reduce your expenditure. You cannot do that if you bought 10 servers. And scalability in the sense, so if you have an application which is utilizing 10 servers, now suddenly the traffic is increasing. So now you want more servers, so you go buy 5 more servers, and now you have 15 servers. Right now, the application is using all 15 servers, but suddenly one day or for 1 week you don't have any spike in traffic and it is only using 10 servers right now. So now the 5 servers are sitting there idle, costing you money. So this again was an issue. So then cloud came into the picture. So they gave you better data security and data privacy because they have hired 3,500 plus security professionals for their data centers, and their data centers architecture is obviously more secure and complex than a private company's data center. And then no maintenance worries. They'll take care of all maintenance. They'll monitor it, they'll maintain it, they'll patch it up. Faster data recovery. So if you have your servers and if you have data in it, if your servers are destroyed in some natural calamity, then you'll not be able to recover that data back. But if your data is stored on the cloud, you can have a backup somewhere else in another region. Even though that data center is down, you can get a backup of the data from another data center. Scale dynamically. So in cloud, you don't need to buy more servers. You just have to provision 5 more servers. And so let's say the same example, you have 10 servers for an application, traffic spikes. So you get 5 more servers. So now 15 servers are used. Suddenly traffic goes down. You only need 10 servers. Right now you can deprovision or terminate those 5 servers and use only these 10 servers. So this is very cost efficient. And then reduced costs. Obviously, if a cloud provides dynamically scaling option, obviously it will reduce your cost. You don't need to worry about maintenance. That will reduce your cost. You don't need to worry about security. Again, that will reduce your cost. Now, some facts about AWS. We'll just rush through this. So top companies like Netflix, Reddit, Expedia, and NASA use AWS for their hosting needs. And then AWS currently has 165 different services and it is increasing every single year. And then on average, people view 7 million online videos, and they ask Siri 100,000 questions, buy $222,000 worth of items from Amazon, and all of these websites and applications are hosted on Amazon Web Services. Now also, AWS owns a 47% market share in the public cloud industry, which is the highest, and they are at the number 1 position. And also AWS has 69 availability zones across 22 geographic regions, including India, USA, and all across Europe. So now they are also trying to bring 10 more availability zones in 3 different regions, which is Indonesia, Italy, and South Africa. So these are some AWS facts just to show how big is AWS. And other cloud providers: Azure, Google Cloud, Ali Cloud, IBM Cloud, VMware. So AWS is the number 1, and second comes Azure, then comes Google Cloud, then comes the other cloud services. Mostly we ignore them because the top 3 are AWS, Azure, and Google. And so in this session we are looking into AWS. So moving ahead, we'll check out why should we use AWS. So we discussed about AWS and we also saw other cloud providers. Now you would be thinking that why should I not use Azure, or why should I not use Google Cloud? So you can use Azure or Google Cloud, but why should you use AWS? That we'll look at now. So first, AWS launched. So AWS were not the first cloud providing company, but they were the best cloud providing company. So just a rhyme. So AWS came into picture in 2006 with EC2 and S3. These were the first services which came up. So they revolutionized the IT industry by introducing a new way to use servers. So normally an IT company will buy servers, configure it, put their application, run it. But when AWS came into picture, they told that They told companies that you don't need to buy servers. We'll buy servers. We'll take care of them. Just give your application to us. We'll host it on them. So basically, you won't give your application's code. They give you the permission to host your application on their data center, and it will be running. You just pay for the servers which is used. They'll take care of maintaining. So this was a great gift for any IT company, because it will reduce their costs, as well it will reduce their maintaining needs, and they can concentrate more on developing the application rather than hosting it. Then other things why you should use AWS is, other pointers are, first, simple and per hour billing. That is, if you're using a service and if you're using it just for an hour or 2 hours, you won't get billed for a month. You just get billed for 1 or 2 hours which you have used. Amazon's brand name. Obviously, Amazon is the largest e-commerce company in the world. They have other things like, there is Amazon Prime Video, there is Amazon Music, there is Amazon Kindle. So there is so many things, and Amazon is one of the biggest names in the internet industry. So that is one plus. Third one is, it is very easy to get started with AWS. It is like creating a profile for your Facebook account, but just one more step, you will have to provide your credit or debit card details, so that if you're using some services, obviously you will get billed. But AWS also provides a free tier. We'll discuss about that later. So right now, these are the three major factors why people prefer AWS. And I've already told you that AWS is leading. So this particular chart is just for 3-month period on Q2 of 2019. So in Q2 of 2019, Amazon had 33% share, Microsoft had 16%, and Google had 8%, and other companies, you can just look at them. So worldwide cloud infrastructure service revenue was $23 billion. And in that $23 billion, 33% was AWS revenue. So this shows how big is AWS. And obviously, if a service or if a cloud provider is huge enough, many companies are going to use it, or they're already using it. So if a lot of companies are using AWS, so if you learn AWS, obviously there is a lot of job opportunities. Okay, so now we've discussed various factors. We discussed what is AWS and why should you go ahead with AWS. Now let us look at some AWS services. First, these are some domains on which AWS has services. So compute in the sense a server, a database engine. So a database engine which you can host on that server. So they also have separate database services, but as a compute service, you have these. And you have database services, you have storage services, you have migration and transfer services. This is these are very amazing tools in migration. So there are database migration services, and there is a virtual machine migration service as well. So in a database migration service, you can directly migrate a database hosted on your on-premise system, on-premise server, to the AWS cloud in just a few minutes. So you can do that. And then customer engagement, you have customer engagement applications as well, like chats and email services. Then you have security, identity, and compliance. Obviously, you need security and also identity services for AWS, because there might be multiple users using a single AWS account, and for that you need identity. And then management and governance. So obviously you'll have to monitor and manage your AWS account. Even though AWS is managing your servers, you will have to manage your AWS account. And for that, you have monitoring and managing services. And then networking and content delivery. So for these services, that is compute, database, and storage, to run, they should be running inside a network. So to create a virtual network for yourself, so let's say you're creating a virtual network and launching 2 servers within that, and another server outside of it in another network cannot communicate with it until you give permissions for that. So you can create your own private networks. And also content delivery, that is, you can also have a CDN, a content delivery network. So YouTube uses a content delivery network, but YouTube uses Google's own content delivery network. And in AWS also, they provide a CDN called CloudFront, and you can use it for your own streaming needs. Okay, so now let us discuss few services. So EC2 is a compute service, and this is the most integral part of AWS itself. So because most of the AWS services uses EC2 for one or another reason. So first, let me tell you what is EC2. So the full form of EC2 is Elastic Compute Cloud, and EC2 is basically an on-demand server system. So EC2 enables on-demand scalable computing capacity in the AWS cloud. So what does this mean is it provides you a virtualized server running on the AWS data center, which you can just launch in a couple of seconds and use it for your own needs. You can use it so you can use it as your own PC. You can use it to launch applications. You can use it to host applications. So instead of buying your own server, you can just launch a virtualized system, which will be like 10 to 20 times cheaper than maintaining your own server. So this is EC2. I'll go more in depth in the hands-on. And then comes RDS. RDS is a relational database service. So it is a service which gives you a relational database over the AWS cloud. And these are the options, that is MariaDB, PostgreSQL, SQL Server, MySQL, and Oracle. And Amazon Aurora is a sub-feature of RDS where you can launch PostgreSQL and MySQL databases, but they will be much faster because it's a different architecture. So we'll not go into that. We'll discuss that in another session. So this is one of the service which is commonly used in AWS. And then comes S3, the most used AWS service. So S3 is a storage service. Basically, it is a binary storage service. You can store anything you want. Everything will be stored as an object. So you can store an audio file, you can store a text file, you can store a video file. So all of this is stored inside bucket. Bucket is like a repository. So in S3, there is no hierarchy concept. There is no file hierarchy concept. So there is no folders. Every single file is stored in the bucket. You can create virtual folders. So it will seem like there is a folder, but it is just creating paths. But every single file is stored in one single bucket where you can just leave your hand inside and search for the right object and pick it up and use it. So this is S3. And then there is IAM. This is a security service. So let's say, for example, you have an admin, cloud admin, you have a web developer, and you have data scientists working in your company. Now for the admin, you want to provide all the access. So this admin should be able to add users, remove users, give permissions to those users. Second, web developer. So you should provide permissions to this particular web developer only to the web development dashboard or to any services which he requires, like databases, EC2, or Elastic Beanstalk. So you can give permissions to this web developer to only access these services. And for a data scientist, you can only give access to the services which he requires. You don't need to give permission for every single service in AWS. So if the data scientist just needs 5 services, you can give permission for this data scientist to use only those 5 services, and he'll not be able to use any other service. So this is why you use IAM, to give permissions, to create users, to create groups, and you can also do a lot of other security features. It has multi-factor authentication as well. So there is a lot of features. We are not going to go deep into IAM right now. This is one of the important services you'll have to learn if you are going to start off with AWS. Okay, so now we've discussed these few services. Now let us do a quick hands-on. Okay. So I have already logged into my AWS management console. So this is how it looks, and this is my username. And if you click here, you can see my account, my organization, and then billing dashboard. Here you can see if you have any bills or not, and you can create billing reports and stuff. And here you can see your security credentials. I'm not going to go deep into this because it's a very huge concept. Okay, so now this is how your management console looks. So now you can see these are the recently visited services, and coming down you can see all these services available here, and there are these many services. So learning AWS is not that you'll have to learn all of these services. Nobody can do that. Even Jeff Bezos cannot do that. But you'll have to know enough services for you to do something effective for a company. So let's say you've learned EC2, you've learned databases, that is RDS, you've learned DynamoDB, you've learned S3, and let's say you've learned around 10 services. So now with these 10 services, will you be able to create an architecture which can host an application successfully and also be highly available? If you can do that, you can easily get a job in AWS. So now let us do a quick demo in EC2 because this is the most basic thing you'll have to learn first. So this is the EC2 dashboard. So now you can see running instances, dedicated hosts, volumes, key pairs. So I'll explain first running instances. So this shows how many instances are running, that is servers. In AWS, servers mean instances. We don't call them servers directly, we call them instances. And volumes, obviously, if you are running a server for the storage purposes, you need a volume. So it will automatically create a volume. And to log in to this particular instance, you need a key pair. So the private key is with you, the public key is stored on the server. So while logging in, you will have to provide the private key. And if the private key is able to decrypt the public key, only then you will be given access to the server. So this is to prevent unauthorized access. So this is a very secure method. So if you provide your private key to another person, obviously they'll be able to log into your server. So you should not give the access to them. So now let's get started. I'm clicking on this. So I'm going to launch an instance. So I'm going to basically launch a server. So I'm going to launch an Ubuntu server. So first thing after clicking on launch an instance is AMI. And AMI is, let's say it is a copy of a server. It is called an Amazon machine image. So what is the purpose of an AMI is, so let me come down. So here you can see an Ubuntu server 18.04 AMI. So this AMI is it is like the ISO file which you use to create a virtual machine on your local system. So this is the exact same thing like an ISO file, but for a cloud system. So now if I use this AMI to create, this AMI will already have all the configuration files which I require to create a Ubuntu server, to create a Ubuntu OS, to run an Ubuntu OS on a server. So this AMI will already have all the configurations. It will run everything for me and set up a Ubuntu server for me. So this is the most basic thing you'll have to learn about AMI. So if you use an Ubuntu server AMI, so you will get a Ubuntu instance. So now I'm using this. Next is choosing an instance type. So there are so many instance options, guys. So first, it'll automatically select the free tier eligible instance type, because for practice, you don't need to go ahead with a large one. Free tier eligible is fine. Why free tier eligible? In the sense you don't get billed. We'll discuss about this later. There is a free tier capability in AWS. So you can see this particular free tier instance will give you 750 hours of free usage. You don't get billed for that 750 hours. So let's go ahead with it. But there is also huge servers. So you can see if you want, let's say if you want a server with 48 virtual CPUs and 384 gigabytes of RAM, or if you want a server with 96 virtual CPUs and 768 gigabytes of RAM, you will still get a server like that. But these services, and if you even run them for a minute, you will get billed a lot. So don't do that. Go ahead with a free tier eligible server. Next, configuring instance details. I just need one instance. So I'm not going to go to the network and subnet concepts. These are again huge concepts. Coming down here, so enable, so it will already be in enable. So do not disable it because we are launching a public server. So I should be able to launch a website in it. So to check out the website in your browser, you need a public IP address for the instance. So to get a public IP address, you will have to enable auto assign public IP. Otherwise, you will, after creating the instance, you will have to manually assign one. So now this is done. Next, 8 GB of storage is more than enough for my Ubuntu system. If you want more, you can just change the size over here. And this will be your root directory. You can create one more volume if you want to. You can create multiple volumes, and that is no issue. Next, tags. Tags are basically to trail. So let's say you have 10 different instances, and in that 5 different instances are for a website and other 5 are for general purpose. You're just having them for other issues. So now you can just tag all that 5 servers which are for your website as web servers, and so you can give it web server, and then if you just type in web server in the search bar, you will get all those 5 instances. So this is just to keep track of it. So you can give a tag if you want to. and it is not it is optional basically. Now SSH. So to SSH into an instance, you will have to provide the SSH permissions. So the port number 22 is for SSHing, that is secure shell. So why secure shell in the sense? So as I told you, you'll get a key pair. The public key will be on the server. The private key will be on your system, that is your local system. So now what you'll have to do is you'll have to provide your private key to the server. But how will you provide it? So you will provide it through a secure shell. You'll be providing it through SSH. So for that you need SSH, and for logging in you need a service called Putty. So I've already have it installed, and if you want that, it's pretty simple. Just type in download Putty and you'll get it. So no issues. And also I'm going to launch a web server, so I'll just give HTTP so port number 80, because I'll be launching a web server which requires the port number 80. So I'm just using it. Next, and then review your server and then click on launch. So I think so I have this key pair. I'll just check once. It's not available, so I'll create a new one. Yeah, so I'm creating a new one. I'm giving a name for it as YouTube Live, and download it. So it'll be in my downloads, let it be. So now I'm launching the instance. So now the first part is done. The second part is to convert your PEM file, because if you are having an Ubuntu system or a Linux system, you can just use the PEM file directly using the SSH command. But if you are using a Linux system, you will either have to have a Linux emulator, or you will have to convert this PEM file into a PPK file. PPK in the sense Putty private key file, because you're using Putty to do SSH. So Putty only accepts a PPK file, so that you'll have to convert. So if you have downloaded and installed Putty, it will also install a software called PuttyGen. So in PuttyGen, go to load and go to downloads, and it's not available. Oh, sorry, it's searching for Putty private key files. All files, and you can see the YouTube live.pem file over here. I'm opening it and I'm saving the private key. And I'm saving it in my desktop as YouTube Live. You can give it any name. I'm giving it the same name. So right now I've converted it using the PuttyGen software. So just load your PEM file and it will automatically generate a private key. Then save the private key and close it. So done. Even my instance is running right now. So one more thing I wanted to show you is you can see a public IP address over here. So now if I copy this and paste it here, you will not see any website running because I don't have a web server running in my instance. So once I run my web server, you will be able to see that. So for that, you'll have to log into your instance. So copy your public IP, open Putty, paste your public IP under host name or IP address. Port number is 22. Connection type is SSH, which is secure shell. Then go to SSH, expand it, go to authentication. Under authentication, click on browse, choose the private key file, which is basically connected with your instance, because my instance has the public key of YouTube Live private key. So I'm going to choose that and I'm going to hit open. So if you get this particular security alert, so basically it means that you trust this host. If you trust this host, just click yes, and you'll be given permissions to log in. So I've launched a Ubuntu system. So for me, the username would be Ubuntu. If you have launched a Linux system, the username would be EC2 user. So this is the Ubuntu system. So I'm going to go with Ubuntu and it'll log in. So I'm successfully logged in. Okay. So now, right now there is no web server. So what I'm going to do, I'm going to run a web server. So there is a web server called Apache 2. So you can learn about that later. You can just do a Google search of Apache 2 and learn what is it, because I'm not going to go into Apache 2. So it is sudo apt-get install Apache 2. Yes, and now it will install a web server. So once it is installed successfully, if I refresh this, you will be able to see a default web page. Let me refresh this, and now you can see a default web page running in my public IP, which is my instance's public IP. So where is this file? So let me show you that as well. So now let me open this folder. So under var, under www, and inside that there is a folder called html, and if I do an ls, you can see an index.html file over here. So this is that file. So let me remove this file. So I don't have permission, so I'll have to use sudo. So now there is no index.html file. So now you can not see the web page. Okay. Now let us create a index.html file. I'll just type in hello world and save it. Okay. Now if I refresh this, you should be able to see the hello world page. That is, I've successfully hosted my website on my own server. So this is how you do it, guys. You can easily get started with AWS. So I think you understood the easy to part, and it's pretty easy to get started with it. So first of all, EMR is called Elastic Map Reduce, and it is a managed cluster platform. So this will simplify big data frameworks. So let's say you want to run Hadoop on the cloud. So instead of running a server, downloading Hadoop in that and configuring every single step, you can just go ahead with Amazon EMR, just type in the name of your cluster, choose the softwares, choose the big data tools which you need. Once you've done that, you can give how many nodes you want, that is the master and slaves. So let's say one master, two slaves, you can have that. Once you mention that, you'll have to provide a role, and that's it. You'll just have to click on create cluster and it'll do the rest for you. So that's how simple Amazon EMR is. Now let's look into the benefits of Amazon EMR. So first of all, if you look into this, there is cost efficient. So that, as I told, you'll just have to pay as you go. Then allows AWS integration. You can integrate it with other AWS services. Then comes easy deployment. As I told you, you'll just have to give in few details and hit click. It'll automatically do that. And then comes scalable and flexible. So as I told you, there is auto scaling available. And also it is flexible because you can terminate it, you can stop it whenever you want. It is reliable because they provide you an SLA of 99.9%, which basically means it never goes down. It is always on. And then secure. So obviously AWS provides you a lot of security features. You can use IAM, which is for identity and access management, where you give permissions to users. If they have the permission, they'll be able to use this particular service, EMR. If they don't have the permissions, they'll not be able to use it. And then easy to monitor. So there is a service called CloudWatch. So it is automatically integrated with all the AWS services. So you don't have to even do anything. You can get the metrics automatically. Finally, easy management. You're not going to manage anything. You're not going to patch anything. You're not going to add any code. You're not going to debug it. Everything will be taken care by AWS. You'll just have to set it up, and that's it. So we've seen the benefits as well. Then the EMR architecture. So how exactly it is hosted in the cloud? So that would be your question, right? So let's say in your local system, you would have the Hadoop ecosystem, because you'll be downloading it, and then you'll install it, you will configure it, you will set it up. In the cloud, it is almost the same architecture. So you can see that EMR architecture remains identical to the normal Hadoop cluster architecture. Local file systems of the nodes, HDFS or EMRFS, are used as storage nodes for EMR. So you can use the local file systems of the nodes, that is local file systems in the sense, the local file systems which is hosted in the cloud. So that local file system is basically Amazon S3. So S3 is the backend for HDFS. So as I told you, S3 is used for storage. So S3 is also used for storing that is storing files in it. So using the EMR file system, that is EMRFS, Amazon EMR extends Hadoop to add the ability to directly access data stored in Amazon S3. It is not that you'll have to push the data into HDFS and then you'll have to analyze it. Instead, you can store the data in Amazon S3 itself, and directly from S3, sorry, yeah. So directly from S3, you will be able to query and analyze the data. Most often, Amazon S3 is used to store input and output data, and also the results are stored in HDFS. So these are the temporary files are basically stored in HDFS. The input data and the output data both are stored in S3. So this is how it basically works, guys. It's pretty simple. It's a cluster format. If you know about the big data services, it is the same architecture on AWS as well. So if you don't know the architecture, I tell you, so I ask you to go and please go and check that out. Check out HDFS, check out Hadoop, check out Map Reduce and all that. So once you get an idea of that, you will get an idea of how it is hosted on the cloud, because it's similar. So let's say it will have a backend server running, and in that backend server, Hadoop will be installed, configured, and everything would be set up over there. And once that is set up, guys, Amazon S3, it is pretty simple. I'll show you how to start up with that as well. And then you will be able to set up whatever service you want: Hive, Hadoop, Spark, HBase, anything. So this is the basic architecture. Okay. So the main processing frameworks available for EMR is Hadoop MapReduce and Spark. So one more thing, the most popular frameworks are Hadoop and Spark. There are other frameworks which you can use on EMR as well, but the most popular ones are Hadoop and Spark. Okay, so now EMR applications. That is, what are the other applications available on EMR? As I told you, you can see over here, it supports many applications: Hive, Pig, Spark, streaming platform. It supports Yarn, it supports Hue, it supports mostly all the Apache products, that is the Hadoop ecosystem products. So you can go ahead and look into that more. So we'll not be covering this a lot. Now, next I'll be doing a hands-on using Hive on EMR. So let's do that. So in addition, Amazon EMR also supports open source projects that have their own cluster management functionality instead of using Yarn. So instead of using Yarn, if you're using your own resource management, then that is also fine. So EMR allows that as well. So we've seen that. So now let's do an hands-on on Amazon. So this is basically a getting to know session. So you will get to know how to start off with AWS and AWS Big Data. So first of all, to start off with this, you will need an AWS account. So I suggest you to get an AWS account soon and start practicing, because this session will be available in our YouTube channel and you can go through over that. Okay. So right now I'm already in the EMR console. I have logged in and it's pretty simple. And you can just search EMR over here and click here and you'll be inside the EMR. Yeah, so I'm here. So just 1 second, I'll have to show you S3. Okay, first of all, let's create a bucket here. So what we are going to do, we are going to create a bucket to get our output. So our output will be stored in the bucket we are going to create. So this is very simple. Click on create bucket, provide a name. So let me give as YouTube live webinar 1. And I'm going to just create. I'm not going to set up anything. I'm just going to create this. So it is this simple to start a bucket. So a bucket is basically a repository or a folder where all the files are stored. So it's pretty simple, guys. You'll just have to remember that. So a bucket is basically a folder where you can store all kinds of files. It may be video, audio, all kinds of binary files can be stored here. So we've created a bucket. So you can see there's an upload option as well, but we're not going to upload anything over here right now because this bucket is for our output. Okay, now let's start with EMR. But before starting with EMR, I'll just get a file. 1 second. Yeah, so the file is over here. Just a second, I'll just close these. Yeah, okay. So we are going to create a cluster. So while creating a cluster, I'll be explaining that. So first of all, to start off with EMR, get yourself an AWS account, but there is no free tier in EMR. So there will be a small charge. It will be around let's say $0.04, something like that. It'll be a very small amount, so you can go ahead with that. But make sure that you terminate your cluster immediately. So just a second, guys. I'll just get some water. Okay, guys. Let's start off with this. So create cluster. So first of all, to start off with EMR, as I told you, get an account. Then you can start off with this. Then come to Amazon EMR. Go to clusters. Click on create cluster. Okay. So now it's the simple setup. It's very, very simple. Yeah. Okay. So first of all, give your cluster a name. I'm going to name it as webinar cluster. Okay. And then let logging be on. Logging in the sense, whatever happens, the setup, let's say the configuration, everything will be loaded and it will be stored in this folder. So it will be stored in this folder in S3. So let it be. That's fine. Next, coming down. So this is going to be cluster. We are going to start with a cluster and software configuration. So this is where you'll have to choose, guys. So here you can see core Hadoop, that is Hadoop, Hive, Hue, Mahout, Pig, and Tez. So anyway, we are going to only use Hive. So I'm going to choose first one. Then there is for HBase, Presto, and Spark. If you want more options, if you want to choose multiple services, you can click on go to advanced options. And you can see here, you get to see all the available applications. You can choose whatever application you want. Example, TensorFlow, Zookeeper, if there is Kafka, then there is Flink, Tez. You can choose whichever you want, and then you can set it up. But right now, we are going to go with quick options because it's easier to understand at the start. So it was the same. So I'm not going to change anything. And so you can see, yeah. So I'm going to go with core Hadoop. And this is the most basic instance type in EMR. So let it be. And the number of instances are going to be 3. There will be 1 master and 2 core nodes, which is basically 1 master, 2 slaves. So that will be a master slave architecture. And then I'm going to choose an EC2 key pair. Anyway, we're not going to use this. But if you want to log into the Hadoop system and check out what is happening inside of it, you will need this. But anyway, we're not going to open it. But still, I'm showing you. So key pair, you can learn about the key pairs and how to log in with a key pair from our other AWS tutorials in our YouTube channel. You can check that out. Okay. So this is my key pair and choose a permission. I'm going to go with default because it's already configured, as we'll be taking the data of pushing the data into S3. So I'm going to go with this. Yeah. Okay. So now you can see this, and if I hit create cluster, it will start. But I'm not going to do because I'm going to go and do this exact same thing in advanced options. I think I understood this part. If I click create cluster, it will create a cluster. So there is one small step in this. That is, we'll have to mention the input data and the output folder where the result has to be stored. So I'm not going to make any changes. It is going to be the exact same configuration. I'm not going to change anything. The only change we'll be making is adding a step. So our step would be a Hive program, because that's what we're going to do. We are going to include a Hive script. So I'm going to click that and I'm going to click add step. Okay. So you can see script S3 location. So we'll have to provide the location of where the script is available. Then we'll have to provide the S3 location of the input files. And then we'll have to provide the output location, which we created. Okay, and an argument. Okay, so that is fine. Coming down. So this is what I wanted to show you guys. So if you want to check out this, you can just go ahead with the documentation provided by AWS for Amazon EMR. So this is one of the tutorials they provide. So this is the script link. So the script is over here. I'll explain to you about this. This is the script. This is the script link. And this is the input folder. So as you can see, this is the input folder of the S3 bucket. And inside this bucket, there is a sub file called CloudFront. Inside that, there is a sub file called code. And inside that, there is the script file. Okay, that is fine. And then there is the input. Okay, and this is basically a command which AWS told to add in the argument section, so that if there is any keyword mismatch, it'll automatically take care of it.
Just a quick info, guys. If you want to learn data engineering, then Intellipaat provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job. Now let's continue with the session.
Just a quick info, guys. Test your knowledge of Azure by answering this question. Which of the following web applications can be deployed with Azure? A. ASP.NET, B. PHP, C. WCF, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
That is fine. Next, coming to summary. So this is the script which will be running in Hive. Okay, so you can see this, and this is pretty much it. What exactly we are doing right now. So this sample shows you how to analyze CloudFront logs stored in S3 using Hive. So we are using Hive on EMR to analyze logs which are generated from CloudFront, but we are not going to do anything in CloudFront. That logs are already stored in S3, but not in mine, in AWS's official sample repository. So we are going to take that data, push it into Hive, and once it is in Hive, this script will run. This script will process the data and give us the output, and we can download it and check the acquired results. So to check that, first of all, you'll have to set it up. And before that, you can see over here, you'll have, so this script is creating a table. So it's creating a date. It's you can see local time, location, bytes, host, OS, and browser. So what we're going to do is we are just going to get the count of the OS inputs. So coming down, you can see total requests per operating system for a given time frame. So what result we are going to get is, for example, there is Mac OS, there is Windows, there is Ubuntu, then there is Android. So all of that operating systems. So let's say in CloudFront, there is an application running. So CloudFront is basically CDN. Okay. So there is so let's forget about that. Let's just concentrate on this. There is an application running, guys. So that application could be accessed from all kinds of operating systems, from a Windows system, from a Mac system that is an Apple laptop, or from an iPhone, from a Safari browser, which is an iOS. Then there is Ubuntu, then there is Android. So that application could be accessed from all these operating systems. So the output we'll be getting is how many hits were from each Windows or Mac or any operating system. So the output would be the operating system and the number of hits this particular application got from that operating system. So this data is already available, so it's not going to be dynamically changing. It is static data. Okay, so I think I've explained to you this part. Now let us start off with configuring this. So first of all, I'll have to provide the S3 location. So this is the S3 location. So I'm going to provide this. Done. Next is the S3 input location, which is this. I'm going to provide this. Next would be our output S3 location. So for this, we can search over here. And this is the bucket which should contain our output files. So I'm going to click it, select. Okay, next is the argument. I'm going to copy this and paste it over here. Just a second, guys. I'll just get some water. Yeah. So now this action on failure is, if this particular code or this particular process fails, it should continue and create this particular cluster. Or you can cancel and wait. So basically the cluster will be stopped and then terminate cluster. If this particular for this script we are running fails, then this cluster will be automatically terminated if you give terminate cluster. But I'm not going to give that. I'm going to give continue. If this step fails, our cluster will still be active. So that's what it means. So now I'm clicking on add. And you can see we've set this up. That is the only extra step. I'm just going to give next, next. I'm not going to change anything. Yeah, so you can review it once. So you can see it is proceed without an EC2 key pair. I'm going to give my key pair and create cluster. So guys, it will take from 5 to 10 minutes to create this. So you can see the steps over here. You can see first this step will be completed. That is, the setup will be completed. Then Hadoop and debugging, everything will be completed. Once that is done, the Hive program will start running within the cluster. Once that is done, we'll be able to see our output in this particular bucket. So if I open this bucket right now, you'll not be able to see. Let me just refresh. Yeah, so I'm inside the bucket. So right now there are no files inside this bucket. Once this is done, we'll be able to see that. So as I told you, it'll take some time. So let me click on clusters. Here you can see I already had a cluster which I terminated. So you can see it is my cluster because once I went into advanced options, I did not change the cluster's name. So it was my cluster only. So it's the same. It is right now starting. And once we see complete over here, then this process will start. And once this is complete, this process will start. And only then we'll be able to see the output. So then we'll download the file and see the output, guys. So I think that's clear right now. So this process is still starting. So as I told you, it'll take from 5 to 10 minutes to this getting completed. The thing is, we added a step before we launched. You can also add a step once it is set up. So you can see here, you can also add you can also add a step once you've created your cluster. You can choose a pig program, a Hive, a streaming program, or a custom jar program. So if I want to add another Hive program, it's again the same setup, and you can do that. Okay, so we've seen this, it's still starting, so there is nothing else to do over here. Okay. So while doing this, I'll also explain the other things about this cluster, because there is no need to waste your time as well, because it's everybody's precious time over here. Okay, so coming to hardware, you can see this because we wanted to launch 3 instances. One is one is a master instance, 2 core instances. You can see the 2 core instances are created. The master instance is currently under creation. And so right now we have not enabled any scaling policy. Let me explain to you about the scaling policy. So it is basically for auto scaling. Click on edit, come down. So you can see enable cluster scaling, use EMR named scaling. So come over here. EMR will automatically increase and decrease the number of instances in core and task nodes based on workload. So if the workload increases, it will automatically increase the number of instances. If the workload decreases, it will automatically decrease the number of instances. Okay, let me close this. I'm seeing running over here. Yeah, so the instances are running, guys. So you can check out the steps over here as well. You can see the instances are running, but the steps are still pending. So now this step has completed. So once the instance is run, it got set up in 4 seconds. If you want to check out this logs, just click over here. So right now there are no logs. So once the log is created, you can just refresh and see over here, and that logs will be available in S3, and you can go check out those logs. But this step is still running, and now it is completed, guys. So let's go over here, refresh this, and hope that we get an output. And we got an output. So let me open this folder and let me download this. Okay, sorry, that's not the folder which we want to download. We can download that, or we can go inside and download this. So the thing is, we have 2 nodes. So why do we have 2 nodes is that we'll be splitting work and giving it to each instance. That is, the half or some of the work will be given to the first instance, and some of the work will be given to the second instance. So you see 2 files over here. So this file would have been processed in the first instance. This file would have been processed in the second instance. So now let's download. Sorry, I think it's not possible. Let me click download the first one. Click and download. Sorry, I downloaded it multiple times. Okay, so we've downloaded it. I'll go to the folder. So as I told you, the output would be uh, the OS name and the number of hits. And you can see this. Let me open this as well. Okay, I think you're able to see right now. You can see Android 855 hits, Windows 883 hits, Linux 813, Mac 852 OS X, which is for the Apple laptops, MacBooks. So it's 799, and in iOS it's 794. So we've got the files, guys, over here. So this actually means that our program ran successfully. We created we created an EMR cluster successfully. We ran a Hive program on it, and we also got an output. The thing is, this file is very small. That's why we got an output in less than a minute. But if your file is very, very large and it takes a lot of time to process, then obviously it will take around 10 to 15 minutes according to the size of your file. And sometimes it can also take hours, because you might have, let's say, petabytes of data. Okay, so we've come to the end of this session. So going back over here, we've successfully created the cluster. We ran a Hive program, and both of the steps have succeeded. You can just click here. Yeah, so both of the steps have been succeeded. So it is waiting because right now there is no process running. If you want to add a process, you can click on step and add another program to run your program and process data. So you can do that. You can see all the interactive jobs over here. If there is any current job running, you can see the job. So for example, we were running this Hive program. So while running, we could have seen that job over here. So the thing is, this cluster can be shared among other users in my AWS account, so that all of them can run a job at the same time, and we can check all the jobs running over here. So I think that's pretty much it. So it's pretty simple to start off with this. It's pretty simple to create a cluster, run your own program with your own input data set. The thing is, while running the Hive program, we gave an input data link. So instead of providing that link, you could provide your own data set, and you could provide your own Hive script, and you could provide your own output location. So output location is pretty simple. You can just give any location which you want, but the input script and the input data location should be provided, and that's it. It will automatically run the script and get your data processed. You can download the upload and take the data and do whatever you want with it.
What is Azure Data Factory? Data generated by several applications and product is increasing exponentially. So we all know that we are living in the world of data. So all the different applications which are running, they are generating millions and millions of data. Azure Data Factory, or we lovingly call it as ADF, falls under the identity domain of services in the SEO, which is nothing but the search engine optimization catalog, and it is cloud-based integration services. Basically, it works on data. It orchestrates and automates the movement or transformation of data. So ADF, or Azure Data Factory, is a code-free ETL or ELT solution, which is completely based off cloud. You don't need any hardware. You don't need any licenses. You don't need any kind of setup. You quickly can go in without using a single line of code. You can perform your data movement as well as orchestration. As data is coming from number of different products, to analyze and store all this data, we need a powerful tool. Azure Data Factory helps us here. How does Azure Data Factory help us? Storing data with the help of Azure Data Lake Store. So Data Lake Store is nothing but a Hadoop compliant storage. We have the Azure Data Lake Store, which is Microsoft implementation of Data Lake Store. We can analyze the data. We can transform the data with the help of pipelines. A pipeline is a component in Data Factory which groups the related activities to perform a task. We'll see that in detail. Publishing the organized data. Visualize the data with third-party application like Spark or Hadoop. So Data Factory has support for Spark baked in inside as out-of-box solution. Now, how does a data factory pipeline flow? So you can see that this is an architecture diagram of a data factory pipeline. So first and foremost, we have the input data set. What is an input data set? It's nothing but the data which we have in our data store. We need this to be processed. So we pass the data through the pipeline. So input data set is nothing but the source data that we capture, which is coming from the source. Then we have the pipeline. So this is the building block of data factory. It basically performs an operation on the data that transforms the data, which could be anything from just data movement or some kind of transformation. So it can happen that you get your data from a source and you want to push it to a destination without doing any kind of transformation. So let's take an example that you get your data from an FTP location, and from that FTP, you want to push it to a SQL database without doing any kind of transformation. You can do that. On top of that, if you want to do any kind of transformation, you can do transformation right from Azure Data Factory using the power of Apache Spark, and then push the data to your destination from source. Then we have the output data set. This contains the data that is in a structured format, as it has already been transformed in the pipeline storage. It is then given to link services such as data lake, blob storage, or SQL. So output data set, I won't say that every time it is structured. You can work with semi-structured output data also. So you can work with JSON, XML, and other semi-structured data set. And then you can push this for your consumption. Now, where do you want to push your data? Of course, you can push it in multiple locations. You can store it in a data lake store, you can store it in a blob storage, or you can store it in a SQL. Now, to establish the connection with these sinks, we use something that we call as link services. Then, what is a link service? Link services store the information which is very important when it comes to connecting to external data sources. So link services are nothing but the username, password, server name, database name. So the connectivity informations are stored in your link services. So there can be different types of link services. You can store it in a data lake store, you can store it in a blob store, or you can store in a SQL. It's not just limited to these three. There are way more link services that we can access in Azure Data Factory. Then we have the gateway. So this is an important concept. What is a gateway? This is called as gateway, or we call it as a data gateway, or we call as a integration runtime. This connects to our on-premises data to the cloud. So we do not need a client installed on our on-premises system so that we can connect to Azure Cloud. Now, there can be scenarios where you're getting your data from an on-premises source, or you want to push the data to an on-premises destination. In either way, since Azure Data Factory is a cloud-based approach, you have to set up a connectivity to the on-premises source or the destination. So what we have to do is we have to provide a networking handshake. Using the data gateway or the integration runtime, we can establish the connectivity between on-premises as well as cloud. Finally, we have the cloud. Our data can be analyzed and visualized with a number of different analytics software such as Spark, R, Hadoop, and so on. So this is the end way where we have analyzed our data, transformed our data, and finally we want to consume it. That's also possible using Data Factory. So why should we use Azure Data Factory? So there are just a couple of things which are listed here. It can be more than that, way more than that. Improves productivity with shorter time to market. Data Factory is a tool and it doesn't have any kind of language in it. So what we can do is the learning curve is very easy in here. You don't have to do much of learning. So you can very quickly grasp the concepts of Data Factory. So the time to market reduces drastically. It reduces overhead costs because it's a one-stop shop where you can perform your data movement as well as your transformation. So you don't need a lot of things to get involved, a lot of products to purchase. So the cost is very less, and cost is actually very less. If we see the pricing of Azure Data Factory, it's very, very cheap. Transfers data using pre-built connectors. So lot of connectors. If I'm not wrong, currently we have support for around 70 connectors, which is out of the box from Data Factory. So you don't need to create any custom connector. Of course, you can create, but most of the connectors that we use are pre-built in Data Factory. Integrates data cost effectively because the pipelines and the process is such user friendly, we can very easily save cost. Gets continuous integration and delivery, which is CI/CD. So we can easily connect with a Git repository and set up a CI/CD pipeline with ADF. It's very easy and works the way we want. So we can do our own custom logic in our Data Factory so that we get to know how we want to do this. It improves productivity with shorter time to market. It develops simple and comprehensive ETL and ELT process without coding or maintenance. So as I said, ADF is not just an ETL where we have extract, transform, and load. On top of that, we can perform ELT as well, where it's extract, then load, and then transform. So it doesn't require any coding or any kind of maintenance. It's completely code-free. It ingests, moves, prepares, transforms, and processes our data in a few clicks and completes our data modeling within the accessible visual environment. So Data Factory comes with its own canvas where you can quickly design your transformation logic and your overall program flow very easily. The managed Apache Spark services takes care of code generation and maintenance. So as I said, Data Factory has support for native Apache Spark out of the box. And the good thing is that this Apache Spark is a managed environment. So you don't have to bother about the infrastructure. You don't have to bother about the setup, the configuration, the maintenance of the Spark environment. It's completely managed by Microsoft. You can create your own programming logic without writing code. Please remember, we don't need to write any code, and you can use the power of Spark right from Data Factory. Reduces overhead cost. When migrating our SQL Server DB to cloud, it preserves our ETL processes and reduces operational cost and complexity. So it's kind of similar like we had in SSIS. If we want to migrate on-premises data to Azure, Data Factory is the de facto choice currently. It does everything with breeze, but it's not just limited to moving on-premises data to cloud. There are more things that we can do in Data Factory. It rehosts on-premises SSIS packages in the cloud with minimal effort using Azure SSIS Integration Runtime. ETL in Azure Data Factory provides us with familiar SSIS tools. So people who are coming from SSIS background, they'll be happy to know that Azure Data Factory is very easy to learn if you're coming from SSIS. The learning curve is very, very simple. You don't need to spend much time in relearning a lot of things. Most of the things will be very familiar if you're coming from SSIS background. And also, if you're still not convinced that you want to refactor your SSIS packages into ADF pipelines, you still have support to run your SSIS packages from ADF. So you can have your existing SSIS DTSX packages, which can be run from ADF. Transfer data using pre-built connectors. It gives access to the ever-expanding portfolio of 90 plus pre-built connectors, including Azure Data Services, on-premises data sources, Amazon S3 and Redshift, and Google BigQuery at no additional cost. So as I said more than 70, but it's actually more than 90, and it's increasing every day. So once we move and see a hands-on, you can see that there are so many pre-built connectors which are available right out of the box from Data Factory. So you can use Amazon S3 bucket, you can use Google BigQuery, Apache Impala, Azure Store. A lot of things are available pre-built out of the box in Data Factory. Integrate data cost effectively. It integrates our data using a serverless tool with no infrastructure to manage. As I said, this is a code-free, cloud-based ETL solution, which is a complete PaaS service and managed by Azure. For Azure Data Factory, we need to pay only for that what we use, and we can scale up the elastic capabilities as our data grows. Again, since it's cloud-based and it's backed up by Azure, it has a pay-as-you-go model. So whenever you're using Data Factory, till the point that you're using, the quantity that you're using, you only pay for that. And whenever you need to grow, scale up and scale down. It transforms data with speed and scalability using the Apache Spark engine in Azure Databricks. So as I said, this also has support for Spark infrastructure with you without bothering about the Spark setup and anything. So you can run big data also with Azure Data Factory. Works the way we want. Data Factory provides a single hybrid data integration service for all skill levels. We can use the visual interface to write our own code in Python, .NET, or ARM to build pipelines. We can add any processing services into the managed data pipelines or insert custom code as a processing step in any pipeline. So if you still want to use code, you have support to run your code in either Python or .NET or ARM, which is Azure Resource Manager. And still, if you're not convinced, you still have support to create custom components. So you can write your custom code and still use your pipelines. Gets continuous integration and delivery connectivity, so CI/CD. It continuously monitors and manages pipeline performance alongside applications from a single console with Azure Monitor. So again, as this is part of the Azure suite, so you can easily integrate this with Azure Monitor and you can visualize what is going on inside your Data Factory pipeline. It integrates our DevOps process using the built-in support for pipeline monitoring. So this can very easily be integrated with Azure DevOps. So you just have to connect it to Azure Git or a normal Git repository, and you can create your very simple and quick CI/CD pipelines for a continuous integration and continuous deployment. If we prefer a less programmatic approach, we can use the built-in visual monitoring tools and alerts. So not just it has support for Azure Monitor, Azure Data Factory itself comes with an inbuilt monitoring. So it is native to Azure Data Factory. If you do not want to use Azure Monitor, you can use the inbuilt monitoring tool, which is available inside ADF. Okay, now we're going to see what is an integration runtime in Azure Data Factory and what are types of IR that we have. So what is an integration runtime in Azure Data Factory? So integration runtime or IR is the compute infrastructure used by Data Factory to provide the following data integration capabilities across different network environments. So IR is essentially the backbone where the infrastructure is managed by Microsoft. So using an IR, you can perform data flow, you can do data movement, you can do activity dispatch, or you can run SSIS packages. So let's see what all things we can do. So in Azure Data Factory, an activity defines the action to be performed. So these are the terminologies that we use inside Data Factory. If you hear the term activity, this means the action that you want to perform in your Data Factory pipeline. A linked service defines a target data store or a compute service, meaning that this is the place where you define your connectivity and all the other related information. An integration runtime or IR acts as a bridge between an activity and linked service. So this is the managed infrastructure. Now, in Azure Data Factory, we have three types of integration runtime. The simple one is the Azure Auto Resolve IR. Second one is self-hosted. And the third one is Azure SSIS IR. Now, based on your requirement, you can choose any of the IR. Okay. So this is a pictorial representation which shows the different types of integration runtimes, which can be used in combination to offer a rich data integration capabilities and network support. So typically what we do is when we have our source and destination, which are both cloud-based, then we go for an auto-resolve integration runtime or an Azure integration runtime. If you have something which requires an on-premises component, Then we go for a self-hosted integration runtime. And Azure SSIS runtime is exclusive to run your SSIS packages. Now, you can use a self-hosted integration runtime to connect to cloud-based source and sink as well, but it's typically not used. So if your source and destination are both cloud-based, then we go for an Azure IR. If it involves any kind of on-premises component, then we go for self-hosted IR. Okay. Now, why we have this inside an Azure virtual network? The reason is that if you have something which is on premises, then we always should create an Azure virtual network, which will have all the network connectivity set up between your on-premises system and cloud. And using that network, we will connect via the integration runtime. And as you can see, using the Azure integration runtime, we can run Apache Spark program as well. So let's talk a little detail about the IR locations. Data factory location is where the metadata of the data factory is stored and where the triggering of the pipeline is initiated. So what it means is that since Azure is a cloud-based solution, when we create any resource, you have to provide a location of that resource. Data factory is also a resource in Azure. So when you create a data factory, we have to provide a location of that data factory. Now, whenever we create a data factory in a specific location, let's assume that I'm creating in India, since I'm based out of India. So let's say that I'm creating in a central India location. So whenever I will trigger my data factory, the metadata of the data factory will always be stored in central India, and the pipeline will start from that location. It's nothing but the physical data center where Microsoft creates your resource. Meanwhile, a data factory can access data stored and compute services in other Azure regions to move data between data stores or process data using compute services. Now, don't think that if I create my data factory in central India, I won't be able to access data which is stored in any other location. That's absolutely not correct. If you create a data factory which is based out of central India, if your data is in Japan, you can still access the data using data factory. This behavior is realized through the globally available IR to ensure data compliance, efficiency, and reduced network egress costs. Now, how does an ADF which is created in central India can access the data which is stored in Japan? That is the job of the globally available integration runtime. So this integration runtime takes care of connecting to your data and moving the data across the region, as well as maintaining all the GDPR policies along with efficiency and reduced cost. The IR location defines the location of its backend, compute, and essentially the location wherein data movement, activity dispatching, and SSIS package executions are performed. Meaning that whenever we create an integration runtime, by default, the integration runtime gets created in the same region as your data factory. But of course, you can change that from the data factory pipeline as well. It's not a requirement that the region where your data factory is, your integration runtime should also be in the same region. You can change it, of course. But what happens is, based on the region of your integration runtime, all your resources, your data movement, and everything will initiate from that location. Okay.
We'll be discussing about Azure Data Lake. Okay, so Azure Data Lake has two components within. It has storage account as well as ADLS Gen 2. So ADLS Gen 2 is a jazzy bird in the market as well, and then it's really a resource or a service offering which is given to you by Microsoft Azure. So what is the purpose of this storage account? So when I say data lake, right, just consider data lake to be either storage account or ADLS Gen 2. Before talking about the definition, I will tell you what is that resource. So storage account can also be considered as a lake account. So storage account, you see, right? This is itself the two flavors within. So you have two flavors within the storage account itself. One is the general storage account, and another is the ADLS Gen 2. So while creating, I'll show you both the flavors. But just consider when I'm talking about lake, it can be either storage account or ADLS Gen 2. Okay. So what is data lake account? So data lake can help you to store any kind of data. So it says that you can store any kind of blobs. When I say blob, right, blob can be CSV file, blob can be Parquet file, ORC, MPEG file, any particular file which can come in our mind. You can actually go ahead and save that data in data lake. And the good thing about data lake is, even if you don't have, you did not provide any instruction about while saving the data, right? Let's say that data size is of 1 GB, or let's say it's of 10 GB size, right? It will internally split the data into multiple chunks and then save it in a distributed manner. And when you extract the data again from the lake, it will be again a distributed read for you. So that's why you see a better performance when reading as well as when writing. So that's the beauty about data lake. And on the data restriction, data size restriction, there is basically no restriction in the size of data. So more the amount of data you save, obviously you are paying more. That you should always keep in mind. But if you save less, if you store less, you will basically pay less as well. And the costing of storage account. So just be mindful about this. Costing of storage account is just not related to storage cost. It also deals with the read cost, write cost as well. So let's say that I have stored my data once. Okay, let's say I have stored some 10 GB of data. Now I'm just not paying for that 10 GB of storage. And let's say I have a lot of customers who keep on reading the data from my storage account. So that read is also attributed within the storage account cost. And when I'm writing information to the storage account, that time also I'm incurring cost. So there are three components to the storage account cost. One is the storage cost, one is the read cost, and another is write cost. These three components. Okay. So I will just iterate through the theory in just 5 minutes or so, and then I will move on to the portal. Okay. So just watch out here. So it says the main objective of building a data lake is to offer a unrefined view of data to data scientists. With the increase in data volume, data quality, and metadata, the quality of analysis also increases. Data lake offer business agility. Then machine learning and artificial intelligence can be used to make profitable prediction. Data lake gives a 360-degree view of customers and makes analysis more robust. Okay, these are the just the definitions of data lake. Right? I'll just give you in simpler language. Now, in today's world, if you are using SQL database, right, for storing data as well as doing reports, you can actually do the same from lake as well. So instead of keeping the data in stage format, I generally call it as raw format. Okay. So in SQL world, you will call something as staging. In lake world, we call that as raw file. So let's say customer is providing me some file. I'll store as is into my storage account, and I will call that as a raw file. And I start processing the raw file, and there are multiple. Okay, no problem. So this is the lake architecture. Okay, so you might have heard about lake house architecture. At least you might have heard about that terminology, right? Lake house architecture. So I'll just explain about the lake architecture. Okay. So when data comes in from external system, right? Let's say upstream. This is the upstream where I'm getting the data. So I store in my lake in raw. I'll call that as a raw zone. Okay, and then I do some data quality checks, and then I store it in gold layer. I call this as gold because only when data quality succeeds, I will move the data from raw to gold. So what is the data quality check? Let's say I want to count the number of records before moving it to the gold layer. If the count is not nearby compared to the last raw file, right, then I will discard the I'll stop the processing. I'll not move the raw data to gold data. In a way, I'm actually providing more security checks before even moving to gold. Now I'll tell you more. Okay, let's say I'm moving it to published layer. I'll tell you what is published. Okay, publish is something which your downstreams can refer to. Okay, so what I'm doing is, let's say some people are doing dimension modeling in a SQL database, right? So in published layer also, I can keep all the files in different, let's say CSV files or Parquet files. I'll save those dimension and then fact tables within the published layer. Okay, and then that will be the source of truth for my downstream application. So if I'm maintaining the project, there will be some upstream, there will be some downstream. So when I am receiving data from upstream, my duty is to make sure that the data accurateness is maintained, data integrity is maintained. And once it is maintained, I will move the data to published layer, which is our fact and dimension. And then my downstream can be my reporting application also. Okay, just giving you a simplified answer. My downstream can be my reporting application, or my downstream can be some other projects who are looking up to my data. Once data is there in publish, you can actually share it with others. But you call raw as staging. You just consider staging as a schema. Okay, here I can consider raw as a folder. Under that raw folder, I can place multiple files. So raw is relatable to staging layer. And then from staging, you might move it to an intermediate layer. Okay, where I will just do some data quality checks and then move the data to the intermediate in SQL, which I call here as gold. And then I move the gold layer to publish. Let's say I want to perform some slow changing dimension 1, 2, etc. I want to formulate some dimension and fact tables. So I do some kind of transformations all over here. You also do the same thing and move it to the main table. So I call this as a publish layer here. So this is basically the lake architecture. If you have not heard about this, this will be very common when you appear for any interview in data engineering, right? People will ask you what is the lake architecture. You can explain the same fundamentals. Okay, so if I am managing a particular project, right? So I will have some upstream. When I say upstream, the project which is giving me data is upstream. Okay, and downstream is the subscribers who are actually looking up to my data, my project's data. So I will receive data from upstream and I'll provide data to my downstream. Okay, let's forget about push and pull mechanism. Who is pulling, who is pushing data? We'll not talk about that. My focus is to just explain the data lake architecture. So I'll just try to correlate it with SQL once more. So try to understand. Raw is nothing but staging. Staging we understand, right? The way upstream provides me the data, I keep the same thing in the same format. So if I may be receiving it in a CSV file. I may have a staging table where I store the data without doing any kind of transformation. That is staging layer for. So in Lake, I call that as raw. What is gold? I think as a part of transformation, you might be doing this in current world, but you have to invest time more on data quality checks as well. So when I move data from raw to gold, I have to ensure that I'm doing data quality checks. So example of data quality check is, let's say I'm expecting that a particular column should have only non-nullable column. It's a non-nullable column. It should not have any null entry. So I will do data quality check for that column. And similarly, there might be some 100 rules. If all the 100 rules satisfies, then only I will move the data from raw to gold. That is the example of data quality. So you can adopt this in any technology. If you are using SQL also, you can adopt this particular approach. But in when you are using lake architecture, right, this will be a common practice. So people will definitely ask you what are the data quality checkpoints you're managing. So once this is done, it is the publish is as good as the main tables in your SQL table. So in SQL, you might have managed dimension and fact table, right? So I will just put all those, I'll perform all the transformation from gold layer, and then I'll publish all of them to the published layer in the form of dimension files and then fact files. And then my downstream, right, who are looking up to my data can refer to the published layer. My downstream need not look into the raw gold. I will not provide anyone access to raw and gold. I will just receive data, do data massaging till publish, and then we'll send it to the downstream. So what is happening? I have explained you about the entire flow, right? It is just a visual representation of what I have just mentioned. So you can do batch ingestion as well as real-time ingestion. So in between, you can store it within the storage account. And you can do data management services, which I mentioned. Data quality checks is one of the data management service. MDM is nothing but master data management, where you can store some master files, or you can, I call that as dimension file. You can call the same thing as master data management for storing the dimension files. And the same terminology. Okay, workflow management is nothing but we transform from raw to gold to publish. That is the workflow management. And what is the processing tier? So I'll be using Azure Databricks in order to process all these things, right? So my processing tier is nothing but the gold tier as well as the published tier, where I have processed the data and moved to the gold or published layer. And you can do in-memory operation, multiple processing, multi-parallel processing. So because I will be using the capabilities of storage account, right, the reads and writes are already parallel. And with using Databricks or Dataflow, I can do all the in-memory based processing. So what do you mean by in-memory based processing? Hadoop used to do all the disk-based processing. So it used to incur a lot of charges on I/O as well. So it used to save the intermediate result in hard disk, and when the subsequent process needs the data, again it will do take the same data from disk and take it into the memory. So that's basically a I/O operation. But when I'm using Databricks or when I'm using Dataflow, all the intermediate result also will get saved within the memory itself. Memory is nothing but RAM. Okay. And once everything is done, distillation tier is nothing but, again, you can call that as a publish layer. Okay, once entire processing is done, then you can save them in the HDFS storage, which is nothing but our storage account. Okay, and once you have done that, your downstream can maybe using SQL, maybe using some map reduce operation, so they can pull data, or you might have some reporting requirement where you might do some insight based reporting. Okay, so that is basically the lake architecture. So the terminology which I have mentioned, right, is up to date in the market. You can hear about what is raw, gold, publish. The same thing is mentioned over here.
Let's see how do we create pipelines using Data Factory. All right, guys. So creating a pipeline basically is listed as one of the steps in performing your ETL solution, guys. Now we have a school database. Let's say we are trying to extract some data from the database. We will be extracting, and if something has to be processed, then it will be processed, right? Then it will be stored in somewhere, wherever we want.
Just a quick info, guys. If you want to learn data engineering, then Intellipaat provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job. Now let's continue with the session.
Just a quick info, guys. Test your knowledge of Azure by answering this question. Which of the following web applications can be deployed with Azure? A. ASP.NET, B. PHP, C. WCF, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let's see the steps for so basically, guys, as we are seeing in this on the screen, so we have your database, SQL database, and we are trying to extract some data from the database. So we will be extracting, and something has to be processed, then it will be processed and then stored in the data lake. So these are just some sample databases, guys. It can be anything. It can be happen between your blob storage to SQL, or SQL to blob storage, or your blob to data lake, or data lake to blob. It can be anything. Your data source can be anything. There is no specific restriction that your source should be something or your destination should be something specific. It can be anything. All right, so these are the steps for creating your pipeline using Data Factory. The first thing we will be doing is we will be just creating your link service for your SQL server database, or whatever. I have taken in my case, I have taken the example as SQL to data lake. So that's why I'm just showing the steps for creating the link services. Just steps for creating this ETL process. So we will be creating the link service for SQL server database as the source database, and then we will be creating link service for the target database, which is, in our case, it is Azure Data Lake Store. And then we will be creating the data set for the data extraction. This one we will be just doing an author and monitor tab, guys, once you will be creating the Data Factory, you will be you can just access that author and monitor tab. There you can just go to the you can just go to the author and monitor, and there you will be having all these options for creating the link services and creating the data set for your data extraction process. And then you can just create a data set for your data saving, and then we can just create a pipeline, guys, and then we can add some copy activity or any raw activity. And then, guys, at finally, so the main advantage of this Data Factory, we can schedule this pipeline just by adding trigger. So basically, guys, you can just schedule this your let's say, whatever transformation you have, you can just schedule that on some specific basis. We can transform them on weekly basis. We can transform that on monthly basis. We can transform that on day-to-day basis. You can just transform it whatever and however, in whatever way you want. You can just transform in that way. All right. So guys, now let me just show you one project where we are going to perform today. So guys, now today I'm just going to demonstrate you a project where we will be identifying the videos in the selected channel from YouTube that is getting maximum traffic. So let me explain this problem statement to you guys. So basically, guys, we are having we are having a YouTube channel. So in the YouTube channel, there are various channels, right? So let's say there is a company. So the company wants to promote its advertisements. So in order to promote its advertisements, so it wants to uh, promote its advertisement on the channel which is getting the utmost traffic. Okay, so how does the channel knows that the specific channel is getting the utmost traffic? So guys, for knowing that, that company needs to put a developer who is an Azure Data Factory specialist, where he will be automating the list of channels which is getting the more which are getting the utmost traffic at specific time. So he can just put a trigger for every 5 minutes. So for every 5 minutes, the traffic is, let's say the traffic is loading. So every 5 minutes, the list gets changed, and based on the list, this company can promote its advertisements. So this is the project we are going to do, guys. So in our project, we are just considering the two data sets, which will be where the data set one will be our first interval. Let me just show you the data sets. So these are the data sets which we are going to perform. Let me just open this data sets for you guys. So these are the two data sets, guys. So where we are having video ID, video title, views, likes, dislikes, comments, and your duration in minutes. But in real time, you will be getting in different format. So for your understanding purpose, we are just creating this project as a sample project. So this can be, these all things can be, these are all some of the basic data which we are getting from the channels. So now without wasting any time, then let's import this to our SQL database. So for creating this, let me just move to my Azure portal. Alright guys, now first of all, let me create a SQL server. So what I'm going to do here is, guys, so I'll be just creating so first of all, we'll be just creating an SQL server, and then we will be just creating some other different data store, which will be, let's create data lake, and then we will be just creating pipelines just to make some kind of things. We can just transform the data, and then we will be just building to copy the all the data. We will be just performing a basic query. We will be just performing on that, where we will be just uh, let me show you. So first of all, let me create a SQL server, guys. So guys, if you have a resource group, it's fine, or else you can just create a new resource group. First of all, let me create a resource group as workshop. So I'll just give my server name as YouTube source. So I'll just give my admin details, which will be Intellipaat, and then I'll just give it as. Alright, guys, let's create this server. The deployment is taking some time, guys. Let's wait for the process. So meanwhile, let me just open my SQL Server Management Studio. Yeah, it's already open. So guys, you can also connect to this SQL Server instance using your Azure inbuilt SQL. That also you can use, or else you can use the SQL Server Management Studio just to connect your SQL Server database or anything else. Alright, guys, the deployment is completed. Now let's just go to the resource. So basically your Azure SQL Server Microsoft, now let's go ahead and just create the database for this. So guys, basically your Azure SQL database is a managed cloud database, which is provided as a part of Microsoft Azure. So let me just create the database here. So my database name will be, let's say, SQL DB. All right. So I just don't want it to be an elastic pool. You can also create an elastic pool or a managed instance, guys. So basically there are different concepts. So basically when we talk about elastic pool, so your elastic pool is like nothing but a collection of your databases with some shared set of resources, which are managed using your SQL Server database server, guys. So basically what is the benefit of using an elastic pool in Azure is that, so using with this, you can just create a single database which can be moved in and out of an elastic pool, which gives us flexibility actually. So, but we don't want that. We can just create a normal SQL database for this purpose, because cost also varies for every database whatever we are creating. So now I'll be just creating my SQL database. So you can just see the estimated cost per month whatever is shown over here. So let's create this thing. So in Azure, sometimes the deployment takes much more time, guys. Let's get it deployed. Meanwhile, let me just open the SQL Server and connect it to my SSMS, which is on my local machine. Let's go to the SQL servers. There you can just find the SQL Server. So YouTube source is my server which I have created now. So alright, guys. Let me just check the service settings over here. So this is my server name, guys. Using this server name, we can connect it anywhere, wherever we want. So I just wanted to connect on my SSMS portal. So here I'll be just connecting to this, guys. So I'll just connect to my database engine. So here I'll just paste my server name. So guys, here I'll be just doing it with SQL Server authentication. So my the login credentials will be the one which you have created it over while creating the SQL Server. So guys, I have created my login name as Intellipaat, right? So that's what I'm just giving it over here. So guys, I need to sign in with my Azure account for getting this client IP address. So basically our client IP address is not having the access to the server. So we need to just sign in with our Azure account, and then we need to create a firewall rule for that, enabling it. So let me log into my Azure account. Yeah, so let me add my client address. So guys, for importing or exporting an Azure SQL database with basically, I mean, without allowing Azure, I mean, for without allowing Azure services to access the server, you can also create an Azure virtual machine, and then you can just connect to that, and then you can install SQL package, and then you can just create a firewall rule to allow that VM access to the database, and then you can export a database using SQL package. So but here what we are doing is that we are just importing, I mean, we have just created a server on Azure, and then we are just whatever data we are having, we are just importing to our SQL, I mean, to our Azure SQL database. So let me expand the database over here. So this is my database which I have created on my Azure SQL server. So guys, let me open SQL import and export services. uh, So with using this thing, I can import my. So guys, my source data is whatever I'm giving is Excel data, right? So let's put it in Excel data. So I'm using 2016 version. So let me put it this. So let me give the source form. I mean path over here. Alright guys, now destination is nothing but my Azure SQL server, right? So I will just put it as my OLEDB driver for SQL server, or not this one. We have to give it as. So I'll be just giving my server name over here, and then I'll be just giving my server, I mean, details of credentials. So let me log in over here. Yeah, now let's choose this. Yeah, you can choose this over here. So this is my database which I have created on my server, right? So now I'll be just uh, going forward. So what I'm doing over here is, guys, I'm just copying the data from all of the tables to the server. So let me edit the mappings. So I just want, okay, it's already, if you want to change the data type or anything, you can just change it over here, guys. So here my data is in this, so video ID, I want it in my integer type. I don't want it in my float because all of them are integer. So I'll just put it into int, and then my views are also integer type. Views cannot be in decimals, right? So I just want to be in integer format. And I mean, I just want everything to be integer instead of float. So I'll just change this thing. Also, you can alter these data types over using query also. We can do it manually also in this way. Alright, guys. Now let me just go on next. Okay. I think everything is fine. Yeah, good. This should import successfully. Let's see. Yes, guys, we are good to go. So our process is very successfully done over here. So let me just query this data. So it's taking good time. So okay, meanwhile, let's just create our data factory and also final. So I'll for my target database, I'll just create a data lake, guys. So how do we create this data lake in this Azure? So basically, for creating data lake or blob storage, you won't be having a specific option. So you need to go to storage accounts, guys. So let's go to the storage accounts. All right. So let me just add a storage account. So it's basically your Azure Data Lake. When we talk about your Azure Data Lake, it includes the capabilities which are required to make it easy for developers or your data scientists or analysts to store the data of any size or shape. So we are just creating the data lake over here. So let me just open. So I'm just choosing the pay as you go subscription. Now already we have created the resource group. I'm just creating, I'm selecting the workshop as my resource group, and then I'm just giving my name for my storage name, which is data lake. So let me just give it as target database. So okay, it's already taken. Let's give another name. So guys, basically we are using data lake version 2, so which is the latest version. So we are putting a replication mode as read, access, geo redundant storage. That's fine. Access style we are choosing it as hot. So let me just create. All right, guys, it worked. Let's create this. So guys, you all might have a query in your mind. What is the difference between the Azure Data Lake 1 and what is this Gen 1 and Gen 2? So guys, basically here for Azure Data Lake Generation 1 is a file system storage in which your data is distributed in blocks in hierarchy file system, guys. So your Azure Data Lake Generation 2 contains both file system storage for performance and security, guys, and your object storage for scalability. So Azure Data Lake Analytics is also support which is not available right now because it is expired right now. So now some of the new features are updated in this thing. Let me just go to this thing. So let me choose this workshop as my resource group. I think it's some mistake which we have done, which we have not checked. So let me create it as target AL. Yeah, fine. So version 2 is this one, and this is version 1, and this is blob storage. We can just create these three services and data lake. Yeah, we are good to go. Alright guys, now let me just check this database. Okay, we can just check it over there. Now let me just create the data factory now. So we are creating a job where we can just automate all this process to be happen. Guys, basically your data factory provides your single hybrid data integration service, guys, for all skill levels. So basically you can use the visual interface, or you can just write your own code in any language to build the pipelines as well. You can just build the pipelines manually as well, guys. You can just put your choice of processing services into your managed data pipelines, or you can insert custom code as the processing step in your any of the pipeline. So let me just create the one data factory first. So ADF project, sorry. So let me just choose my resource group. Let me choose it as workshop. Fine. Now I don't want to enable Git. So this is already choose low, so I don't want just let me just do it as some different name. So guys, if you, I mean, what is this enable Git option, guys? So basically to provide a better authoring experience. So basically Azure Data Factory allows you to configure a Git repository with either Azure repository or your GitHub. So basically Git is a version control system, guys, that allows you for easier change of tracking and collaboration. But I don't want to enable Git for this. So let me just create this thing. Alright guys, it got deployed. Let me go to the resource. So as I have already said in the presentation when I am explaining about Data Factory, so whenever you want to create any link services or pipelines, you will be just going to this author and monitor, guys. So in this tab, there is, let me show you. Yes guys, it's open. So let me just show you. So guys, we can just go to this manage tab, and then we can just create linked services, guys. So you can also directly create all the process at one go, but this is more, I mean, you are having this specific thing where you can just create link services, where you can create integration runtimes. You can just do some git configuration over here, and then you can just define triggers and whatever you want. So guys, first of all, let me just create the link services for this. So first of all, I'll be creating a linked service for my source database, which is my Azure SQL, right? My server name is, let me check it.
Hey guys, if you're looking for an end-to-end training in Azure Data Factory, Intellipaat provides an Azure Data Factory certification training for DP200 and DP201, and you can check out those details in the description box below. Now let's continue this session.
SQL DB, let me choose as this thing, and then let me just put as Intellipaat. Intel at the rate 123. Let me test the connection. Okay, let me just or else let me do it over here. So my task name is that transform the channel list. Sorry, let me just output list, YouTube channel list. So guys, here you can just run it once, or you can just run regularly on schedule. You can just trigger it every, I mean, you can do it hardly minute, or you can just do it every 1 minute, or you can just do it every hour, whatever you want. I just right now I'm not scheduling it. I'm just running it once. Let me just create this. So let me just choose my Azure Data. Or else let's do one thing. Let's do it with service principal ID. So I'll be just creating. I'll be just going to my app registrations. I just create a new app over here, which will be my Azure SQL. So I'll just go to certificates and secrets, guys. So here I'll just upload a new client secret, which will generate my principal key. So let me just do it as secret. add this thing. So this is my application. You have to copy this thing, which is your key. So let me just put it in my notepad for safe side. So click on overview. You can just go. You can get the principal ID, which will be your application ID. So this is my application ID, right? So first of all, let me copy this thing here. Service principal ID and the principal key is noted over here, right? And also we have to view the firewall access in Azure SQL, right? Let me just do that as well. So here I'll be adding a role or assignment with. So here I'll be just putting as the owner. Let me just put this. Let me check this application. I mean, let me confirm this app registration name. So whether it is SQL or anything else, let me just go through the application. This, I think this one we have created. This one. Okay, we have to create for Azure SQL. So let me just go to that SQL server. So under the access control, I'll be just giving the access for mine. So once we are done with this, let me just text this connection. Yeah, is the deployment done? Oh, let's read what is the error we are getting. YouTube source database, check the links on configuration and make the SQL Server database firewall at the integration runtime. Okay, let's check the firewall. So we are done with the principal key and then we are done with the care. Let me just let's check the database once. Okay. So this is a source database, right? So let me just check the access for this thing as well. Okay, we need to set that and that only it's set already. Why is it not working still? Okay. Successful. Let's create this. Alright, guys. Now link service for Azure SQL database is successful. Now let's create. Let's go for the step. So while loading the, I mean, source data to our target data, we just need to query. We are using including the query as well. So we are applying. I mean, some query based on this. So we want to change. I mean, we just want to the output where the views and like. I mean, here in our data set we are just considering the views and likes to be I mean where we want the traffic. So in order to just find the channels which has more traffics, so I am just querying over here where So let me just do it. Select video ID. So first of all, let me just see the schema as well. So you also can preview the data over here, guys. See, here is a preview of the data. So now let me use the query for this. So it would be something like select video ID title views, like we'll be selecting the views, video ID views, and let's say we want this only, video ID and video title only. So okay, let's put the views also. So what is our table name over here? Worksheet, right? So let me put the field as 72. Let me some random field. Alright guys, we got the data to that. Now let's choose the destination data store. Now my destination data store will be, let me just create a link service for my data lake store which I have created. So my data lake store over here is storage. Let me target DL, right? So let's choose the data lake storage Gen 2 over here and then click on continue. Now let's choose the integration service one. So I'll be choosing my Azure subscription, which is pay as you go. Now my storage account name is Target Data Lake. So I'll just choose this. So I can test the connection over here. So let me create this link service. All right. So let's click on next. So guys, for my out folder path, you can choose it. Let me just go to my storage explorer preview. So under the containers, I'll just create one container. Let me create a block container over here. Output. So guys, as I've already said, what is the difference between Gen 1 and Gen 2? So basically Gen 1 is a file system storage, which your data is distributed in blocks in hierarchical file system, and your Gen 2 is which contain both file system storage to performance and security, and your object storage for your scalability, right? So let me just choose this. Okay, so I'll be just choosing the output. Yeah, so I'll be choosing this output, and then my file name will be final. So I won't define this maximum current connection blocks. Let it you can leave it blank. Click on next. So guys, my file will be coming in text format. I just want it in text format, and my column delimiter will be comma. You can change it as well, and then row delimiter will get auto detected, which is /n, which is the ending of the line, and then I just click on next. Let me just do it. Alright guys, you can also monitor this thing. So it's still in progress, guys. It's taking some time. Let's see. So we have applied manual trigger over here. You can also, as I have already said, we can schedule it minute wise, or else you can just do it hourly wise, whatever you want. You can do it in any way, guys. Let's just open this thing. It's still in progress. Let's wait for getting it succeeded. So guys, basically, let me just show you. So when we talk about this triggers, guys, basically Data Factory supports three types of triggers, which is scheduled trigger, which is a trigger that invokes a pipeline on your wall clockwise schedule, and another thing is tumbling window trigger, which is a trigger that operates on your periodic interval while also returning in, which is in returning state, guys. So event-based trigger, when we talk about that, a trigger that is responded to an event. So these are the three types of triggers which are supported on Azure Data Factory. I think it might be completed. Let's just refresh this and let's see. So we have already created these link services. We can directly choose it over here. So my source data is Azure SQL database. I'll just click on next, and then I need to apply the query again. So also guys, let me show you one more thing. So we can just or else let me wait. Okay. So let me query this thing. First of all, before querying on this, we will just try to query over here. It's too slow. Let's choose from everything. So let's start from let me validate this first. Okay. Okay guys, this is the output which we are getting, so it should work actually. So the query is working, that's why we got the output. So we have given some 100 channels and we are getting 1 2 3 4 5 6. These are the channels which are getting the utmost traffic as per my constraint which I have set to my dataset. So just click on next. Yeah, so I'll be choosing my data lake storage as my destination data store, which we have already defined, which is the link service. So let me choose this thing output. Yeah, with this file name you can just test this connection. Alright guys, it got validated. Now let's finish this thing. Now let me just let's move ahead to storage accounts and check whether that they got updated or not. So this is my target database and I think it should be under process tab. So let me open it in storage explorer preview mode. Still getting loaded, I think. Yeah, it's successful. So now I will go ahead and create a new data factory. Just see it here. So in the search box, I will just type in data factory, click on data factory and click on create. Okay, so you can provide the resource group name if you know about it. Let me create it. East US is fine, and then I will provide a name. V2. So there are two versions if you see it. There are two versions, V1 and V2. You should always think about choosing V2, not V1. V1 was as a part of data factory evolution, right? We used to code everything in JSON. So if you want to build a connection manager or link service, you have to write a small snippet in JSON. Then if you want to create a data set, again, you have to write a small JSON snippet to formulate the data set. And similarly for pipeline triggers and so on and so forth. And it was not a good experience with the developers to use V1 because everything used to be coded. But V2 is more of a drag and drop behavior, and you can just simply pull out the respective activity like for each loop or if condition, data flow, and you can simply set the properties of those before using them. But in V1, you used to actually formulate the JSON to simulate that same thing what you use now in V2. V2 is very simple to use, and you will only use V1 then when there is some kind of migration project, right? Some of the odd projects might be still having V1, but if you are building a new data factory project, definitely you are going to invest time on V2 only. And V2 is integrated with DevOps, but while V1 is not integrated with DevOps. So lot of such criteria are there. I will show you the flavor of V1 within V2 itself. Okay. Then click on next. So what we will do, this is about the GitHub integration. We are going to do the GitHub integration later. So what I will do is I will say configure Git later. I will check this box. So later what I will do is I'll set up the repository type as GitHub. I'll provide the GitHub name, repository name, what is my branch and all those things. So for now I will select configure Git later. And I can choose public endpoint over here, not private endpoint, because I want to run this data factory instance on a public network, right, within Azure network. So I will use that. So if there is a particular virtual machine from there you want to run the data factory, then it makes sense to use private endpoint. So it will not make use of the internet. But if you want to use public endpoint, you can make use of internet to run this data factory. Otherwise, you have to get into the VM, which is installed within a virtual network, and then from there you get connected to internet and execute a data factory. So without going through the route of internet, you can execute data factory by using private endpoint. But our focus is to execute this with public endpoint. So if you want to encrypt your data factory, then you can do so using a customer managed key. Okay, so I don't want to do that. If you have a customer managed key, then you can put the key vault URL
and the data factory would be encrypted. But you can keep it unchecked, and Microsoft is anyways encrypting. You see here, by default, data is encrypted with Microsoft managed key. It's just that if customer wants to encrypt with their own key, then you need to provide one. Otherwise, you can ignore this. I have explained the significance of tags. I will explain once more. So you are already classifying your resource with respect to directory, active directory, then subscription, resource group, and then the resource itself. But if you want to also classify your resource in a different dimension, you can create new tags. So let's say that this is mostly used by my development team, right? So I can say development as the environment. This is kind of a key value pair. And let's say similarly, I'm doing for 5 more resources, right? Later when the billing comes up, I can understand that, okay, for the set of resources with the tag environment equal to development, this is the pricing. So this is just an extra way of representing your set of resources. Then go to review plus create. If everything goes good, right, the validation would be successful like this, and then click on create. Once you create, you will see the notification icon that the deployment has started. So in just 30 seconds or 1 minute of time, this should be created. And you can see here that the deployment is in progress. Okay, and you can see that the deployment is succeeded. I will go to the resource, and you can see some more options here, right? So the main portion will be author and monitor. I will come here. Let's go to iterate through the list of items, right? So again, overview will comprise of what you have already created, like the name of the data factory. You can see over here the resource group name, subscription name, subscription ID, and so on and so forth. So if I want to make some changes to this data factory, right, I can see all those things here within the activity log. So as we have just created, we don't have any events to display, but as we keep using this data factory, we may see some more other log. Access control, if you want to provide access to someone or service principal or a group, you can do so over here, coming to role assignment. Let's say I have a user named as Venki, right? I want to provide Venki the reader permission on this data factory. So what I will do, I will click on add role assignment, and then let's say I'm providing reader permission to Venki. There is a user called as Venki. Click on Venki and click on save, and you can see that the role is getting added for Venki into this data factory. Yeah, and the role is added. So now if Venki logs in into Azure portal, right, he should be able to see this data factory. So if you have missed out on creating any tags, you can still come here and create additional tags. So let's say I'll say that this development resource is being used by my payments team. So what I will do is team name, and then I will say payment and apply. So once you apply, this will be a part of your tags. Yeah, this is added now. Now, diagnose and solve problems. Let's say you are encountering some regular problem some problem you're facing, right, within data factory. So the first place you should come into and check is diagnose and solve problem. So this is having a lot of community-based problem statement. User will be posting a lot of problems, and then the community will upload those problems along with the solution. So if your problem matches with one of the problem statement listed here, you will definitely get a solution. But nevertheless, if your solutioning is not there, right, you can always raise a new support request. So when you're really stuck with something, right, or you feel that there is a bug in the system, you can raise a support ticket, and one of the support member will contact you and take it to the closure. So let's say there is no answer from the support team, they will point it to the data factory product team, and they will respond to you in some timelines. But the first place to come is to come to data diagnose and solve problems. I will go to properties. So okay, why I came to properties, because I want to show you this property. So there might be use cases where you might require to run this data factory, some data factory pipelines using some programming language, right? Let's say you are using a small piece of C# code, and from C# code, let's say you built a web application, and from that web portal you want to execute a particular pipeline. So when user is clicking on a button, you want to execute a pipeline. So at that point of time, some properties are required, right? So this is one such property. To identify which resource you are pointing to, this fully qualified resource ID, it is nothing but the resource ID. If you see subscription ID, resource group name, and I'm using Data Factory service. Which Data Factory I'm using? I'm using demo bits ADF 127. It is basically giving you the entire hierarchy. So some programming languages might ask you to give a resource ID, and you can extract such resource ID using properties. So this is applicable to any resource. Okay, if I go to Azure SQL, I will see another resource ID. If I go to Cosmos DB, I will see another resource ID. So you have to just go to the properties to extract such a property. Logs I explained, but I'll repeat again. So if there are two types of log, read only and delete log. If I want to make this data factory just read only, I will click on read only, and this data factory becomes read only. So you will not be in a position to modify any properties of this data factory account. And delete is that you will not be able to delete the data factory. This is the delete log. Okay, so you have to simply write do not delete and click on OK, and this is set. I don't have to save, it is automatically saved. Okay, I'll now not be able to delete this data factory. Okay, so let me try to delete them. Okay, I will give this name. Yes, you see, deletion failed. Okay, I will not be able to delete because there is a log. So this is to avoid accidental deletes. Okay, it's always good to use these logs rather than not using it maybe later. So there is a use case where if you perform a full deployment, right, there are some resources which does a full deployment, which means delete dropping the resource before recreating. If you don't want to perform those full deployments, right, you can always keep a do not delete log or delete log basically. So that won't delete your data factory resource.
Just a quick info, guys. If you want to learn data engineering, then Intellipaat provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job. Now let's continue with the session.
Just a quick info, guys. Test your knowledge of Azure by answering this question. Which of the following web applications can be deployed with Azure? A. ASP.NET, B. PHP, C. WCF, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
With that, I mentioned that if there might be cases where you might need to run this data factory from .NET application, so you can make use of Azure SDK for .NET. If you want to run through PowerShell, you can read this documentation. Azure SDK for Python, REST API. If I want to hit on a particular URL and my data factory Python should run, there are a lot of such options. You can just go through the documentation. Okay. And then alerts, metric, diagnostic setting, and logs I will cover in one topic. So I'll give you a use case. Okay, one of the metric is called as failed pipeline run. So this failed pipeline run along with all other metrics will go into logs. Okay, on day-to-day basis. Now using the concept of alerts and diagnostic setting, I will be able to understand that the pipeline has failed, and I can trigger alert to the respective team or respective person. So I will make use of that use case later on. Okay. I will go to the overview section and then again click on author and monitor. So once you click on author and monitor, this will open up the data factory workspace. Okay. So there are 4 tabs within the data factory. So you have data factory overview, author, monitor, and manage. Okay. So we have overview, author, monitor, and then manage. So I will give you a problem statement before solving any of these things. Okay. So we will understand all these things by solving a problem instead of just going through them manually, right? I'll solve a problem statement. So this is the storage account that I have in my system. And if you see here under the blob container, I have one container called as source and another container called as target. Okay, target doesn't have anything at this point of time. Target doesn't have anything. And if I click on source, I have Netflix underscore titles file. So what I will do, I will simply solve a simple problem statement to transfer this file Netflix titles into target location. Okay, I will solve this very simple exercise. So can anyone tell me what is the first step that I need to do? Anyone? I explained the theoretical concept, so you should be able to answer this.
First we need to connect the source.
Yes, connect to the source using link service. Yes, agreed. Okay, so what I will do, I will click on create link service here, or I can click on new. So once you click on new, just observe the list of sources that is supported by Microsoft. Right? There are a lot of resources which Microsoft supports. And then if later on tomorrow Microsoft adds some more resources, right? You will just see it over here. They may keep on adding list of sources and destinations over here. Okay, coming to the problem statement, we want to connect to our storage account. So I will simply type storage, and then you can see here Azure Blob Storage. So you also see Gen 1 and Gen 2. Because it's a normal storage account, I'm going to use Azure Blob Storage. And naming is very important. So I follow a particular nomenclature. If you like that nomenclature, you can go ahead and use that. Okay. So what I will say ls underscore. Ls is for link services underscore. I will say that it is a storage account. Now which storage account I am connecting to, I will say demo bits storage account. And now if you see, I was talking about integration runtime also, right? So by default, we are getting one integration runtime, which is auto resolve integration runtime. This is nothing but the Azure integration runtime. If you want to get connected to any of your PaaS instance, right, platform as a service instance, then you need to use Azure integration runtime. So auto resolve integration runtime is nothing but an Azure integration runtime. Click on this, and then scroll down. You have several authentication method like account key. I was explaining about the access key, SaaS URL, and all that. You can go ahead and use account key, and from subscription you will be able to list out the subscription. You can list out the account. So we want to point to demo bits account. Right? I selected demo bits account, and it automatically loaded the key. And scroll down and do a test connection before actually creating this link service. Okay, click on create, and your link service is created. Is in the process of getting created and is created now. Okay, so what should be my second thing? And again, I will have a proper naming convention, ds storage. I will say this as source. Okay, and then I will also say Netflix. Then I will select the link service. So my link service that is created is ls storage demo bits. Now you understand that why I'm so much focused on the naming part, because when I'm selecting it from the drop down, by the look of it itself, I should be able to understand it. Okay, which link service I'm pointing to. So it is very easy to comprehend. And the next thing is, if I'm creating a data set which is of storage account type, then all the related link services will only come up. All the storage based link services will only come up. So you will not be confused that way as well. And as my link service is already pointing to storage account, I will be able to browse my file as well. Click on browse. So again, repeating, there is a small folder option here, right? Folder icon. I'll click on this folder option to browse to my file. Okay, and you can see that the container is source, and there is no intermediate directory. That's why you don't have to pass anything here. And the file name is netflix.csv. And I know that the first row has a header. I will select this option. If you know that the first row doesn't have a header, you need to uncheck this. That will be treated as a data record. Click on OK. What is my next step? Just pointing to the container option. I don't have to provide the file name. I can provide, but I don't want to provide. I will just specify the target folder name, and whatever is coming from the source, the same name will be written in the target. So what I will do, I will click on new data set. Okay, I will say storage account again. Click continue, delimited text, continue, and I will name it as ds underscore storage underscore target. Why I'm specifying target is because my container name is target. Don't think that source I'm pointing from source to target. Don't think that way. I'm actually referring to my container over here. I mentioned that you don't have to classify data set as source and target. So keep that in mind. And then I will say target underscore folder. I will not give a file here. And I know that I'm using the same link service. I will select that. First row has a header. In browse, I will select simply target, click on OK. So target is automatically put here, and there is no directory, no file. Click on OK. Okay, my data set is also created. Now, before moving to the next step, what I will do, I will click on publish all, because now you're developing in this data factory, which is where are you developing? You're using a web browser in order to develop this entire resource. So by mistake, if I'm refreshing this browser, the changes will be lost. You will not see these datasets anymore. So on a time-to-time basis, you need to click on publish all. Publish all. What am I publishing? I'm publishing both the datasets that I created. So once you have published it, after that, if you refresh your browser, it will stay permanently. So when you're publishing, it means you're just publishing these relevant objects, like dataset, pipeline, link services to the data factory. Now it is successfully published. Now if I refresh my browser, you will see that the things will be intact. Okay, my things are intact, right? You can see those two datasets. Now observe, if I'm creating one more dataset, let's say I'm selecting the same thing, or let me do one thing. I will simply clone the existing dataset by clicking clone. It is faster option. Now I'll not publish, I'll refresh the browser. It still says me this page is asking you to confirm that you want to leave. Information you have entered may not be saved. Leave page. So basically I'm doing a forceful refresh. So now you see that other cloned data set is not available to you anymore, which means that you need to click on publish. I just wanted to explain the importance of publish. You are developing everything in a browser. It makes sense to publish in meanwhile. I will create a pipeline and move data. Yes, that is correct. So let's create a pipeline, new pipeline, and then I will say PL. Okay, PL for pipeline, DS for dataset, LS for link services. Copy file. I'll just name it simple, copy file, and I will also say storage. Within storage account, I'm doing these things. I'll say PL storage copy file. Okay, then there is so you see there are a lot of activities within it. There are lot of activities. There is copy data, data flow, and you can browse through all these activities. But because it is very new, right, it is difficult to browse to the exact location. So what you can make use of is the text box. Because I want to perform a simple copy from source to target, I can simply type copy, okay, and drag it here in middle. Okay, let's name this copy data. How will you rename this? By putting the name over here. And then I will talk about few more options as well. Timeout, retry interval. Just remind me once more. I will talk about once I execute this pipeline. I will talk about these three things in one go. Let me select source. So obviously source is data set, right? So I will select DS storage source Netflix. So the naming importance is understood, right? So because the naming is very clear, I'm able to understand and click on the respective data set. Sync, I will go to sync and then select the appropriate sync also, DS storage target folder. I don't have to do mapping. Mapping makes sense when you want to map from one column to another column. But here I'm simply copying a file. We'll talk about mapping after some time. We are now focused about just transferring one file from one location to another location. Okay. Now I will just publish it before executing the pipeline. I will explain you how will you execute the pipeline. So when you are publishing, right, you can go to this notification icon to check whether it is getting published or not, and it has successfully published. Once it is done, so for development purpose, there is an option called as debug. You see there is an option called as debug. And before even I execute, I want to show you my storage account. In target, I don't have anything. But in source, I have Netflix underscore title. So I want to move this particular file into the target location. So I will simply run debug. Okay, now you see it. As and when I click on debug, you see an output option over here. And this copy data activity is currently queued. The next, see, first status is queued. It means the run has not started this. It is trying to acquire compute from the integration runtime. Once it extracts the resource state, then it goes to in progress state. After in progress, it can go to either succeeded or failed. If I have done some mistake, obviously it will go to failed status. But because everything was correct, I got a succeeded message. Okay, because it is successful, you can just click on the details to see what has happened. Files read, yeah, one file was read. Files written, one file is written. And how much data was written? 3.33 KB. And it also showcases you what is the throughput. It's a very small file, hence you see that it took some time, 1.1 KB per second. Okay, now I will go to my storage account. So earlier, this was the earlier status, right? In target, there was nothing. I will refresh this over here, and you will see Netflix underscore title file here. Makes sense, right? The timing you can see 8:53 Indian time, and currently it is 8:53 only. Okay, and to just quickly browse and understand it, what is there in the file, what you have to do, you cannot browse it here. So you can scroll down, go to containers, go to target container. Here the same file, right? Click on this file and go to edit. And you can see the mini version of the same file. The best option is to download and see the file, because you will have a lot of editors in hand, right? You can see this CSV in your Excel file, and there'll be a lot of options. Okay, so I just did a simple copy of file from source container to target container. So here is link service. So this is very much clear, right? If we want to get connected to a source system, then our destination system, we can create this link services. Integration runtime. So by default, I did not create this, right? So by default, we are getting an Azure integration runtime. You see this? The name of this is auto resolved integration runtime. What is the type of integration runtime? It is an Azure integration runtime. So if you want to get connected to the PaaS system, like storage account, like SQL system, then you can make use of this auto resolved integration runtime. But I mentioned that if you want to get connected to a different integration runtime, where you want to connect to on-premise ecosystem, then you can make use of self-hosted integration. How will you make use of self-hosted? Click on this, continue. Click on self-hosted again, continue. And let's say I'm saying self-hosted. I'll just tell you the steps. You can take it offline. Okay. Click on create. Okay, it is created successfully, not finished yet. So we are trying to connect to an on-premise ecosystem. So what you need to do, you have to download. So let's go with option 2. We don't want to do automatic process. We'll do very much manual. So let's say that you have a SQL Server system which is present in your on-premise in a particular virtual machine. So download and install integration runtime in that particular virtual machine. Once you download and install and you open that application, it will ask you to provide a key. You provide either key 1 or key 2. So let's say I'm providing key 1 in that application. After 2 minutes of time, okay, after 2 minutes of time, this will be running. So you have to download, install, plus provide one of the key, and then wait for 2-3 minutes of time. This status would turn to running, which means that my data factory would be able to talk to that virtual machine. So that virtual machine, I can read file system, I can read the SQL Server. If there is Oracle in that same virtual machine, I will be able to read. That's the purpose of self-hosted integration. Then I'll again talk about Azure integration runtime. So we already talked about auto resolve, right? So that is nothing but Azure integration runtime only. But just see the options. If I click on Azure again, there are some options, right? Like if I want to select a particular location where I want to run all these things, right? So I can select the location as well. So if my customer base is US, I keep everything in US, and I can also keep US location in this East US location in within the integration runtime. It means that when my data is getting moved, I am 100% sure that that will be moved within East US itself. And I did not talk about data flow. When I'm talking about data flow, I'll talk about these 3 things. Okay, so okay, I'll give you the exercise. Before going to the exercise, I will tell you how to subscribe to a subscription. Okay, I will explain the sign up process now. So what you will do, because you might be you may not have still created a subscription yet. So what you can do, so just provide portal.azure.com. I will just ping this in the chat window. I'm explaining the sign up process. Okay, go to portal.azure.com, then do a sign up. You can provide your personal email accounts like Yahoo, Outlook, Live.com, any personal email account, okay, Gmail account, any account. And once you are in the process of sign up, you will be asked to choose a subscription. So you will land up to a page which I will be showing right now. So during the process of sign up, you will come to a particular page, which will be this. Okay, so you will see 3 types of subscription types, right? Free trial subscription, pay as you go, and Azure for students. Don't deal with Azure for students unless you are a university student at this point of time that university has tie up with Microsoft. Until that point, you will not be able to use this particular thing. This gives you some free products for 12 months of time, but this is for university students. So what option is left to us? We have free trial and pay as you go subscription. So obviously, because you are in the learning phase, go with free trial subscription. It will give you $200 of free credits for the 30 days of period. So if you're in India, it is something around 13,000 INR. Okay, 13,000 INR. In US, it is $200. So you will get $200 of free credits over 30 days of time. So what does that mean? So if I'm exhausting $200 in 10 days of time, then the subscription status would turn disabled. Or let's say that I'm not exhausting the money, but 30 days has gone, then also the subscription would turn disabled. So you will select this particular option. As and when you select this option, you will be asked to you put the credit card details. You can safely put your credit card details. Okay, and once you do that, based on your location, if you're in India, 1 rupee will be deducted. If you're in US, $1 will be deducted, and it will be reverted back as well. It is just to check if your card is legitimate. If your card is legitimate, it will just successfully validate that your card is valid and will allow you to complete the sign up process. So the money will be back. Okay, you can just read out the terms and conditions over there, but that is the process. You don't have to worry from free trial perspective. Okay, but at some point of time, you have to make a decision, right? Because you're investing time on this Azure subscription or maybe Azure product, right? So once the free trial is over, what next? So there are two options, right? Either you can again continue with free trial. So you cannot use the same account. Okay, you have to create another account, another personal account, another credit card. Only then you will be able to again use free trial account. That is another option. Second option, the best option is to go with pay as you go. It means that your credit card is already linked, right? So you can go with pay as you go, and the billing will actually start. But it's not an easy decision, right, to go to pay as you go, because you are already skeptical. Because credit card is linked, you'll be little skeptical to move to pay as you go, because every billing, some or the other amount might appear. So whenever I talk about any of the resource, just have a practice to understand the costing model. Okay, I will, after this, once you do this sign up process, I will also explain you where exactly you can understand the costing. Once you're comfortable with costing, you can actually take a decision and move to pay as you go. So while you are in free trial, right, try understanding the costing perspective. Once you do that, you can actually easily move to pay as you go subscription. So that is the entire process. And second scenario you might think in mind: will my subscription automatically move to pay as you go from free trial to pay as you go? No, it will not happen unless you provide the instruction. It is not going to automatically move from free trial to pay as you go. So once it is expired, you don't have to worry from the credit card perspective. If you're so much skeptical, then you can remove your credit card from after using this free trial subscription. So that is the sign up process. So in this problem statement, I was trying to transfer file from source to destination. Right? This Netflix titles file from source to destination. What if I want to upload a different file using the same pipeline that I have created? Right? So you have to understand few more options there. Now let's do one thing. I will upload another file. So just give me 1 second. I will identify the file and will directly upload those files. Okay, I've uploaded a new file as well, customer.txt. Then I'll go back to the data factory. This is static copying, right? Now I will make it a little more dynamic. I'll say dynamically copy. Okay, so what I will do, I will create a new parameter called as file name. So whenever you create a parameter and you click on debug, right, the first thing it will ask is to pass a file name. Without passing this, you will not be able to execute a pipeline. So that's the reason, because we don't know, right? While executing this pipeline, I'm not sure what is my file name. Okay, again repeating the problem statement. Earlier, I copied a file from source to target. Okay, in very static manner, right? I chose a particular file called as Netflix titles and I moved the same thing to target location. But this time I'm creating a dynamic copy, which means during the runtime, I'm going to understand that this is the file, and then I will transfer that file from source to destination. So I'm creating this parameter so that during runtime, I'll pass a file name and that file name should be moved from source to target. That is my intention. Now what I did was I made a clone of the existing pipeline and I renamed this pipeline to dynamic copy. That is what I did. Post that, I created a parameter called as file name. Okay, post that, what should I do? So I have a copy data activity and I have source and sink, right? And this source is dedicated totally to Netflix file. So I'll not make use of this data set at all. So I will go to this data set. Okay, this is the data set which is pertaining to Netflix file, right? I will create a clone of this data set, and I will name this as dynamic file. Okay, so just for my interpretation, I'm naming it as dynamic file, and then I will remove this, and then there is something called as parameters. So I'll create a new dataset parameter, and I will name it as dataset parameter. Sorry, file name, dataset file name. Go back to connection, and then in the file name, right, instead of passing Netflix underscore title, I'll pass this parameter name that I have created. So to add this, click on add dynamic content, and then search for the same name, dataset file name. Click on this, and you saw, right, this is automatically formulated. So what is going to happen when I'm going to run my pipeline PL storage dynamic copy? We already have a pipeline parameter, and when I'm running, I will obviously pass the pipeline parameter. Let's say customer.txt. When I'm passing customer.txt in this particular pipeline, right, in this particular pipeline, right, that has to cascade into this data set. Okay, where will it cascade to? That pipeline parameter will go to dataset parameter, and that dataset parameter is being referred to as a file name. Okay, I'll go back here, copy data activity, and under source, I'm going to change this to dynamic file. And because this dynamic file dataset has its own dataset parameter, I will be prompted to provide a value here. You see, right? Dataset file name. Now, the link you are able to understand it. So I have created a dataset parameter. Now, because I'm using that same dataset which has its own parameter, I'm being asked to provide the dataset file name here. So what I would pass, I will pass the pipeline parameter into the dataset file name parameter. Click on add dynamic content, and then type in file name. Click on file name, and you can see this expression is automatically again evaluated. It is the pipeline based parameter. This is file name. Click on finish. So during the runtime, if I'm passing a file name called as customer.txt, so that same name, file name, will go into dataset file name. And then if I refer to this dataset file name, right, where is it? It is within the file property, right? It is the file, add dynamic content, dataset file. Once I do that, so the sync is still the same thing. It is just pointing to the target folder, right? It still holds good. I will click on publisher to save all the changes before running this pipeline. Okay, publishing is succeeded. I will click on debug now. And now you see, right, because the pipeline has its own parameter, is asking me to provide the file name value. So now I will provide the name customer.txt. I will copy this and paste it over here. And click on OK. And you will see the output. Copy is in queued status. It is in progress, and it is succeeded. I will go back to the storage account. So this is there in my source container, right? So I will go to my target, and I will be able to see that customer file is present now. The timing you can see over here. Okay, so I have made it more dynamic in nature, right? Now let's say I want to pass another file. So I will pass Netflix underscore title. Okay, the time is 8:59 in the target, it will change. And click on OK. Refresh queue to in progress, and then it will go to succeeded. Yeah, it is succeeded. Now if I go back to target and refresh this, the time would change. Yeah, you see, right? Netflix file, the time is changed to 9:33. Now I will again repeat the same thing. I hope it is clear, but I will repeat the same thing what I did. My goal is to dynamically decide during the runtime what is the file name. So to do that, I have to create a pipeline parameter called as file name. I created file name parameter. Once I did that, I have to pass this file name into my dataset, right? How will I pass my pipeline parameter to the dataset parameter? So when I created this dataset, I first created a parameter, dataset parameter called as dataset file name. And where did I place this dataset file name? In the file property. So this is container, this is intermediate directory, and the file name. So what am I expecting? During runtime, my pipeline will pass a value to dataset file name property, which is used in my file name value. So that's how I'm using this, right? Under copy data activity, if I go to source, and I've made use of the same parameterized data set, it is prompting me to provide dataset file name, which is nothing but the file name of the parameter. And sync is pointing to the target folder. So that's why you see that this has succeeded. Now it is very much dynamic compared to the first pipeline, where I'm able to pass any kind of file which I want to write. I will unmute you guys to understand if there is any questions on this aspect, or you can post your questions in the chat window. So by default, it will replace the existing file at destination. Yes, Vinith, it is going to. Okay. So what I will do, I'll just make a copy of this pipeline. Okay, cloning this pipeline, and then we'll rename this pipeline to copy. Yeah, copy. If not exit. Okay. So this copy activity will come in a while. So what I have to do, I'll just repeat the entire flow once more. I will first check if the file is present in the target or not. If the file is not present in the target, I would make a conditioning and then would copy the file. If the file is not present, then I'm not going to copy the file. That is what my logic is. So first I need to ensure that the file is present in target or not, right? So what I have to do, I have to create a data set for the target file. So at this point of time, we have a data set which is pointing to the target folder, but I have to create a data set which is pointing to the target file. So I will make a clone of this. Okay, I will name it as target file. Okay, and then I will create a dataset parameter like I created earlier. Go to connection and use the same parameter. Click on finish. So this is done. Now I will go to the new pipeline, which is this, and then there is a activity called as get metadata. So see, as and when I'm solving some of the use cases, right, we will come to know more and more number of activities. So I'm extracting get metadata activity. I will say that check file existence. Okay, and then I would use a data set which I just created, which is the target file. And obviously this target file dataset has its own parameter, right? So I will put the file name parameter from the parameter file. So what I would do, I will just type in file name, and then the pipeline parameter would cascade into this data. And scroll down, there is one more important property called as field list. So click on new, scroll down once more, click on this drop down and see what are the items. So I will be using exist property because I want to check if the file is present or not, right? That's why I'm making use of exist. There are some use cases where I can iterate a list of items using child items. Over here, child items. But for this use case, I'm making use of exist property just to cross check if the file is present or not present. So, and I'll explain you one more property about this data factory. If I want to run just this particular activity, right, get metadata, and I don't want to run copy data activity during the process of debugging, I will just check this over here. You know, right, in SSIS you used to place a debug point. I will call the same thing debug until this point. Debug, and then I will pass a file name. Let's say I'm passing a random file name which is not present, obviously, and then click on OK. Refresh the output. Keep refreshing. Go to this output section. See, I'll explain you how to read the output of one activity. Right? So there is an output, there is an input. So let's go and check what is the output. And you see the first property is exist false. So it means the file name that I provided doesn't exist in the target location, which is exist false. Now close this. I will debug this once more, and I will pass customer.txt, which is present in our target. Right? Click on OK, and then let's read out the result once more. Okay, and then I will open the output to see that exist value is true because the file is present in the system. But what should I do? Once I check this get metadata, I should do some conditioning, right, before copying. I cannot see why right now the flow is like, even if the values exist true or false, I'm making a copy. Right? I cannot do that. I have to do a condition before copying the data. So I will disconnect this and then we'll place another activity called as if condition. Okay, I will connect the get metadata with if condition. Okay, and then I'll just cut this and paste it within the true activity. So there is if condition, there is true and false, right? I will copy that activity here. Copy file activity will be here. But now I have to make use of this output, right? The get metadata output. I need to make use of this property in order to understand if I want to execute the true activity or false activity. So click on this if condition. I will name this if condition as if file exists. Okay. Then go to activity. There is a expression box. So click on this expression, add dynamic content. Now I'm going to use the output of one activity in here. So scroll down or just type in check. Okay, so my activity name is check file existence. Click on this. So we formulated till output. Okay, click on finish. I'll just formulate this once more. So check the output. So what is it? Under output, you have a property called as exist whose value is true at this point of time. I'll copy this and go back to this expression. And you see under output, I just need to put dot exist. Got it, right? So I'm using the output of check file existence activity. So this is automatically formulated. I'm just making use of the output, one of the output property, which is exist. And because it is giving me a Boolean value, right, of true or false, I can make use of the same. I don't have to do equals and what is the value? I don't have to do, because anyhow this expression is giving me a value of true or false. So click on finish. Okay. Now can anyone tell me what is the incorrect thing that I made? Can anyone point me where exactly I did correct thing? So see again, I am trying to read the output of get metadata. The value would be exist true or exist false. Then in the if condition, I'm putting this expression. Okay, this expression activity check file existence dot output of exist. And then if the value is true, I'm going to copy the file here. So what is the mistake that I have done here? Now, why did I place a not? Because when the file is present, it will say that it is true. And not of true is false, right? So I am not trying to copy anymore. But if the file is not present, the exist value would be true. At that point of time, I want to execute, sorry, the exist value would be false, and not of false is true is when I'm executing this copy data activity. Okay, now I'll just publish it before executing the pipeline. Okay, so while it is in publishing mode, right, I can still go ahead and click on debug. I will say customer.txt. Click on OK. So customer file is present in the target location. So ideally, if condition will give a value of false and it should not execute, right? So let's see what happens. It's done. So you say that the check file existence value is giving me a value of true over here, true. And because it is true, not of true is false, right? So it evaluated the if condition but did not copy the file because it evaluated to false. Now see here, I will try to execute another thing. Okay, I will delete this customer.txt and then run the same thing again. I'm deleting this file and we'll go back and run the same thing with the same parameter customer.txt. You see, right? Now the third activity came in, which is copy file. Because this evaluated to false, not of false is true, and hence I'm executing the copy file activity. And it is successful. Now if I go to the target location, refresh this, I'm able to see customer.txt. Okay, this is one another use case within storage account. You can play with this expression, and based on what is the outcome, you can decide how you want to orchestrate your data movement. So this is what I wanted to cover on storage account. One more important thing which I didn't cover yet. I told that I will cover that. So I will just explain you one of the important property. Okay. So if I go to the general tab of any activity, I can go any pipeline and choose that copy data activity, any activity. There are three properties, right? Timeout, retry, and retry interval. So I'll tell you what it is. Let's say that I know, right, when something is getting copied, I will roughly understand that okay, it should not take more than 5 minutes of time. But the default timeout property is set to 7 days of time. If let's say on an odd day, if it gets stuck for no reason, right? Then if it gets stuck for 7 days of time, which is not good, right? So what I would do, if I know that it is going to take maximum of 5 minutes of time, and just to be very much pessimistic in nature, I will set it 10 minutes. So I know that it will take maximum of 5 minutes of time. So I will set it to 10 minutes. So the format is the date, days, dot, hours, dot, minutes, dot, seconds. So I'm setting it to 10 minutes at this point of. If you want to set it to some days, you can do like this, 6 days, 0 days, 0 time. At the same time, there is some property called as retry. Let's say currently the retry is 0, I'm making it to 1. What does it mean? If copy data activity fails for some reason, it is going to retry once more. That is the meaning of retry. But it will retry after waiting for 30 seconds of that is retry interval. Okay, this is the timeout, retry, and retry interval. Now what I will do, I will try to solve a simple problem statement of copying data from source database to target database. Okay, now we'll go one level up in data factory, and later on we'll solve an incremental problem statement of what is the infrastructure that I have. Now I will go to my SQL Server instance. Let me switch over. So I will select SQL Server. This is my SQL Server account, and if you go to the databases, right, I have two databases. One is source DB and another is target DB. Okay, so let's assume that source DB is maintained by the customer, and I'm retrieving the data from customer and loading the data into my target database. That is what we are doing here. Okay, for the simulation case, what I have done, I have kept source DB and target DB separately within the same SQL Server box. Okay, so what I'll show you a few things in source DB and target DB before approaching to the problem statement. So there are some data which is getting published on a day-to-day basis, and it is published by customer. I have to retrieve in an incremental manner into my target database. Target database, I have full control, but source database, I can only read the information. Okay, having said that, we'll not be able to create anything in the source database. Obviously, it is maintained by customer. How can we create it? Now, if I click on the source DB, right, I will open one more instance as well. I will open target DB as well. Okay, now go to query editor and type in the password. Okay, my IP needs to be added, so I will go and add my IP over to start set server firewall. If you are not able to get connected to your system, right, it means that you have to add your IP. So one rule is you can click on plus client IP and your IP will be added like this. You can see here, right, your IP is added. At the same time, you have to say allow Azure services and resources to access the server. So by default, it might be no. You have to set it to yes. If you say yes, then your external system like Data Factory, Cosmos DB, or Databricks streaming analytics would be able to talk to the SQL system. If it is no, they will not. Those systems would not be able to talk or interact. Click on save. So why I added my IP is that because my machine is my router's IP needs to be added, and SQL will understand that okay, it is coming from a trusted source. Okay, I'll go back to source DB and then go to query editor. I will type in my password now. I will not get any error anymore. Click on OK, and I am connected to my system. And similarly, I will do the same thing for target DB as well. I want to showcase the entire scenario, right? So go to query editor and type in your password, and I'm connected. Okay, now what is customer providing? So if I see here, there is a table called as orders. If I execute this, I'm able to see certain number of orders over here. I have total of 16 orders till date. So far customer has published till 2020-01 and 11. Okay, at the same time, what I would do, I will try to simulate some scenario. Okay, so you will see here, there is no record in this target system yet. So if you see here, there is no record in orders table, right? We see 0 number of records over here. Okay, so what are we going to solve? We are going to push data from source database, which is maintained by my customer, and I will load it into the target database. So it is very easy, right? If I use a copy data activity, put source as orders and destination as order, I'm going to put the entire data from source to destination. But our goal is not that, right? We want to do it in an incremental manner. So for that, we have created another table called as watermark table. So this table will help me to maintain the timestamps. So whenever I'm loading the data for the first time, right? So I'm choosing the first date in the system, which is 1900-0101. Because we are dealing with orders table, right? Whenever you are going to do this exercise for the first time, place the entry as orders and place the first date. Because all the orders would be definitely greater than this date, right? So if you see my source database, there is a timestamp entry insert date time. You are 100% sure, right? Whatever date it is in this set of orders would be definitely greater than 1900. So this is my initial configuration setup. What I would do is I will put orders as the table name and I would start from 1900. Means I'm copying fully for the first. And then let's say I'm loading this data from source to destination. What is the maximum timestamp here? It is 11/1/2020. So let's say I have loaded the data from source to destination successfully. The next thing that I need to do is to update this value, which is the maximum timestamp, in this watermark table over here. So that now, let's say it is updated to 2020-01-11, right? Now, if I run the same pipeline once more, it has to start from not 1900, it has to start from 2020-01-11. So now you understand it, you are now getting the incremental data set. You're not getting the full data set. That is the purpose of maintaining those checkpoints, right, in watermark table. So I will explain it with a diagram as well. So let's go to Data Factory. Let's say I'm creating a pipeline, which I will call this as EL copy orders incrementally. Okay, I've created this pipeline, new pipeline. Now I'm going to draw the diagram before when explaining this. So what I'm going to do. So this is what I'm going to do. Okay, this is a lookup activity. I have not talked about lookup activity. I will talk about that. This is a copy data activity. This is a store processor. So what am I, before copying the data, I need two information. Okay, watermark value, yes. Anything else which I need to bring? Yes, watermark table, watermark value will give me the start date. Yes, end time as well. End time is the maximum timestamp which is present in the source database. So what I'm going to do, I'm referring old watermark, I'm going to refer to the old watermark, I'm going to refer to the new watermark. So old watermark is nothing but the watermark timestamp. So if something is there in the watermark table, it means that the data has loaded till that point of time. Now when I'm running the pipeline again, I have to start from that point. And that's why I'm calling it as old watermark. And how am I going to extract the new watermark? This new is nothing but the maximum value. Whenever I'm performing the load rate, I will calculate the maximum date value within the orders table. The maximum at this point of time is 11/1/2020, right?
Just a quick info, guys. If you want to learn data engineering, then Intellipaat provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job. Now let's continue with the session.
Just a quick info, guys. Test your knowledge of Azure by answering this question. Which of the following web applications can be deployed with Azure? A. ASP.NET, B. PHP, C. WCF, D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So the same thing, the max of insert date time from the source orders is nothing but the new watermark. So now I got the old watermark, I got the new watermark. Copy data activity has source and think, right? Think will definitely point just to the table. Source, I have to evaluate the query before loading it. So I will do select star from orders where insert date time greater than old watermark and insert date time less than equal to new watermark. Once this copy data activity is successful, I'm going to execute a stored procedure which will update the watermark value with the new entry, what we got in the lookup. Okay. So the first two things I need to do is to extract lookup activity, right? We'll extract lookup. Again, one more lookup. One will be for old watermark, one will be for new watermark. Okay. over here. Then I'll scroll down. So you understood the value of what you should put in timeout, retry interval. I'm not modifying these things. But if you have the fair understanding, I'm fine with it. Then go to settings. So we obviously need a data set to refer to the old watermark, which is there in our watermark table, right? So what I would do, I will have to click on manage and then select link services and then click on new to create link service. Right? Before even creating data set, I need to create link service. What link service I'm creating? I'm creating a SQL based link service, Azure SQL database. Click on continue and then I will select ls underscore SQL underscore source db. So this is something which is maintained by customer, not me. So I will have read access on this. Okay. So when you're trying to put your watermark table, you cannot think about putting that in source database because you have just read access on source database. Now let me try to fetch the server, okay, and the database, source database. And authentication it is asking me, so I know my SQL authentication username and password. So this is Azure SQL, right? So I'm doing it in this manner. When you're trying to connect to on-premise ecosystem, right, and to your on-premise SQL server, you have the prerequisite is to have a SQL authentication because end of the day you are going to put a username and password. You can do that accordingly. I will test the connection to just be sure if the connection is going to be successful, and it is so. I'll create one. Similarly, I will create another link service to point to the target system. Okay, target database. So again, I will say SQL database, continue, and the naming is important. ls underscore SQL underscore target db. Why is it slow? Then select the respective subscription, server name, database name, SQL authentication username and password. Test the connection before creating. Okay. So I will create one more data set. Okay, again refer it to SQL database, then click on this, click on continue, give a name called as ds underscore SQL underscore source db underscore orders. Okay, and then select the link service before choosing the appropriate orders. Okay, click on OK. This is just one part. Then I will go back to the pipeline and will arrange this way. So in the old watermark, as you rightly mentioned, that old watermark will point to the watermark table. Okay, so I will go to settings, select the data set, which is watermark, right? Watermark table. So you can even search it with this filter criteria. And then I will specify a query. Okay, what will be my query? Just observe here. I will go to the target database and I will say where table name equal to orders. This is what I will get, right? And at the same time, I will just name it as okay. I'll just copy this and then paste it in the here over here. Okay, I pasted it and I can do a simple preview to understand if I have done correctly. So you can see, right? I'm getting table name as orders and watermark value as watermark value. Now for the new watermark, I'm going to obviously refer it to the orders table, right? Source DB orders, the first one. And then again do a query. Okay, and then we are going to extract the maximum value, isn't it? So what I would do, I will go to the target database, then select max of insert date time from order state. So I have to do this in source. Okay, I will go to source database. I'll just cut this and paste it in the source database, and let's see what is the result. I'm getting a result, right? So I will also at the same time I will modify the alias because there is no alias currently as new watermark value. We copy this, execute once to cross check if it is fine or not. Yes, it is fine. Go back to Data Factory and paste the query here. Okay, I'll just do a quick preview to understand if it is correct or not. Yes. Now, if I run this, you will be able to see the same thing in the output window. So, yeah, I'll publish and at the same time I will run this. Yeah, click on debug. Yeah, both of the activities succeeded, right? So if I choose the old watermark output, I'm able to see under output, under first row, I'm able to see table name as well as watermark value. Now, if I select the new watermark output, I will be able to see first row and new watermark value. So basically, I got a date range, right? The from date would be this value, and the to date would be this particular value. So I have those contexts in mind. Now the next thing is to execute a copy data activity in an incremental manner. Right? So I will just name this activity as copy orders. And then I will connect these two things, which means only when both of these things are successful, right, it will execute copy data. And I'm doing this parallelly. There is no point that you set this up sequentially, right? Because these two things can be executed in parallel. So go to the copy data activity, select source, and then select the source data set, which is source db underscore order, which we have already created. And then I have to formulate the query. So what is that query? Let's go to the source database. So select star from orders where insert date time is greater than, I will just put for the timing 0101, and insert date time less than equals, and I'll put whatever value is there currently, I'll put that. So I should get all those 16 entries, right? To see if I'm getting 16 or 15. Okay, 15. So I will do 12. Okay, I will get all the 16 entries over here. So I will copy this, the same thing, and paste it in my query window here. Okay, you are able to understand. You would also write the same query language like this, is equal to. But I have to, instead of putting this hard coded, I have to extract it from old watermark and over here from new watermark. So just remove this portion and over here as well. I just want you to be sure that this is the query that we are going to write, right? So put the cursor in between the single quote and then click on add dynamic content, then search for old watermark. Where is that query? Okay, I'll cancel it and then copy it again and add dynamic content, paste it here, place the cursor in between of this quote and then search for old watermark. Okay, before even I replace this, just place a @ and curly braces. Okay, @ and curly braces. Within this, you place the cursor and click on lookup old watermark value. Okay, I have clicked on that. So you can see that activity.lookup.output dot first row. So if you remember, we had a property called as first row. Within the first row property, we had watermark value. And then similarly, place a @ and curly braces and come in between and place new watermark value. And then under output, we had first row dot new watermark value. Okay, just remember what I have done. Output dot first row dot watermark value from old lookup. Finish. And then go back here. Just check the same thing. Output dot first row dot watermark value. For the new one, I did output dot first row dot new watermark. So I'm not remembering anything basically. I'm using what is visible to you all. So I have formulated the source query. Okay. I have formulated the source. Now let me go to the sink. So I have to select the target table also. Right? We have not yet created any data set for sink data set. So click on new and then select SQL database. And then select the link service as target DB. Select the table as orders. And click on OK. So now go to the mapping, import schema. I'll just give a random value because the query expects value, right? The parameters, right? The lookup input, the old watermark and new watermark. That's why I'm providing a random value. And click on OK. It will import the schemas. Yeah, it has imported the schemas right over here. Okay, it has imported all these schemas. Scroll down, make it visible, And then there is one more activity called a stored procedure. This is just to execute the stored procedure. So what is the intention for us? We want to update the watermark value, right? I'll say update watermark value and go to settings, choose link service. To select the stored procedure, you don't need a data set. You just need a link service. So I know that one of the stored procedure is present in target database. I will select one and select the watermark, okay, set watermark. What I will do, I will just showcase you this particular stored procedure, SP set watermark. It is a very simple stored procedure. Want to expand this one.
Hey guys, if you're looking for an end-to-end training in Azure Data Factory, Intellipaat provides an Azure Data Factory certification training for DP200 and DP201, and you can check out those details in the description box below. Now let's continue with this session.
Okay, you can see here create procedure name. It is taking two parameters, which is table name and the new time. Once it is provided, I'm simply using an update watermark table, set watermark value equal to incoming new time parameter, where table name equal to incoming table name parameter. It is a simple short procedure. Okay. Now I will go back and then would click on import to import the parameters of this SP. So now you see, right, both the parameters came in. So what is my new time? The new time is going to be the new watermark value, right? Because old watermark was already loaded earlier. Now because copy data activity executed the orders from old to new. Now I have to update the watermark value to the new one, so that next time when I'm executing, my start date is the whatever is there in watermark. Now what I'll do, I'll add dynamic content and we'll say new watermark. Click on this dot first row dot new watermark value. Click on finish. And at the same time, this table name property is also present in the old watermark output, right? So if you see here, it is the table name property. So instead of hard coding, I will directly pull it from this particular parameter. So I will go back and select the value, add dynamic content, and then we'll filter out to table name. Sorry, not table name, old watermark dot first row dot table name. Click on finish. My pipeline is built. I will publish and will run the pipeline just to be sure that we are having no orders at this point of time, and the watermark table has a value of 1900, okay, in the target region. Now if I run this pipeline, click on debug. Okay, this is in the process of debug. The pipeline is executing. So if you see this queue status, right, what it is doing behind the scene is trying to acquire resources from the integration runtime. That's what it is busy. Okay, so it has actually succeeded, plus the copy data has also succeeded, and watermark value is also succeeded. Now let's see what is the old watermark. Old watermark is 1900, which is expected. What is my new watermark? The maximum value of orders, right, from the source database, which is 11/1/2020. So we had around 16 records in total, right? So if I click on this details button, I am able to see rows read was 16 and rows written is also 16. And it also gives you picture about how much amount of data is read, how much amount of data is written. And then what am I updating? If you see the input parameters, I'm passing this to new value, which is 2020-0111 and orders. So that the query is update watermark table, set new time equal to, set watermark value equal to this, where table name equal to orders. That is what is happening in the stored procedure. Now if I execute this particular first this one, right, what is the new watermark value? That is 2020-0111, right? It is now updated, and I should be 16 orders in total, and I'm able to see 16 orders. Now the incremental problem statement, right? Yes, this is for the first time I'm able to load the data set fully from source to destination. Now what if the customer is trying to insert a new entry here, right? So I will do insert, do orders, values, and I will pass 17, comma, 15, C4, C5, 11, 11, and the date will pass, which is 2020 for this today's date. 21, okay, let me put 2020 only, 01, 12. Okay, just I'm trying to follow the same sequence. I will run this. One row is inserted, and if I run this query rate, I should be able to see 17 records now. The latest record being this one, 2020-0102. Now, without doing anything, I will execute the pipeline. You should be able to see that only one record will be copied, and that will prove the incremental problem data set, problem statement. Okay, let's see what is the old watermark. Old watermark is the old value 2020-0111, which was there in watermark table. And what is my new watermark? Should be 12, right? Yes, it is 12. 2020-0112. And copy data activity, yes, one row was read, one row was written, which proves that it is solving an incremental problem statement. And then it is updating the new time to 12/1/2020. Now, if I execute this order thread, I should be able to see 17 records in total. Yes, I'm able to see. And over here, I will be able to see the latest watermark.
A data engineer is an IT professional whose primary responsibility is to prepare data for analytical or operational purposes. Data engineers design the system that gather, handle, and turn raw data into usable information for data scientists and business analysts to comprehend in a range of scenarios. Their ultimate objective is to make data more available so that businesses may assess and improve their performances. So without any more wait, let's start the session by taking a look at our today's agenda. Why become a data engineer? Learning curve for data engineering, job responsibilities of a data engineer, job scopes and salary ranges, sample interview questions, and finally, future of data engineering. So now let's take a look at our first topic, why become a data engineer? Most businesses have undergone a digital transition in the recent decade. This has resulted in an unthinkable numbers of new sorts of data as well as considerably more complex data being created at a greater rate. While it was previously obvious that the data scientists would be required to make sense of it all, it was less obvious that someone would be required to organize and maintain the quality, security, and the availability of this data in order for the data scientists to do their jobs. In earlier times, it was only the burden of the data scientists to collect, organize, and clean the data even before starting to analyze it. With the storm of completed corporate digital transformations, the Internet of Things, and the rush to become AI-driven, it's evident that the businesses require a large number of data engineers to lay the groundwork for successful data science programs. Companies require teams of employees whose main purpose is to process data in such a manner that values may be extracted. As a result, the function of data engineers will continue to increase in relevance and scope. And with such demand for the role of data engineers in this current digital world, the big shot companies which we are about to see are all lined up in the data engineering investments. Facebook, where the average salary for data engineers are somewhere around 1,75,000 US dollars. Airbnb gives around 1,69,000 US dollars. Capital One with 1,68,000 US dollars. Microsoft with 1,65,000 US dollars. Cisco Systems with 1,60,000 US dollars. Google with 1,27,000 US dollars. AT&T with 1,03,000 dollars. And finally, IBM with 91,000 US dollars approximately. Now let us take a look at our next topic, learning curve for data engineering. Now we'll be taking a look at some of the very basic requirements to become a successful data engineering. Coding. Coding is a highly sought after skill that is required for the majority of data engineering jobs. Many organizations expect candidates to have a working knowledge of programming languages such as Python, Golang, Ruby, Perl, Scala, Java, SAS, R, MATLAB, C and C++. Data warehousing. Data engineers are responsible for storing and analyzing massive amounts of data. That's why, in a data engineering profession, expertise with and experience with data warehousing platforms such as Panoply and Redshift is critical. Knowledge of operating systems. Knowing how to work with operating systems such as Apple's Mac OS, Microsoft's Windows, and then Linux, Solaris, Unix are essential as a data engineer. Data analysis. Most organizations require data engineers to be well versed in analytic softwares, particularly Apache Hadoop based solutions such as MapReduce, Hive, Pig, and HBase. Critical thinking skills. Data engineers must be able to assess problems and then devise innovative and effective solutions. Basic understanding of machine learning. Though machine learning is generally the domain of data scientists, having a fine grasp of how to use this sort of data is beneficial to data engineers as well. Building your data modeling and statistical analysis skills will help you design solutions that others can use, establishing you as a valuable addition to any firm. And finally, communication skills. As a data engineer, you must be able to interact with both technical and non-technical colleagues, which is why excellent communication skills are essential. When it comes to getting a career boost or a career kickstart, nothing comes close to completing a top certified course from a respected source. Hence, let's take a look at some of the top major data engineering certifications, with first one being Amazon Web Service Certified Big Data Specialty Certified Course, Microsoft Certified Azure Data Engineering Associate Certified Course, SAS Certified Big Data Professional Certified Course, the Databricks Certified Professional Data Engineering Certification, and finally, the Google Cloud Professional Data Engineering course. Now, let's take a look at our next topic, which is job responsibilities of a data engineer. Let's look at some of the key responsibilities that a data engineer might come across on a daily basis. Analyze and organize unstructured data, create data pipelines and systems, examine your company's requirements and goals, analyze patterns and trends, conduct complex data analysis and report on results, prepare data for prescriptive and predictive modeling, build algorithms and prototypes, combine raw information from different sources, explore ways to enhance data quality and reliability, and finally, identify opportunities for data acquisition. Now, let's see our next topic, job scopes and salary ranges. Let's take a quick peek at some of the companies who are in great need of data engineers. They are Visa, Accenture, Deloitte, Adobe, IBM, and Mercedes-Benz. The average Indian salary. In India, the salary for a data engineer ranges from as much as 4 lakhs per annum to somewhere around as much as 20 lakhs per annum, with the average salaries coming around somewhere between 8 and 9 lakhs per annum. Now, let's look at some sample interview questions so that it will help you in your interviews. Explain data engineering. What is data modeling? List various types of data schemas in data modeling. Distinguish between structured and unstructured data. What is name mode? What is the full form of HDFS? Define block and block scanner in HDFS. Explain star schema. And for our final topic, future of data engineering. As we manage an ever-increasing number of data sources and data pipelines in data-driven firms, the function of a data engineer will only become more relevant and crucial in organizations of all sizes. Hence, it is pretty much easy to say that the future of data engineering looks quite bright.
Well, we already know that the data engineer's role is one of the top roles to have in this particular decade. With that comes a lot of competition, and where it creates a demand where people are looking for the most proficient data engineers they can find. And this ensures that there are a lot of job openings, which again equate to more interviews and more chances of you guys landing the dream job as data engineers. Well, without further ado, let's begin with this compilation of the top 50 questions that have the highest probability of occurrence in an interview, and you can use this to ace all of your interviews. The questions and answers are both precise and at the same time descriptive enough to help you to add on your own points to the answers as well as answer them to the best of your abilities. So with this guide, we are sure that you can answer all of the high probability occurrence questions in the interview and eventually impress the interviewer and land those jobs. Well, let us begin. Question number 1. What is data engineering? Well, data engineering is a method, it's a technique, and in fact, it's a job role where a person is proficient enough to handle the data and work with data in terms of storing it and converting raw data into useful information. So data engineer is a person who has the ability to maintain the data in the system, work with the data, and eventually store it after the data processing has been done. So coming to the next question, what is data modeling? Well, data modeling is a very simple step of simplifying an entity. Here in the concept of data engineering, you will be simplifying a complex software by simply breaking it up into diagrams. When you think about diagrams in data modeling, think about flowcharts, because flowcharts are a simple representation of how a complex entity can be broken down into a simple diagram. So this will basically give you a visual representation and easier understanding of the complex problem and even better readability to a person who might not be proficient in that particular software usage as well. Coming to the next question, what are the design schemas that are used when performing data modeling? Well, mainly there are two schemas that you must understand when you're learning about data engineering. It's the star schema and the snowflake schema. With the star schema, basically data is spread out in the structure of a star where you have one primary table in the middle and all of the other tables surrounding it are trickled down from the main table. When we have to talk about the snowflake schema will consider a main fact table and multiple dimensional tables, which will again have subtables, as you can see on the right hand side of your screen. So you have one fact table, you have a couple of dimensional tables, and these individual dimension tables can again have n number of subtables as well. So looking at it in a perspective, a star schema is very simple to implement, but then a snowflake schema is more efficient and it will have a better amount of usage in terms of efficiency and responsiveness, which we will be checking out in the next couple of questions. This brings us to the fourth question. What are the differences between structured and unstructured data? Well, we can compare four very important parameters when we are answering this question. So whenever you're talking about structured data, make sure you visualize an Excel workbook, because this will give you an understanding that your data is sorted into rows and columns. It is sorted based on some factors. So that makes the primary difference between a structured piece of data and an unstructured piece of data. A quick example can be a data set, as I mentioned, for the structured data, and it can be any sort of images, videos, or unorganized data in a text file, which can be unstructured as well. When we're talking about how these data is stored, coming to the first point, storage methodologies, we'll be using a database management system to analyze, maintain, and work with a structured database. When it is unstructured data, most of the storage methodologies will depend on that particular application, and it goes unmanaged in many of the cases as well. There are a couple of protocol standards that you must know. We have ODBC, we have the SQL and ADO.NET for structured data, and we have the XML, CSV, SMTP, and SMSM standards for the unstructured data handling aspect as well. When you're talking about scaling the schemas, be it the star schema or even the snowflake schema, in terms of structured data, making your schema into a more expansive state or expanding on the existing schema will be very difficult in terms of structured data. But then if you have unstructured data, you can convert them into schemas very efficiently and quickly and work with it easily as well. So these form some of the vital differences between structured and unstructured data. Coming to the next question. Hadoop is a very important part of a data engineer's role. So understanding all of the tools that come along with Hadoop and in the Apache ecosystem will add a lot of weightage to your candidature. So it is fitting that question number 5 is, what is Hadoop? Well, Hadoop is one of the world's most used framework today for handling big data. Hence, it is called as the gold standard of big data. It is basically an open source framework that is used to perform all sorts of activities such as data manipulation, data storage. It has its own file storage methodologies, and it runs on entities called as clusters. We'll be checking out a bit about this in the next set of questions as well. With that note, moving on to the next question. Question number 6. What are the important components of Hadoop? Well, there are multiple components that you can quote at this point of time, but the 4 most important concepts that you have to tell out is these. The first component is Hadoop Common. Well, Hadoop Common is this very important component of Hadoop, which basically consists of all of the utilities, all of the tools, all of the libraries and sub-frameworks that you'll be using in the Hadoop application. This is very important. And the second thing is Hadoop File System, or as it's called, HDFS. So what HDFS does is it basically provides a distributed file system which will give the application and the server client architecture a high amount of bandwidth, where with respect to big data, you can transfer a lot of data at any given moment, and HDFS provides this advantage to Hadoop users. So coming to Hadoop Yarn, Yarn stands for yet another resource negotiator, and it is basically a very beautifully put together tool which is used to manage all of the resources whenever you work with a Hadoop application. So basically, Yarn provides a resource negotiator, which in turn is a simple scheduler. So these set of scheduling operations will add to the advantages and the efficiency of the system as well. And the fourth and the last important component is the Hadoop Map Reduce. Map Reduce is a technique which is being implemented everywhere ever since the launch of Hadoop. So with Map Reduce, users can have access to a large scale of data and process it very effectively by making use of these two functions, one being the map function, the other one being the reduction function. So these form to be the very important components of Hadoop. Of course, you can add on more components in case if the interviewer is expecting you to know more. In this particular case, make sure that you can emphasize on the other components which Hadoop provides as well. This brings us to the next question. What is a name node in HDFS? Well, do understand this name node as one of the very, very important aspects of HDFS, which is mostly asked in all of the interviews, because name node is an entity in Hadoop which consists of all of the metadata of the actual storage files. What you need to understand is that when you're talking about name node, the actual data gets stored in the data nodes. There's another entity called as data node, and the data gets stored there. But the reference to those data nodes and all of the metadata which describes the actual data is present in the name node. And this brings us to the next question, which is, what is Hadoop streaming? Well, Hadoop streaming is a very beautifully put together utility which is provided by Hadoop to the users in case if there is a requirement for the users to go on to map operations and work with reduction operations at the same time as well. So basically, by performing mapping operations and reduction operations, the user has full ability and flexibility to work with the data and process it in a simplified manner. And this is basically used later to submit it to one cluster where it can be put to use after processing. So this is the state in between where the data is converted from its raw entity into information, and later where data is actually put into use to drive some sort of analytics. Question number 9. What are some of the important features of Hadoop? Well, the first most feature you need to talk about is how it is open source. Since it is open source, it has a community of millions of people across the globe where there are a lot of contributions, lot of revisions, making the tool more effective and easy to use with every iteration and release. And Hadoop works on the basis of distributed computing, parallel processing, and you have to talk about data redundancy a bit. So since Hadoop works on the basis of distributed computing, your data is spread across multiple machines. And what if a machine fails? Is your data lost? Well, the answer is no with respect to Hadoop, because data redundancy is actually given priority here to make sure that all of your data has backups and there is a way to retrieve data in case if it is lost. So this is done by storing your data in separate clusters and actually performing various operations, which we will be checking out in the next set of questions. This brings us to question number 10. Question number 10 seems to be one of the most common and the highest probable occurrence for any question for a data engineer's interview. So it states, what are the 4 V's of big data? The 4 V's of big data involve volume, veracity, velocity, and variety. Well, this is very important that you guys know this. Volume is talking about the amount of data that you're supposed to handle. Veracity is talking about the quality of the data, how much of it is useful information, how much of it is just noise. And then when you're talking about velocity, velocity is all about the speed of arrival at which the data is coming through to the pipeline, and this will give you a clear idea of how quickly you need to process the data. And of course, variety, as the name suggests, is how different your data from each other. So basically, what are the types of data that you are seeing that you need to process here? So with volume, we're talking about the amount of data. Veracity talks about the quality of the data. Velocity talks about how quickly the data is arriving into your architecture or environment. And variety is talking about the various types of data that can be coming through various sources as well. This brings us to the next question, question number 11. What is block and block scanner in HDFS? Well, whenever you talk about a block, make sure to highlight on the aspect that it is a singular entity of data. This means that a block is the smallest entity of data when you're talking about Hadoop and storing files in Hadoop. Because Hadoop does this really nice thing. Whenever it encounters a large piece of file or a huge chunk of file, it will automatically cut it and slice it into tinier aspects. And these tinier aspects are the one we call blocks and block scanner. As the name suggests, a block scanner is actually used to see if the large amount of data which is cut into blocks is actually correct or not. So it checks if there is any loss of blocks when Hadoop goes on to split the data into multiple tiny entities. And this data, as you might have already guessed, is getting stored on the data node. And all the information with respect to the data gets stored in the name node, as we previously discussed. So all in all, the block scanner is used to just verify if there is any loss of any number of blocks whenever Hadoop goes on to split the files. Question number 12. If there are files which have been corrupted, how does Hadoop handle this? Or how does a block scanner handle corrupted files? So you need to understand that whenever data is stored in the data node, there are chances that a file might be corrupt. So the first couple of steps that happen whenever Hadoop realizes that through block scanner that it has seen a corrupted file is that the data node will actually report this corruption entry into the name node. The data node literally tells the name node that I have a file which is corrupted. And then what the name node does is basically it creates replicas of the file which was corrupted. And then this will give you the original file which was unaltered, which is not corrupted. And then basically the name node tells the data node back that the files have been recreated and no need to worry. And the name node eventually tells the data node again after the recreation of the original files that these files have been created. So whenever there is a match with respect to the replicas created and the actual existing files, you need to understand that the data block which was corrupted is actually not removed. So this is one important point you can always mention. Coming to question number 13. So how does the data node communicate with the name node or vice versa? There are two important ways the name node and the data node communicate with each other, and the concept is called as messages because messages are sent in between name node and data node, and there are two types of messages called as block reports and heartbeats which are actually exchanged, and this forms the vital channel of communication in between the data node and the name node in Hadoop. More on this in the coming set of questions. So question number 14. What is meant by COSH or COSHH? Well, this is a very simple abbreviation for classification and optimization based scheduling for heterogeneous Hadoop systems. So what it basically means is that it provides very good amount of tools and methodologies required for scheduling activities which are performed at the cluster level. So this will basically ensure that all of your applications are completed on time now that they have scheduling attached to them and it is not happening in a haphazard way. So this is the basic working of COSH. Coming to question number 15. Again, since we've already checked out schemas, this might be a follow-up question as well. So what is star schema in brief? Star schema, first of all, is also called as the star join schema. Make sure you remember that. And one of the most important things is that star schema is the simpler schema when you're comparing star and a snowflake schema as well. So in the concept of data warehousing, it is a very simple aspect of how data can be stored. And the structure, as the name suggests, resembles a star and hence it's called as a star schema. Your fact tables in the middle and all the dimension tables surrounding it. So whenever we talk about star schema, understand that it will only be used when you're working with huge amounts of data. Of course, you can still use star schema when you're working with a small amount of data, but then it can only be put to use effectively when you're working with large amounts of data. So this question can again be asked, what is Snowflake schema in brief, which could be a follower to the previous question as well. So when you're talking about Snowflake schema is basically star schema version 2.0. Think of it that way, because it is an extension of star schema which has the ability to have more dimensions attached to it. So basically it is a more complex version of the star schema, and it looks like the structure of a snowflake when looked under a microscope. Hence it has the name Snowflake schema. The data in the Snowflake schema is very structured, and it is split into many more tables when you compare it to a star schema, which is performed basically after normalizations. This is done to make sure your data is highly readable and it is effectively stored as well. And then even after this, if the interviewer wants to push you a little bit more on the basic schemas, star and snowflake, here is a table which covers the difference between the star schema and the snowflake schema. So these 4 points are very important, because in the star schema, you'll be emphasizing on the aspect of where dimensional hierarchy is stored. And again, in the case of snowflake schema, that it is stored in every individual table out there. So hierarchy is stored in separate tables in the case of snowflake schema, but in the case of star schema, it is stored in the dimensional tables itself. Star schema involves a lot of data redundancy, while there is low data redundancy in terms of snowflake schemas. And database designing is very simple when you're working with star schemas, but it is very complex to handle a lot of data in terms of storing it and maintaining it when you're working with large scale snowflake schemas. And of course, this ensures that star schema has faster processing, while snowflake schema in some cases, due to its nature, might be a little slower in data processing activities. This brings us to the 18th question, which says, name the XML configuration files which are present in Hadoop. Do note that you do not have to explain on these XML configuration files, but then make sure that you name the files. Naming the files for this question is very important. And there are 4 main XML configurations files present in Hadoop. They are core site, MapRed site, which basically stands for Map Reduce. Then we have the HDFS site and the Yarn site. So make sure you name these 4 configuration files when asked. Coming to question number 19. Question number 19 was again asking you about another very important and interesting aspect of data engineering. So the question goes, what is the meaning of FSCK? FSCK basically stands for File System Check. Make sure you remember this. File System Check is nothing but FSCK. And this is again a very important command which is used to work with when you're using the Hadoop file system. So whenever you go on to use the file check, basically it is performing a check where you're analyzing your data to see if there is any problem in the data, or see if any files are corrupted, or if you have to change anything in the data as well. So this will give the user a first-hand look into the data to see if there is anything wrong with it. And make sure to emphasize on the fact that it is very important to perform file checks, especially in the world of data engineering. This brings us to question number 20. Question number 20 states, what are some of the methods of reducer? Well, whenever you're talking about the map function or the reducer function, you need to understand that each of these entities will have sub methods involved with them. And when we're talking about the reducer, here are the 3 methods which are actually associated with reducer. The first thing is setup. The setup method is basically used to understand what the input data parameters are, and also understand how the data is cached and the protocols which go on to cache the data as well. The second method involves cleanup. Cleanup, as the name suggests, is simply used to remove all of the cache files after its usage, or in the general removal of any temporary files as well. And then when we're talking about the reduce method, so the reduce method is where the actual reduction operation happens. So it is called one time for every key call, and this basically forms to be one of the most important method in the entire aspect and working of reducer, as the name suggests. Moving on to the next question, what are the different usage modes that Hadoop supports? Well, Hadoop basically is used in 3 different modes. The first mode is standalone mode. In standalone mode, the configuration files and the data can be stored on the local machine of the user itself. You do not need to have any sort of distributed architecture, client server architecture, or whatever it is. So basically all the data is stored on the local machine. Then when we talk about pseudo-distributed mode basically is the method of working where the configuration files have to be present in the local machine, but the data can be spread across a distributed system. In a fully distributed system, of course, the configuration as well as the data can be in the distributed environment overall as well. Of course, you do not have to explain on these three modes, but it is always advantageous to tell a little bit about these modes, which will basically strengthen the aspects of the interviewer where he understands that you have put in some work and you know these modes in detail. This brings us to question number 22. Well, question number 22 basically is this: how is data security ensured in Hadoop? Whenever you're working with large amounts of data as a data engineer, you need to understand that your data has to be secure, especially in today's world. So there are 3 steps which are involved when you're working with data security in Hadoop. The first most important step is that you have to create a channel for data flow, and if the channel already exists, you need to secure this channel. This channel we're talking about is the entity which connects your client to the server. And second thing, after you have authenticated the channel, after you have secured the channel, the second step involves the clients making use of something called as a stamp. So this stamp is basically used and received to create something called a service request. Now, this is done to ensure that it is the actual client who is requesting the data and not someone else in their place. And this adds legitimacy to the client, and the server can see this via the stamp. And after which basically is a very simple step where these clients make use of something called as a service ticket, and this service ticket is basically a tool which is used to authenticate the server and respond back to the client as well. So the usage of stamps and service tickets are very important in the concept of data security. Coming to question number 23, this is a fairly short question, but this is again very important that you understand this as well. So what are the default port numbers for port tracker, task tracker, and name node in Hadoop? Well, there are 3 different port numbers associated with it. The job tracker has the default port 50030, where task tracker has the default port 50060, and the name node has the default port 50070. So make sure you understand and remember this in however the best way you find to remember this. But then again, using it twice or thrice will actually help you concrete this particular port number detail into your brain, because at the end of the day, this is something which will come by practice and you will not forget it, to be honest. So coming to question number 24. Well, question number 24 is primarily concerned with respect to the revenue of the company. It states, how will big data analytics help my company increase its revenue? Well, this is a question that you can answer in multiple ways. There is no one set answer that you can have for this, but then here are some of the important things that you can say. In the world where we're driven by data, making effective use of it is basically the entity that drives between success and failure. So effective use of data is very important. And when data is used effectively, it will directly correlate to having structured growth in the company. And then with respect to big data, it is used to drive customer value, and it will ensure that your customer retention rate increases at the same time as well. And you can perform a variety of things, among which one important thing is something called as manpower forecasting. And this is basically used to understand how the human resources are being effectively put to use in the company as well. And this again will create improvised methodologies for human resource management and staffing methodologies as well. And the most important point that you can highlight on is the fact that big data analytics will bring down the production costs in an exponential way, because this is why big data has been put into use in today's world, and the analytics aspect of it is booming since its launch. Just because of this, it will make sure that the production cost will go down rapidly as well. So make sure to mention that. And at our halfway point is question number 25. Question number 25 is concerned with what a data engineer actually does in his day-to-day role. Well, A data engineer is responsible to handle the inflow of information and creation of process pipelines. So a data engineer will sit alongside a data architect to do this, which we'll be checking out in another question. And then a data engineer is responsible for maintaining the data staging areas. He's responsible for ETL data transformations, entity transformations, basically. And then another very important aspect of a data engineer's role is the ability to perform data cleaning and removal of noise, removal of redundancies, or removal of anything which might not be useful in converting the raw data into useful information. Because if the data is not cleaned, it will lead to very inefficient outputs, especially when you're performing analytics. So make sure you highlight on the data cleaning aspect as well. And of course, as a data engineer, it is expected that you have the ability to create very good queries when you're working with any sort of data operations, because it will majorly involve a lot to do with data extraction and working with that as well. So coming to question number 26. So question number 26 goes like this. What are some of the technologies and skills that a data engineer should possess? The interviewer at this point of time could be asking you this question to see if you have understood the entirety of the role of a data engineer. So some of the very most important skills and technologies that a data engineer must have is, of course, starting with mathematics. The concepts of probability and linear algebra have a lot of weightage when you're applying for a data engineer's role. And you need to work with statistics, concepts of machine learning, which can again be achieved when you're working with programming languages such as Python, R, or even SAS as well. And since you're working with a lot of data handling entities, again, Hadoop forms to be a very vital aspect of a data engineer. Working with SQL and HiveQL. HiveQL is very similar to SQL, which is basically the querying language which is used by a tool called as Hive, which again we'll be checking out in the next couple of questions. So make sure to name the technologies and the skills that you think. Of course, you can add on more to this and eventually create a list of your own as well. And with that, we can come to question number 27. I just mentioned data architect a couple of questions ago. So what is the difference between a data architect and a data engineer? Well, a data architect is a person who is mainly responsible for managing all of the data that comes into the organization, basically. So whenever you're talking about data entry, think of this. Data can come from Facebook, it can come from Twitter, it can come from a local storage, it can come from your cloud storage, it can come from an entirely different network, it can come from a search result or whatever it is. So when you're working with big data, the most important aspect is the variety of data and the ability of the data architect to handle the variety of the data. So a data architect is primarily concerned with the implementation of this new data into your own architecture, where it might create some conflicts as well. So how can these conflicts be cleared in a way that the pipeline is very smooth for the inflow of data? And then now the data engineer comes into picture. So basically the data engineer is primarily responsible to work with the data architect in actually setting up and establishing this pipeline. We call it the data warehousing pipeline, and it can be well put together with the help of a data architect and a data engineer. And at the end of it, this will also result in the creation of data hubs, data processing methodologies, and some of the custom protocols which are which are basically required for the working of that particular architecture as well. So this forms to be the basic difference between a data architect and a data engineer. This brings us to question number 28. So how is the distance between each of the different nodes in the distributed architecture defined whenever a person uses Hadoop? Well, make sure you explain on what nodes are and how nodes are scaled across. Whenever you think of approaching this particular answer, the nodes are kept in such a way that there is a distance between them. And with Hadoop, it makes it very easy to assess and find this distance, because it is a very simple sum of the distance between your current node and the node that you want to find the distance to. Instead of doing the calculations manually with Hadoop, as I just mentioned, it gives you the get distance method. And this method can be put to use effectively to basically calculate all of the distances. So the simplest answer to how one can find the distance between the nodes in Hadoop is to basically use the get distance method. So make sure you emphasize on that as well. But then it is always advantageous to mention the manual working of it in case if they ask, which is basically finding the sum of the distance between all of the closest corresponding nodes which exist. So with that, we come to question number 29. So question number 29 states, what is the data that is actually stored in the name node? As I mentioned previously, name node is responsible for having the data with respect to the actual data that you're working with. What I mean is, so basically this is called as metadata, where data is again describing another piece of data. So metadata information is stored in name node, which corresponds to all of the actual block data which is present in the data node. So name node is this descriptor file that you can consider about the actual data being present in the data nodes. And it is as simple as that. And with that, we come to question number 30. Question number 30, what is meant by rack awareness? Well, rack awareness is again a very widely used concept these days, and this question is again this question is highly probable to be asked in the interview as well. Why do I say this? Because rack awareness is something which is really nice. It is a concept in which the name node actually goes on to use the data node, to directly increase all of the incoming network traffic into that particular distributed architecture as well. So what it basically does is that whenever there is any read operation or any write operation that is being performed, there is a rank which is associated to each of these operations. And so whenever a read or a write operation is basically created, there is a rack which goes into that operation, be it a read operation or a write operation. So it is executed in a way where it is the closest rack to which the data access was performed through. So whenever you talk about rack awareness, so it is basically telling that Hadoop architecture makes use of this to increase your traffic by performing operations in parallel and telling Hadoop that it is doing so. So this is a very simple explanation of rack awareness. Whenever we talk about communication in Hadoop, a very common question that they can ask you is, what is meant by the heartbeat message? We already checked out that heartbeat is one of the two ways which is basically used to communicate between the name node and the data node. But then you need to understand that heartbeat is a very important signal which is sent by the data node. So as literally the name suggests, heartbeat is basically the data node telling the name node that it's still operational and that it is still working fine. If there is no heartbeat message sent from the data node to the name node thinks that this particular data aspect is corrupted or it isn't operational. So a heartbeat is literally used to track if the data node is functioning or not, and it is as simple as that. This brings us to question number 32. It states, what is the use of a context object in Hadoop? Well, a context object is used in Hadoop and it is used together with something called as the mapper class, and this combination with the mapper class and the context object basically creates a path for communication. So this is very important because in Hadoop or any distributed architecture in the field of data engineering is where data communicates with a lot of other entities. With the context object, it makes it very easy to understand what the system configuration is, what are the jobs that are supposed to be executed, and the details corresponding to the job as well. So these two form to be the very vital use of context object. But of course, you can also state that alongside these, context object is actually used to send information to certain methods. These methods can be the setup method, the map method, and even the cleanup method that we already checked out. So there is a wide variety of usage whenever one talks about context objects in Hadoop. This brings us to question number 33. Question number 33 states, what is the use of Hive in the Hadoop ecosystem? Well, as I've already mentioned before, Hive is one of the very important tools that is in the Hadoop architecture, which is basically used to provide the user with an interface. So this interface is used to handle and work with the data which is actually stored. Think of it like a database management system, but here we're talking about a distributed architecture. As I've mentioned previously, Hive query languages are very similar to the working of SQL query languages, and these are executed to be converted into the map reduce jobs which actually perform the data manipulation there. So you actually write a query in Hive which is then converted into a map reduce job, and in the map reduce job the data actually gets processed. So this is how you can handle all of the complexity which comes whenever you have to work with multiple map reduce jobs at a single time. And with respect to Hive, it gives you a user interface to simplify all of this to an exponential level. And with this, we can check out question number 34. So question number 34 states, what is the use of Metastore in Hive? Well, so Metastore is a very simple entity. It is basically used as a place where you can store your schemas and your Hive tables. That's it. So whenever you asked about Metastore, make sure you explain it in a simple way and not complicate it. It is a storage location which is used to store the schemas and the Hive tables. So what is the data that gets actually stored? The various mappings in between the data entities, the various definitions which define the relationships or even the data, and such as metadata can be stored in the Metastore as well. And of course, after all of the data is stored into the Metastore, this goes into the RDBMS or wherever it is required and then used as per the application. So with this, you can already understand that Metastore is very vital to be used when you're working with Hive. This brings us to question number 35. What are the components that are available in the Hive data model? There are three main components which are present whenever you talk about Hive. It's basically buckets, it's tables, and it's partition. Whenever the interviewer asks this, there is no strong requirement that you have to explain on the working of the components, but then make sure that you understand and know what these components does. Because if they ask a follow-up question based on the components of Hive, you can answer them easily as well. Now coming to question number 36. Can you create more than one table for every data file? So, or it can also be asked as, is it possible to create a single table for an individual data file when you're working with Hadoop? The simple answer to this question is yes. It is more than possible to create one single table which contains data for a data file, because in Hive, as I've already mentioned in the previous question, all of the schemas get stored in the Metastore. So there's already a structured aspect to how data is mapped and stored. By making use of a single table, it even simplifies it further down rather than the already simple existing model of the Metastore. So this makes it very easy to actually go on to extract the data or extract the analytics aspect of the data whenever required as well. And with this, we come to question number 37. Question number 37 states, what is the meaning of skewed tables in Hive? This is a very, very common question whenever the interviewer asks about Hive, because skewed tables are the entities that are present in Hive where all of the columns or the rows can contain data which is very much repeated. So if your Hive table consists of a lot of numbers, let's say on a simplified example, so here the numbers are repeated a lot. So if there is a lot of repetition in the data that's present in your tables, more the skewness of the table. So a skewed table is basically a table which will have a repeated set of values present inside them. Whenever you're using Hive, the table is actually considered as skewed while creating it itself. Make sure you highlight on this point. If you already know that your table will contain repeated information, you can classify the table specifically as skewed whenever you are creating it. And basically by doing this, it ensures that all of the values can be written into separate file to avoid data redundancy, and later these files which are not redundant can go into a same file. So as I just mentioned, this is used as a structured way to approach the data and to effectively store them as well. So one important takeaway from this answer for you guys is that if the data is more repeated in the table, it is more skewed. So this term forms to be very important here. And then coming to the next question is question number 38. What are the collections that are present in Hive? So collections are nothing but the data types of Hive. So whenever you are asked about collections, understand that the interviewer is trying to ask you about the data types. So there are four main ways Hive can handle data through structured aspects. It is done using arrays. Data is handled using concept of maps. It is handled using struct and union. So again, as I've mentioned in the previous questions, if the interviewer is expecting you to explicate on this particular question, make sure to talk a little bit about all of these individual data types and where they can be best used as well. That is going to add a bit of value to your candidature as well. So coming to question number 39. What is the meaning of SIRDAY in Hive? Well, SIRDAY is basically a short form for serialization and deserialization. So whenever data is moved across Hive tables, we have two operations which are performed. One is the serialization operation and the other one is the deserialization operation. Whenever serialization occurs, so basically the entity which does this, it is called as the serializer. The serializer will take in all of the Java objects which comes to it. It converts it into a format which is understood by the HDFS, and after this HDFS will actually take over completely, and it will ensure that it can be used for the appropriate storage function. So serialization is the basic conversion of the input data into a format which is understood by the HDFS. Now deserializer is basically taking any record which is present in the HDFS and converting it back into a Java object. So this is basically done to help Hive understand what the data actually means. So again, deserializer will basically take your record and convert it back into a Java object to make sure Hive understands what the data is. After the serialization operation, Hive will not be able to understand what the data is, hence the requirement for the deserializer. And with this, we come to question number 40. So question number 40 is concerned with what the table creation functions are that are present in Hive. Well, there are four main important table creation functions that are present in Hive. So they are the explode function when you're working with arrays, explode function of course when you're working with maps, there's the JSON underscore tuple function, and there is a stack function as well. So these are the four functions which are primarily used for table creation whenever you're working with Hive. So make sure you quote these four functions. And then moving on to question number 41. Question number 41 states, what is the role of the .hiverc function in Hive? It can also be called as the .hiverc file in case if the interviewer wants to separate it out and tell you, but then it's called as the hiverc file in general. So what is the role of this particular file? The first important part of your answer should be that this is used for initialization. So whenever you want to write any piece of code for Hive, right, you first open up the entity, which is of course the command line interface. And whenever the command line interface is opened, this hiverc file is the first file you have to load in case if you have to work with Hive, as I just mentioned. So what this file contains is basically all of the parameters that you will have to initially set to work with your Hive model as well. So this forms a very important aspect to tell the interviewer that it's used for initialization when you're working with Hive, and it is one of the first commands that you will put into the command line interface before working with the files as well. And why is it done? It is done to basically set all of the parameters before beginning the work in Hive. Coming to question number 42. So what are args and k-vargs whenever you're working with data engineering aspects? Well, again, this is a very simple question with a very simple answer, but then this is very much important as it is asked in most of the data engineering interviews out there. So the args function is basically, as the name suggests, is the argument function. It is used to define a set ordered function which is basically used in the command line. So let's say you have multiple functions you want to execute on the command line. The args function is basically used to define all of these ordered functions to be used in the command line interface. So coming to the kvargs function, or it's the kwargs function, is basically trying to denote that there are certain arguments that are unorganized, that are unordered, and these are used alongside as the input to a function. So your args function is to basically denote a creation of an ordered function, but your kwargs function is basically used to denote the set of arguments that are basically unordered, and these go into the function as well. So this is the simple understanding of what args and kwargs mean. And with this, we come to question number 43. How can you see the structure of a database by using MySQL? Well, it is very simple. The syntax to understand and see the structure of a database is to describe the database. So to describe the database in MySQL, you have a very simple command called as describe itself, as the name suggests. So describes space table name and of course a semicolon at the end will give you important aspects of that particular table in that database when you're working with MySQL as well. So make sure to write down the syntax, and of course you can give an example as well by creating a table and show how it's described when the described table name syntax is used as well. So now question number 44 states, can you search for a specific string in a column which is present in a MySQL table? So can you search for something which is specific to the name of that column or the data in that column? Whenever there is a MySQL table is another way this question can be asked. So the simple answer to this is yes, because whenever you're working with MySQL, you can find any specific string you require, any substring, and you can perform operations on this easily by making use of the regular expression operator. So the short form of the regular expression operator is regex, and regex is basically used to do exactly this. And with this, we'll move on to question number 45. So question number 45 deals with asking you the difference between a data warehouse and a database. Well, this is a very important question. So make sure to keep this answer very concise and in an efficient manner. So let's begin. So basically, whenever we're beginning with data warehousing, it is the entire focus of data warehousing is to make use of certain functions called as aggregation functions. So aggregation functions are basically min, max, average, sum, difference, all of these functions. And these functions are used to perform certain set of calculations, and you'll be selecting some sort of data to perform processing. So this is the goal of data warehousing. Now, whenever we talk with databases is concerned with more, because here you'll be talking about how the data is input. So how the data is put into the database, how you can manipulate the data, how you can perform certain operations where you're modifying it, you're deleting it, and much more. So a database is concerned with speed and efficiency because data access, data processing, and data storage is happening right here. And then the difference is actually as simple as this, as stated. So make sure to answer this. In the concise way. Coming to question number 46. Question number 46 has a lot of weightage because this could be, in the top 3 questions that will guarantee be asked in any of the interviews. It states, have you earned any sort of certification to boost your opportunities as a data engineer? So whenever your interviewer asks you this question, he or she is trying to find out if you are really interested in the job role that you're applying for. So if you say yes to this answer, the interviewer will understand that you want to enhance and advance your career in this particular field because you've put in a lot of time, you've put in some efforts, you've learned the concepts, and you've implemented them actively. Now, it'll also give an impression that you are a strong aspirer and that you're capable of learning new things and effectively putting those to use as well. This again adds to the third point on your screen that you can see as you being an effective learner. And then one thing you can talk about it is not just what you have done in your certification, but then explain about how you have actually put it into practical use. So whenever you've learned something new, the most important aspect of it is to actually use it. So all the projects that you'll be working on in your certification programs is basically a real life project where you're solving a problem. So make sure to explain the problem that you have tried to solve and explain the approach that you have taken to solve the problem. So this is very important. And if you do not have any sort of certifications, there is absolutely nothing to worry. If you're strong with all the concepts, and if you do not have any certifications, absolutely nothing to worry. If you have it, of course, I'll give you a lot of weightage, but if you do not have it, just make sure that you understand all of the concepts thoroughly in a way that you're establishing thorough contact with respect to the interviewer and proving your worth with respect to this concept of data engineering. And this brings us to question number 47. Do you have any experience working in the same industry as ours before? Well, the answer to this is dependent on the company you're applying for, because again, it depends on that particular company's goals, aims, and what they're actually doing. So if you have any previous experience working in the same industry, make sure you answer this to the best of your abilities, and not just as a yes or no answer, but make sure to elaborate on the previous experience in case if you have had any, and with respect to all the tools, the techniques that you have actually used as well. This will actually add a lot of weightage again, because you're telling the interviewer that you've had industry level exposure to the same industry as in the company that you're applying for. And with this, we come to question number 48. Question number 48 states, why are you applying for this particular data engineer role in the company? So with this, the interviewer is trying to see if you are proficient with your subject, if you understand everything you've learned, and if you can handle all of the concepts that is required to handle the large amount of data that's present in the company. Basically, as a data engineer, you'll be helping to build a pipeline as we have discussed, and you'll be working with the same pipeline as well. So to answer this, it is always advantageous to to have a complete understanding of the job description, to understand what is the compensation that goes with respect to this particular role you're applying for, what are the details of the company, how the company works, and how you can bring the best of yourself to the company. So this last point that I mentioned, how you can bring the best of you to the company, where you explain on that, is very, very important. So answer this to the best of your ability. And again, as I mentioned, there is no one step answer to this, but then this is totally dependent on you, and here is the framework that you can actually use to answer it. This brings us to the last but not the least question number 49. What is your plan after joining this data engineering role? Well, and again, here is my advice: do not start on stories. So again, with this answer, I would like to give you an advice to make sure you keep it concise. Please do not give any long stories, as the interviewer might not have the time or the expectation to hear from you as well, to hear from you in detail about what you're planning to do, because you have not joined the company yet. So, but then it is very important that you talk about how you will put in effort to understand how the data infrastructure is set up in the company, and how you will take part in this infrastructure, either to make it better, to improvise it, and then work easily in collaboration with all of the other members of the team as well. So use this as a fine print to build your answer and then give it out in a concise way. And then make sure you do not give unorganized long answers for this particular question. And with this, we come to the last question, which is again very important if you've had experience in the field of data engineering. So the question is, do you have any prior experience working with data modeling? Again, if you're interviewing for an intermediate role, this question will always be asked for sure. It'll be asked in the beginning of the interview, in fact. So make sure you answer with a yes or a no. And if you're asked this question, there is a good chance that you're applying for an intermediate level role. So do know this. There are two ways to answer this. One, if you answer no to this, you can have proficiency in all of the other data engineering concepts, but not data modeling. So if you answer no, it is completely all right. Talk about data modeling, talk about what you understand by it and how you plan to learn it if you answer no. If you answer yes, then make sure to talk about the tools that you have used to perform data modeling. There are tools like Pentaho and Informatica which are used just for data modeling. So if your answer is yes, make sure to elaborate on this particular aspect of it, and do not worry, as I just mentioned, if your answer is no to it, because you might have proficiency in some other aspects of data engineering that they're actively looking for.
Okay, now that we've come to the end of our session,
If you're having any queries, put down in the comment section below.
and please make sure that you're subscribing to our YouTube channel and hitting that bell icon for further updates.
Just a quick info, guys. If you want to learn data engineering, then Intellipaat provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job.